All right, we are live here on Standing for Truth. I want to welcome everybody to tonight's 2-in-1 debate event. What we have here is another debate followed by evolution open mic challenge to anybody who would like to join for impromptu debate and discussion. The topic, evidence for evolution. It is a privilege to have both Luca Medugno and Dr. Dino here to start us off, kick off the night with about an hour worth of debate on, again, the topic of evidence for evolution. So, Luca, it's been a little while since you've been here. So, why don't we start with you just in terms of introductions? So, Luca, how have you been? And a little bit about yourself.
Yes, I'm more than fine. I work as a teacher in Italy, elementary school teacher as for now. I'm very, very busy in this moment. Teaching to kids require a lot of time, so I do not work too many hours, but I'm quite far from my workplace, so it's quite hard to have hobbies as for now. But I do have a channel and I want to post more. As for now, it's a mess, but I will do better. So that's me. I do have a degree in chemistry and I'm quite a veteran on debates. I bet that a lot of people know me in the chat. So that's me.
Very good, Luke. I appreciate the intro. This is definitely not your first rodeo. You're not a stranger to debates, as you've now engaged in plenty, which means we have two experienced debaters, because Kent knows a thing or two about debates, as he's done well over 300. And Kent, we're going to get you to number 400 very soon. And so, Kent, how have you been? A little bit about yourself and a little bit about Dal.
All right, I'm having a little computer problem here. According to evolution, things should get better automatically, but it's not working, so I'll fix it. Anyway, my name's Kent Hovind. Let's see, I've been a Christian since I was 16. I gave my heart to the Lord, and I've been an ordained Baptist preacher for 49 years. I taught high school science and math for 15 years and 3 years in college. I believe the Bible is literally true and scientifically accurate. God made everything in 6 days, just like he wrote down on the 10 Commandments with his own finger. And we have a Christian camp and science center here in Lenox, Alabama, straight north of Pensacola, called Dinosaur Adventureland. It's all about dinosaurs in the Bible. God made everything in 6 days. Dinosaurs lived with Adam and Eve and with people all through history. Might be a few still around. Man has killed most of them, calling them dragons or some other name. We believe the Bible is true, and evolution is the dumbest and most dangerous religion in the history of the world. And it's a religion. You have to believe in evolution. There is no scientific evidence of any animal ever producing a different kind of animal. You have to imagine it. Doesn't happen. Oh, anyway, I look forward to the debate. Thank you.
My pleasure. I'm thrilled to have the both of you, Luca and Kent. For those that want to see more from our guests, do check the description box for their relevant links. If you want to find all of Kent's debates with us, he's done just about 100 over the last couple years. Check the website under Dr. Dino, and you can find all of those listed. You can also find all of Luca's debates on the channel as well that he's engaged in here. And so, Luca and Kent, thank you so much for the introduction to the audience. Yes, again, we are doing an open mic tonight as well. And so at roughly the 45-minute mark, what I'll do is post the StreamYard link in the chat. And those that are interested in joining, make sure to click the link. We do want to keep it on one topic at a time, one point at a time, equally timed, and of course, professional and cordial. Okay, with that, we're just going to hand it over to Luca for your first point.
Yes.
And your first argument, and then we'll go from there. Luca, the floor is yours.
Okay. Can you see my screen? Okay. So,
yeah.
What's my point? When I prepared this debate, I had a question. How can I show evidence for evolution? Because, of course, there is a problem. Evolution does happen very, very slowly. So I do need some evidence that's easy to see, and that's also in here and now, basically. What I did choose atavism. Why? So we will discuss evidence in the present, and we will talk about atavism. What we are talking about, that's quite a good image of an Italian museum of a very peculiar guy. Maybe I will talk about it a little bit later. So atavism is a modification of our structure that brings out evolutionary traits that are no longer present, basically. So I want to bring some photos. Here you can see a dolphin with hind flippers, and it's quite a good thing to discuss, a very interesting thing to discuss. Why we do see things like that? Why dolphins have these kind of things? And also a very wonderful example, chicken with teeth. So it's a mutant, but it's not like they created a chicken with teeth from nothing. They just repaired an old gene. Also, you can see a deformation of a feather from an alligator. So that's quite a good point, in my opinion. And I will also show those two things. Goosebumps and on humans are basically not useful at all, and an human embryo with a tail. Why it's important for me? Because we can see those traits right now, right there, and I want to make you all think about it. Why we do see these kind of things in animals, in us, and what does it mean? So I can stop there for my first part.
Okay, Luca, thank you very much for that presentation on argument one, atavisms, and appreciate the visuals. Okay, we're going to hand it over to Kent. Kent will give you an uninterrupted response, and then what we'll do is go back and forth in discussion on our first topic for tonight. And so, Kent, whenever you're ready, just make sure to unmute on your side, and the floor is yours.
Okay, well, thank you so much. All of his arguments were based on the assumption that evolution is true. He's already decided evolution is true. Now, how do we prove it? I think if you'd back up and open up your brain, you'd say, well, does this evidence show evolution? For instance, you talked about atavism, the skull shape changing, and you said it gained back something that it had lost for generations. How can you possibly know it lost it for generations? We've only been around for 1 or 2 generations. We've only got recorded history for a few thousand years. Nobody's ever seen a human produce a non-human or a monkey produce a non-monkey. Why would you compare their skulls and think it means something? Could it also mean a common designer? It is a cool design. You got the bones of the head to protect the brain, and it's able to move and turn around and take a beating once in a while. So maybe it's designed. But see, Luca, you've already decided evolution is true, and you don't seem to be able to think outside that little box. You mentioned about chicken having teeth. First of all, those are not real teeth. And if the chickens ever used to have teeth and they lost them for today, that's an example of losing something. That's not gaining something. Where are the examples of any animal gaining something? Because according to the evolution family tree, they say, oh, we all started off like an amoeba, and the humans and the birds and the reptiles and the ladybugs and the worms all had a common ancestor. Well, that common ancestor was supposedly a single-celled creature of some kind, an amoeba or a protozoa. How did it gain teeth at all? Protozoa don't have any teeth, or arms, or legs, or hair. It would have to gain trillions of traits to become all these different things, and we don't ever see that. All we see is animals bring forth after their kind. Amoeba make baby amoeba every time. There are no exceptions. If you wish to believe the amoeba turned to a human over millions of years, that's your religious belief, but that's not part of science because it's not observable, testable, demonstrable. You mentioned about the goosebumps. Well, the goosebumps, it's a little sphincter muscle around each hair of your body that makes the hair stand up and traps a layer of warm air against your body, like putting on a blanket. They're handy, they keep you warm. Goosebumps are not evidence of anything other than a cool design. I think God designed us to have, you know what it would take to get one muscle in the nervous system to control it and to make a hair stand up would take an awful lot of genetic code. It has to be designed. And it's not that it doesn't serve a function. Somebody might say, well, you know, some animals with more hair have goosebumps and their hair stands up to insulate them. Well, it's true. There are some that have more hair that works as a better insulator than ours. But that's not evidence of any relationship. It's still a cool design, and it still works good. When you get cold, your hair will stand up because of a little tiny sphincter muscle around each hair. The genetic code to do that would be phenomenal. And the nervous system, the interaction between all the nerves for your body to sense the cold, send a message to the muscle, tighten up, hold the hair erect to trap a layer of air. That's a really complex system. It didn't happen by chance, and we're not losing it. Okay, some animals have more, some have less. That's not, you're assuming evolution is true. And so we can look at animals that have more and think we came from them. Then you mentioned the human tail. I am sorry, Luca, but that is simply propaganda. I covered this in embryology. One of the evidences they try to use over and over, which you're using here, is that the embryos of different creatures look like something else during their embryonic stage. They talk about the gill slits or the tail. These are the two most common ones. Those are not gill slits. Those little bones, folds of skin develop into bones in the ear and glands in the throat. And the embryo does not have a tail. It's just not done developing yet. That's going to be the backbone. The backbone grows first, then the leg buds start off, and what looks like a little tail there is still there. It's just much smaller. You have a tailbone. I tell people there are 9 little muscles that attach to those bones, and if you think the tailbone is not necessary and vestigial, I will pay to have yours removed. You will quickly discover you need that, okay? So don't tell people the tailbone or the tail on an embryo is evidence for evolution. First place, the guy who made up all this stuff in 1869 lied, Ernst Haeckel. He faked the drawings. There's the drawings of what they really look like. Here's his fake drawings to make them look just alike. There's a chart. They're using all this in the textbooks all over the world. Haeckel's fake drawings on top, the real photographs underneath. He lied. They don't have a tail. The backbone is not fully developed yet. It has to start somewhere. What if you took the embryo when it's first fertilized, then it's a round egg? Oh, wow, everybody's round. No, it's a developmental stage. So I'm sorry, none of what you gave tonight, and it convinces me of evolution, but it shows me you've already decided evolution is true, and you want to believe it for whatever reason, and therefore you're forcing the evidence to fit your religion. That's sad. Okay, go ahead.
Okay, thank you very much, Kent, for that response. Luca, we're going to hand it to you. And what I think would be a good idea is to now, since we've got a few different points on the topic in relation to our main topic that we're focusing on. And so Why don't you pick a point and we'll go back and forth on it.
So it's a fun thing. It's perfect. Now I have my second point, and I will make my third point as a conclusion to wrap up the discussion. So it's perfect. So yes, very good argument. So I already on the evolution side. Well, yes, I am, but not just because I think that it's true and just like that. I do have my reason to think that evolution is actually a thing. But let's see a little bit. I will show a little bit more of my slides. Okay. So,
You're good, Luca.
very good. Those were atomic. So, yeah. Those are two and vestigial structure. Second point, and I have just a couple of examples for this. Muscle on human ear, it's basically useless, and right now, because back then was useful to direct the sound, to hear better. And in some animals, they still are working those muscle. Why we do have those kind of muscle in our ear? It's basically useless right now. And another thing, the emu wing claw. Why it's important? Because it's a claw that's not a wing. It's a small, tiny arm with a claw. So it's not useful for nothing. And it's basically an arm on a bird. And it will be important later for my point. Why it's important? Because we do have a structure in this bird, the emu, that's not typical to birds. Of course, birds do have wings that are arms adapted to flight, but this bird does not have it. It has a small, tiny arm with a claw. So, that was my second point, and I will give my conclusion as the last part. And of course, it's not like I cannot change my mind. I need evidence to change my mind, and I want to engage in the discussion. I'm bringing to you photos and things we can observe right now, because it's what you asked from me, to bring evidence, to talk about science, and it's what I'm trying to do.
Okay, Luca, I appreciate your follow-up response to your first point. Kent, we'll hand it back to you, brother. Whenever you're ready, go ahead.
All right. Well, thank you, sir. Well, Luca, all of the evidence you have presented so far, it would be under the category of vestigial structure, something you don't need anymore, according to the theory. Again, that's losing. If the emu used to have wing claws that were useful and now they're not useful, that's losing something, not gaining something. If the humans used to have more muscles in there, I know people who can control their ear and wiggle it around and wiggle their ears. Can any of you wiggle your ears? Let me do that. There you go. Got one in here. It's rare, but it happens. So the muscles in the ear, again, that's an example of losing, not gaining. You have to give trillions of examples of things being gained. And this not only just in the application when it comes to the body, but in the gene code to make it. The genetic code to make those muscles for the ear would be phenomenal. Just the genetic code to make a claw on an emu. We've got 3 emus here. We had 4, but one wasn't very friendly, so he ended up on the Thanksgiving dinner table. But now we know we had 4. Yeah, now we have 3 left, okay? And they're friendly. Yeah, they know they better be. So do they have a wing claw? Sure. Does it do anything? Not that I know of. Maybe they know of something. Maybe they use it to scratch their buddy's neck or something. I don't know. But if they have a useless claw, that is losing, not gaining. All of the evidence from vestigial organs can be put in a box and say, none of this is going to help the evolution theory. It's not gaining. Your charts show that they went from an amoeba to a human. You have to gain a whole lot of stuff to go from an amoeba to a human. And I'm glad that you're not locked in and you can change your mind. But all the vestigial structures, usually they say the whale has a vestigial pelvis. I covered that last night. Here's one of the whale bones right here. It's not vestigial. It has a blood supply, nerve supply. It's part of the whale's reproductive system. He has to mate underwater in the dark with no arms, and he can't talk and say, scoot over. He's got a 15-foot penis to maneuver around. He has to have special muscles and bones to allow it to get where it needs to go. That's not vestigial. It's not losing anything, okay? He's glad he's got them. This is a snakeskin albino python. Some people say that at the tail end of the snakeskin, there are claws, and that is correct. And they say, look, that's proof the snake used to have legs. No, those little claws, again, are used in mating. Snakes also can't talk and don't have any arms. They have to have claws. That's part of their reproductive system. It's got nothing to do with evolution or gaining a leg. If it's anything, it was losing. But actually, it's not even that. It's perfectly fine as is. They say humans have a tailbone they don't need. Well, that's just propaganda. I'll cut out your tailbone if you think it's unnecessary. I'll even sharpen my Swiss Army knife to do it, okay? They say the coccyx has no present function. I want to see crybaby's tailbone removed. Okay, yeah, me too. There are 9 little muscles that attach to that little bone system, they're the tailbone, and they allow you to defecate properly and make babies properly. It has nothing to do with walking on land and nothing to do with having a tail to hang on a tree branch. It's just part of the coccyx has several important functions. So I'm sorry, Luca, all of your evidence so far tonight with your photographs is demonstrating that you don't have evidence of anything being gained. If they're anything, they're things that are being lost, not gained. So, third point. Go ahead.
All right, Ken, thank you for that response. Gentlemen, I like this.
Okay.
I like this format and structure. And so, Luca, let's hand it over to you for your third point.
I want to make my conclusion, and I think that will be fun. So, yes. Okay. We are good to go, I think. Okay. So, last part of my presentation. So, I will have to adapt. Okay. Conclusions. I have some questions. Why would you see such characteristic in animals? If they are created, why they are created in that way? And what evidence suggests? And that will be the end of my presentation, more or less, but it's not. I do have a little treat for you. So we did discuss about evolution, and Kant is saying that losing something can be acceptable. So it's losing something. For him, it's good as evolution to change over time, losing something. Here you can see a emu skeleton and a velociraptor skeleton. Why it's important? As you can all see, the emu has a tiny arm, is basically useless, but it does have a tiny arm. Of course, those are bigger, but to get from this, from that, it's just losing. So it's not a problem for Kant. The tail. Here we have a very big tail. Here it's a very small tail. It's just losing. It's not gaining. Teeth, there are no longer there. It's just losing. The only thing here basically that the emu is gaining is the beak, but some dinosaurs did have beaks, so it's not like we cannot prove that they have those. So for tonight, I'm very, very happy to say that me and Kent, we do agree. Dinosaurs and birds are the same thing. It's wonderful.
Luca,
So,
very sweet of you to bring us a treat tonight. And so thank you for your third point. Oh,
wait,
if you're not finished, go ahead. Yeah.
Yes, you did see the bird and the dinosaurs.
No, we saw it.
Okay. Very good. So I'm very happy. Me and Kent, we do agree on something.
That's good
That's
that we
good.
got some agreements in the house tonight for this debate. Okay, Kent, back to you, brother. Go ahead.
Well, again, his entire argument is vestigial, something that is being lost, and he's assuming that birds are related to dinosaurs, and they're not. They have some similarities because they have the same designer. I've had quite a few cars in my life. I've never had a new car. I've had many cars that were, when they were manufactured, probably everything worked, and by the time I got it, some things stopped working. How many have ever had a vehicle that it had an air conditioner, but it didn't work? Ever had one of those before? Okay, sure. What does that prove? It lost a function. You can have a car that has power windows and the windows don't work. Okay, well, that's not gaining something. So what you've shown is some animals seem to have lost something. I believe in the perfect original creation, they may have had some function and now they may have lost it, because we are a copy of the gene code of our parents. They are a copy of the gene code from their parents. How many generations can you go back copying this code? This incredibly complex code, you copy it over and over and over and over and over. It is likely to have some mistakes creep into the copying process. Make a photocopy of a picture and then make a copy of the copy. Do that about 40 times and it's illegible. You can't tell what it is. So we're probably, I don't know, the 300 or 500th generation from Adam. You guys want to believe we're the 10 millionth generation from a chimpanzee or something. To copy that code that many times is insane, to believe it could even transmit data at all. The fact that we're still able to sit and stop and talk and think and talk about it is amazing, that we're a copy off a copy off a copy off a copy of Adam. So I think that all you've given is examples of losing. And if indeed General Motors produces a car that has all kinds of special features, and after 25 years, some of the things don't work anymore, that's normal. That happens all the time. The example of the dinosaur losing its front arms to become wings. Well, that's your imagination. You don't know that they're even related at all. And the fact that it had a big, heavy tail, and now the emu has a small, we have emus here, the fact that it's got a smaller tail, it does not prove any relationship. But your evolution theory says everything is related. You make these charts with all the animals connected, the humans, the pine trees, all going back to a common ancestor. This is propaganda. This is not science. They show the kids the protozoa slowly turned to a human. All they did was draw lines on paper between different things. And all you did was put two pictures up of a dinosaur and an emu and assume there's a relationship, and one turned to the other. You gave no evidence that one turned to the other. All emus today make baby emus, without exception. All reptiles today make baby reptiles, without exception. You have to imagine that evolution happened. It's not scientifically observable. And putting up two pictures on the screen, I got pictures right here. Look at that. We have a bird and a frog on the same picture. That proves they're related. There's a line between them. No, it doesn't. Science is what we can observe, study, test, and demonstrate. It comes from the Latin word "seer," to know. What do we know? We know frogs make baby frogs. We know that. You can see it happen. We know birds make baby birds. You can see it happen. If you wish to believe they're related, that's not observable. It's not science. And thank you for being up at 2 a.m. for this debate, Luca, over in Italy. Get some sleep if you'd like. Just give up, get converted, and become a Christian, and you can go to bed. All right, see you tomorrow.
Thank you, Kent, for that. Luca, we're going to hand it back to you now. So since you go ahead, Luca,
I
you're the
want to
boss.
say something to Kent. So it's not like I did show that emu and velociraptor are related. What I did show is that in your model, you can get from a velociraptor to something similar to a emu in your model, because it's losing the tail, is losing, not even losing, they become tiny arms. It's not even losing. Emus still have tiny arms, so we can see that is losing those big claws and things like that. But in your model, it's okay to say that you can get from one point to another in your model. So what's the problem with the evolution? Dinosaur to birds. I cannot get it.
Okay. The problem is, in my model, all of the observed scientific evidence shows degradation of the gene code. It's degrading, it's losing. But in your model, it shows everything being gained. And we don't see that. It's not observable to see an amoeba change to something else. We don't ever see a protozoa produce anything other than protozoa. They might have a generation time of 8 hours. They get born, grow up, get married, have babies in 8 hours. You can have 3 generations in one day. A scientist could watch thousands and thousands of generations. And all we see is they still produce protozoa. So why on earth should we teach the students the protozoa turned to a human? That's not science. It's a religion. You believe in it, and you might believe in it very strongly, and you might convince a lot of other people to believe in it. You could convince the whole world to believe in it, and it wouldn't make it true. Hitler convinced a whole bunch of people Nazism is true. Stalin convinced a bunch of people communism is good. This has been the history of mankind. People believe something, and they convince others that it's true. Jim Jones convinced 900 some people that the world's going to end, and they better drink this poison Kool-Aid, and they did. It doesn't mean he's right. He just convinced a lot of people. So you guys have an excellent propaganda machine to convince people that these charts are science. I'm just saying they're not science. We never see a protozoa produce a non-protozoa. We see protozoa degrade and lose genetic code where they die and they can't reproduce babies. So I'm sorry, the difference between my model with explaining clearly why things can be lost and your model explaining why things can be gained, the difference is we've got evidence of things being lost, like the heater not working on a car or the air conditioner not working. But you don't have any evidence at all of anything being gained. You have no reason scientifically to draw these lines on this paper. And all these charts is artwork. They're not science. We never see protozoa turn to biology teacher or anything else. But you wish to believe you're related to a jellyfish. I usually ask my people, Luca, do you believe you're related to a jellyfish?
So, to be clear, what I did show to you, Velociraptor to emu, it's still viable in your model. It's only basically losing something. So for you, it's okay to get from the Velociraptor to emu. And that's evolution. That's dinosaur to birds. Also, on the degradation of the DNA, I have a very good example and a very good opportunity for you and for every creationist here. We do have Otzi. I did bring that guy out last time I was on the channel. So we do have this man. He was frozen for thousands of years. It was found in Italy, and we did find his ancestors right here in Italy. So if you want to show to me that the DNA is degrading, just study that case and show to me how the DNA is degrading, because I did ask and I did not have a good answer. So if you can do that, you can basically convert me.
Well, thank you, sir. I don't have the details in front of me about the so-called Iceman they found in a glacier in Italy. Did they know right away it was a human? Okay. How did they know that?
Yes, it's not the problem. You are saying that the DNA is degrading. Very good. I did give you an example, a practical one, with a corpse. We do have a very well-preserved corpse. We do have his ancestors, so you can, you or someone else, I don't care, show to me how the DNA is degrading. you can show me with data and why
Okay.
is degrading and how is degrading. And I cannot ask that from you right now, but someone can do it. And if it does, I will give my point and say that I was wrong.
Well, from what I recall of reading about the Iceman, it was 100% human, obviously a human. Now, did they check the DNA compared to our DNA? I don't know.
It was, but it's not my point. My point is it was a very old human, 5,000 years or so. So you will be able to see the degradation if it's happening. That's my point.
Okay. Well, things don't always degrade. You might buy a car and 40 years later, everything still works. Could be. You might buy a new car and 10 years later, you have to put it in the junkyard because everything quit working. Okay. The Iceman may have a genetic code that's similar to ours today, but have we gained anything over what he had? He probably had 2 arms and 2 legs and 2 eyes and 2 ears, just like we have. So I don't think you have any examples of anybody or anything gaining new information. The emu might indeed be losing his claws for some reason. I don't know. We got emus here. I'll find out. I'll ask him. Okay. But the Iceman only demonstrated that humans have always been humans. And so you may have, it may not have degraded. You might buy a car that stays fine for 100 years and everything still works. Okay. You got lucky. Usually, though, they end up in the junkyard after 30 or 40 years. So I don't think you have any examples of new information being added, only information being degraded. And that's not evolution. That's the opposite of what you need for these crazy charts. These charts show things changing to other stuff, and we don't see that happen. This is nothing but artwork. Lines on paper is all it is. And you guys want to call it science, and you want to make it required that all kids learn this in school as if it's part of science. I object to that. I think it's a religious belief. Evolution should be taught in a religion class, not a science class. There's no evidence of any animal gaining new information. Just the gene code to make your finger bend like this would probably take up hundreds of pages of typed information if you put it in computer code. The genetic code of one human, if you took all the DNA out of one cell, tied it together and stretched it out, it'd be about 6 feet long out of one cell. Human beings have about 100 trillion cells. They say if you tied all your DNA together from one human, tied it end to end, it would go across the solar system twice. From here to Pluto, if you think Pluto is still a planet, okay? If it actually all the way across the solar system, twice. That's the DNA code to make a human. I don't understand how anybody can believe it happened by chance. We don't see anything gaining new information. To go from an amoeba, which has no arms, to a creature with arms would require, or from a protozoa, would require a whole lot of new information. Protozoa don't have fingernails. They don't have bones. They don't have knuckles. They don't have a nervous system that controls all these bones and muscles. How can you believe it gained all this information by showing me examples all evening so far of things that are losing information? Go ahead.
Well, yes, I did show, well, it's not like they are only losing. I did discuss this kind of things, and I was trying to bring actual evidence that you will accept. My point was different. Dinosaurs to birds in your model is feasible, and you did not disprove that. On OTSI, it's not like I'm trying to show that we are gaining something. It's not my point. In your model, we are losing something, and you should be able to show me what we are losing. I'm trying to give you a way to show me that you are right. I'm trying to prove your points. And as for now, I do not see any evidence to say that they are right. they are good points. I'm trying to help you because I want to have an actual discussion. I can bring other points, how we can get new things. I did with cows, with wheat, and so on and so forth. We did have quite a lot of debates, Ken. So it's not like we are at our first rodeo. I'm trying to have a discussion. I'm trying to give you the opportunity to show me that your points are valid. Your points, not mine.
Okay, I think I answered that. In the creation model, we would expect everything was made perfect. We are now a copy off 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 a copy of Adam. And the fact that we can still think and talk at all is amazing. The original gene code must have been phenomenal. And to see that after thousands and thousands of generations, the copies are still working is phenomenal. I think that's amazing. I think either they're going to stay steady or they're going to lose. But in your model, they have to gain, and you haven't shown any of that. Are there any reptiles that need to run fast to get away from predators? Are any growing wings? They could sure go faster. Why don't they grow a wing? Is there any animal that has a nascent organ as opposed to vestigial? Nascent would be slowly gaining something. And the answer is no, none have ever been demonstrated. I'd like to have wings. There have been times I need to go faster, be able to fly. It'd be nice to have a tail. Why on earth would we lose a tail? That'd be handy. Open the door and hold a can of Coke and the groceries at the same time. That'd be handy. So I think the idea that we lost a tail coming from a chimpanzee to a human is, again, example of losing if it happened. And it's not helping. Are any humans today growing tails that they can use, prehensile tails? No. But it'd be awful handy to have. I bet a lot of soldiers on the battlefield would like to have a third arm. Throw the grenade while you shoot your rifle at the same time. So it doesn't happen. It's imagination. That's been my point for decades now. Evolution is something people believe in. You believe these examples of losing and losing and losing is going to explain your chart within a protozoa turning to a human and a bird and a frog. It's not observable. And I wish I could get you guys to admit it's something you believe in, you have no evidence for. Then we could say, okay, good. Believe what you want. I don't care what kind of church you go to. There's all kinds of different churches. They all argue about everything. They all think they're right. And evolution is another religion, and they think they're right. Only they have somehow gained control of our school system, and now we all have to pay to support one religion. I think that's wrong. Donny, you said we're going to have a lot of Q&A from the audience. We're going nowhere here on this one, but go ahead, whatever you think.
Let's do this because I do got people backstage. Actually, I put out the StreamYard link about 10 minutes ago. And so we do have people ready for the open mic. Luca, in order to conclude the discussion on your three main points, is there anything you'd like to follow up with in terms of the arguments we've been going back and forth on?
Yes, I would love to have someone working on the example I gave, because it's very important. When you do a discussion, when you do science, you try to prove your points. Kent asked to me evidence for gaining information. I did give those in my previous debates. Corn was one. Wheat, it's a very good one, is gaining a lot of genetic material, is bigger, better than his ancestor. And we know what those ancestors are because it's in our history. We do find historical evidence for the evolution of wheat. And that's an example. I gave you a lot of examples. Tonight was not about that. I was trying to show and give you the opportunity to prove your model. And that's the point of tonight. I'm showing to you and to the people in the chat evidence in the right here and now. And it's important to me to have an actual discussion.
Okay.
That was the point of tonight.
Okay, let's hand it back to Ken if he'd like to address the corn issue, and then we'll slowly move into maybe a couple minutes of concluding statements each, and then we'll bring in people for open mic. Kent, floor is yours.
Over many hundreds of generations, farmers have selected corn from maize that has little tiny seeds. They kept getting the ones with bigger kernels, crossbreeding those. This is an example of selective breeding to gain a desirable, what they think is a desirable trait. We now have the modern corn, which is huge compared to the original maize that it came from. It's a result of selective breeding. They did not gain anything. The maize already had seeds. They selected for the larger seeds. Same thing with the wheat. Now, 200 varieties of wheat. They probably had a common ancestor called wheat. You could do the same with the 4,000 kinds of potatoes. People have selectively bred to get a particular trait that fits their environment. Some animals do better in cold weather, thick fur. Some do better in hot weather, thin fur, long legs, like the dingo. It's selectively breeding. Farmers have selectively bred cows for a long time to get now, a bunch of different varieties of cows that had a common ancestor called a cow. They've never added information. The cow never got wings. All they've gotten is a variety of already existing gene code. They didn't put anything new in the gene code for the corn. Corn did not add any genetic code when it came from maize. It selected corn seed. They already made seeds. It selected the bigger ones. That's all it did. So I'm sorry, corn and wheat are not examples of evolution. And same with the cows or dogs. They're examples of artificial selection, producing something that the farmer wants. Great, wonderful. But it's not adding new information. Sorry, go ahead.
Luca?
Yes, wheat is, it does have much more genetic information. Someone in the chat was telling the right answer. It's polyploid. So it has 3 times the genetic information of acorn, for example. So yes, and I did bring this kind of evidence. It was not last time. It was one of the first debates. So yes, we do have more genetic information. It's not like we do not.
Kent, would you like to respond at all, or?
I'll have to do research and get the data to show that's not correct. I don't have it in front of me here, but let's go on to the next point, I guess. No, okay. I stand my ground. They selected a trait maize already had. It already made seeds. They're still making seeds. They're just bigger. That's all. They didn't create anything. Go ahead.
Luca, did you want a follow-up point?
For me, it's okay to move to the open mic part. I think that it was a good discussion, and I will be waiting for someone to engage me on the things I did brought up in this debate. I will love to.
Okay, gentlemen, Kent and Luca, appreciate the first roughly hour worth of discussion. And so we're going to jump into now an hour of open mic debate. And then as Kent leaves at the 2-hour mark, we may stick around for a little bit more for some extra open mic. Okay, so with that, before I start bringing people in, I do want to make sure, as always, the open mic remains professional, cordial. We're going to focus on one point or one topic at a time and keep it as evenly timed as possible. And so basically, let's keep it very similar to what Kent and Luca just demonstrated. Very good back and forth discussion, gentlemen. Okay, so we'll bring in, so Brian was the first on the panel. And so, Brian, let's start with you, as you are a creationist, unless you've converted to evolution recently, which I doubt it. And so, Brian, good to have you. Quick introduction, and then if you had a question for Kent or a question for Luca, go ahead.
Am I coming in good?
Yes. Yeah.
Awesome. All right. My name is Brian. I have a YouTube channel called Apologetics 101. Of course, I got an ongoing Genesis series that's going on right now, as you know, Donny. I actually have a question. I have two questions, one for Kent and one for Luca. I'll ask mine for Dr. Kent first. On claims of alleged bird evolution, they claim to have found fossilized dinosaurs with I think that they're claiming that they're like proto feathers. I don't know exactly how they describe it, but essentially that they interpret them as fossilized dinosaurs that had feathers. How do you understand that, Kent?
I think it's been debunked years ago that they just simply had collagen fibers peeling off. As the collagen decays, even scales, as they decay, they will flake off one line at a time, or sometimes many lines sticking up. There's certainly not anything similar to a flight feather. A flight feather is incredibly complicated. So I think it's just simply degradation of the creature that died and began to rot. And it's I think they're collagen fibers peeling off. I think that's been demonstrated. I would check icr.org. They have great articles on that, or answersingenesis.org. That's been answered years ago. It is not growing feathers.
Right. All right. I have a second question for Luca. You showed two pictures there. I came kind of late in the discussion, but I remember you showing two pictures of a bird and a dinosaur, and y'all were talking about vestigial organs, and the bird I guess had smaller arms or something like that. I can't remember, but the dinosaurs, of course. I think my question is this. Well, let me split this up into two questions. One, do you not see evolution as a forward progression? Like that you moving forward, that as you do so, I guess as things are adapting to their environments, as as natural selection is taking place and mutations, do you see this as a forward progression?
So, first of all, if I can, I will comment on the feather question too, if it's possible. Donny, it's possible to do so?
Yes.
Okay.
You're
so on birds and feathers. Feathers are modified scales. I did show a picture of a modified scale of an alligator. So we do know how can we modify scales to get to feathers. Also, birds have scales too on their legs. Those are scales. So we do know that feathers are modified scales. On your question, it was just to show that you can get with Ken model, not with my model, with Ken's model, from a velociraptor or something similar to a emu, because a emu has arms very, very tiny. It's basically without any use, that thing, but it does have very little arms and a very little tail. It's just losing those two traits. And if you take something like a velociraptor, you cut off the tail, basically. You reduce the tail to be very, very small, and the arms to be very, very small and basically not useful at all. You will get something like a emu. The only difference is the beak, but it's losing its teeth, and I did show that you can get to chicken with teeth if you restore Asian gene. So that was my point. In Ken's model, you can get from a velociraptor to a emu or something similar.
All right. On my first question, I don't think you quite answered my first. You did answer my second question though, because I was going to ask you if if you consider that losing information. It appears that you agree that you're losing.
Sorry about that.
And the first
No,
question was
evolution is just population a population gaining or losing something. They are different, but it's not like there is a progression forward or in any other direction. It's not what evolution is. Evolution does mean that you can survive better, but it's not a given that you are getting better. Maybe there is something that is for example, food is getting harder to get. Maybe you become smaller because you need to eat less, and it's good for you in that condition, but you are becoming smaller. You are not gaining, you are losing something. Evolution,
Luca?
it's not like you just have to gain. It's not like that. It's not a linear progression. Sorry if I
just don't.
Actually, Brian, before you go, I'm going to jump in. I want to make sure Kent gets involved too. So, Kent, if there's anything you'd like to respond to based on anything Luca just said about evolution, basically having to do with populations changing and gene frequency, Luca, I think is what you're getting at. It's not about gaining or losing. It's just about changing. And so, Kent, if you wanted to respond, go ahead.
Well, yes, and all the changes observed are negative and losing. That's not going to help the theory. He said something a minute ago that feathers are modified scales. This is dogma. This is propaganda. This is not observable. This is not science. Hubcaps on the car go round and round and round. So I believe helicopter blades are modified hubcaps. Can I just make a statement like that and now it becomes true? No, he made a statement that feathers are modified scales, and he probably believes it's true, but it's not been observed. Nobody's ever seen a scale turn into a feather. We see a lot of animals with scales, like he mentioned, the chicken has both. Wonderful. Are the scales on the legs of the chicken turning into feathers? No, they're always scales. Every time we got a bunch of chickens here, they always make baby chickens with scales on the legs. It's designed so they can walk through the weeds and they don't get tangled up. There's no reason for feathers on the legs. So I think this is an example of what they do to poor students in school. They make a statement, evolution is true, and it's dogma. It's not science. Scales did not turn into feathers. I'm sorry. You can believe that if you'd like, but until you can demonstrate it happening with observable science, don't call that science, and don't teach that in a science class. That's religion. Go ahead.
Me and you on the same page, Kent, on the scales on the legs. I was thinking the same thing. That just means that they have scales and feathers. It doesn't mean that scales are modified feathers. But if evolution is not a forward progression, I just think that would not explain the fundamental differences that we see between different various kinds of animals. And like, humans and apes have some fundamental differences, and it doesn't make a whole lot of sense, but it's not forward progression. Logically, if you're losing information constantly, then you're never going to get that forward progression. If I move 5 steps back and 3 steps up, it's not going to do me much good, is it? Because I'm going to keep on going that way. So I don't see that evolution would have to be logically, in order to explain all life being related, a forward progression. And if it's losing information, then we just don't get that. But that's just my perspective. But thank you for answering my questions. I appreciate it, and thank you again, Kent. I don't have anything else to add on that.
Okay, Brian, thank you for joining. And let's now move to a next guest. We'll go with an evolutionist who I believe Mr. Archaeopteryx you'd hold to, unless you've converted to creation sometime recently. So, okay, Mr. Archaeopteryx, quick introduction. And then if you had a point or an argument or a line of evidence that you wanted to engage with Kent, go ahead and present it.
All right. First of all, can you hear me okay?
Yes, you're coming in good.
Okay, great. I'm Mr. Archaeopteryx. I don't really do YouTube that much. I did have a couple of questions for Kent. So Kent, one of his big things he always says is, his objections are always, I've never seen a dog produce a non-dog or a cow produce non-cow and such. So my counter would be, we've never seen cheetahs produce non-cheetahs. So am I to take it that by your logic, cheetahs are their own separate kind? Because this is typically creationists would say, well, they're a cat. Anyway, so I'm wondering, are they their own kind by your logic? And how do you determine that?
Well, that's a good question. The Bible says 24 times in the first 7 chapters, if they can bring forth, they're the same kind. Can cheetahs bring forth a baby with a cow? No. Can they with a bird? No. See, there's never been a good solid definition of the word species. I can show you, if you'd like to take a half hour, 26 different definitions of the word species in the textbooks and in the literature today. They don't know for sure what a species is. Merriam-Webster dictionary says a synonym for species is a kind. I think we would all agree that the cat kind contains a variety of what we have divided into different species. I don't think the animals care how we classify them. We turn all our animals loose in the North 40. We have cows up there. We have donkeys. We have sheep, and we have horses, all mingled together. They know what their kind is. They don't. The horses show no interest in the cows to mate with them. You can turn them all loose, and they're smarter than most evolutionists. Look at that. They just wander around. We never get a zeep or a zonkey, a heap or a how or a shibu. They always mate with their own kind. So they are smarter than a lot of people. They know what their kind is. Is a cheetah a different kind? I don't know. Good question. But it doesn't prove cheetahs are related to bananas. In your worldview, a cheetah and a banana are related, aren't they?
Yeah, they are.
There you
So
go.
you don't know, you don't have any way to determine if a cheetah is its own kind?
I don't think the burden of proof is on me to do such a thing. I'm not claiming that cheetahs came from a rock like you guys are. You guys are claiming that all life forms came from an amoeba, which came from a pond of soup on the rocks that got rained on for millions of years. You're claiming that science, and you're wanting me to pay for that. The burden of proof is not on me to determine what a cheetah is. I
would say if you're going to say we've never seen something produce a different kind, I think the burden of proof is on you to know what the words you're saying means and how you would determine if something has changed to a different kind. And by what apparently you don't know.
Well, there are 20 different definitions of the word species according to Britannica, 20 other species concepts. What is a species? Most important concept in biology is a complete mystery. What exactly is it? A lion and a tiger can crossbreed and get a liger or a tigon, depending on which one is the dad. They're still a cat. And can they bring forth fertile offspring? No, I don't think they can. So the Bible definition is they can bring forth fertile offspring. That's a different one here. So I think, again, the burden of proof is not on me. I can teach whatever I want to teach. I'm not asking you to pay my salary, but you guys are asking all of us to pay your salary while you teach this stupid evolution religion. We never see a crow produce a non-crow. Man has decided to call them 4 different categories. Hooded crow, the carrion crow. Should they be a different species? I don't think the crows care. They certainly can't mate with a frog or a banana. Do you think you are related to a banana also?
Yeah.
Okay. Do you eat bananas? Hey, do you eat bananas ever in your diet?
Sure.
So you're a cannibal?
No.
Yeah, you are.
No, just because we're distantly related. This is kind of like let's just use your logic. So you think you're related to, all people are related to Adam and Eve. So that means
yes.
when you do it, have relations with your wife, you are committing incest.
Well, I think
kind of a weird way to think of it. Obviously, we've got a long distance, and we've changed enough that no, we're we're not consuming the same thing.
Well, and again, you are way off track on the topic here. I don't have to prove anything. The Bible clearly says God made Adam, and then he made Adam out of a rib, made his wife. Adam married his own rib. In the early generations, the genetic code was pure and clean. There'd be no problem. Adam's sons had to marry sisters. There's no other choice. But then as you go through time, you get more and more distantly related. And most states have laws that you cannot marry closer than a second cousin. Some states allow first cousin marriages. Okay? The states have an interest in this because a high percentage of the children from close inbreeding are going to be severely mentally retarded and need state help. And the state says, now, wait a minute, if we're going to pay for these kids, we're going to have to control who does what. I don't want to pay for that. So I can understand their concern and interest in that. But I think that if a person, I think all humans came from Adam. I agree. Do you think all life forms came from a protozoa or an amoeba? All life forms.
I would say single-celled
Single-cell,
organism.
okay, single-cell creature. So you are related to a chicken, for instance, but yet you probably eat chickens too.
Very, very distantly. And that's the point I was making. Just like you're not really having incest with your wife. It's the relationship is so distant. It's moot.
Well, it's, as far as other humans are concerned, it's acceptable. Humans get together and decide what rules are. We've decided to put all the cats in one category and call them cat. We decided to make up a system: kingdom, phylum, class, order, family, genus, species. The animals absolutely don't care at all. Our cows look for another cow to mate with every time. And by the way, the male cows look for a female cow to mate with. They're smarter than some humans. Mm-hmm.
Okay. Well, I think the point I was just making was with my original questions, you throw around the word kind all the time as an objection to evolution. But as far as I can tell, you've never actually been able to tell if something is the same kind or not. So I'm not sure why you even claim to know if something is still the same kind.
All right. Well, let me answer that. Yeah, let me answer that. National Pornographic has a definition of species, a group of organisms that can reproduce naturally with one another and create fertile offspring. Webster's Dictionary, species, a kind, a sort. They use the word kind. Wow, call Webster, why don't you, okay? Synonyms for species is kind. Biology Dictionary, definition of species. Organisms that share genetic heritage are able to interbreed and create offspring that are fertile. That's a reasonable definition, okay? That's the same as kind. If they can bring forth, they're the same kind. A cow and a pine tree cannot bring forth a baby. A cow and a sheep cannot bring forth a baby. Now, the 400 different kinds of cows, they can crossbreed and bring forth another cow, but that's always all we've ever seen. So yes, I would stick with the Bible. Uses the word kind a whole bunch of times in there. They're the same kind. And that's a reasonable word. A person with two brain cells functioning knows it's the same kind. Put a dog, a wolf, a coyote, and a banana in front of a 4-year-old. Ask him which one is not the same kind. A 4-year-old will know it's the banana.
Come on. You can put a chimpanzee, a human, and an orangutan picture in a banana, and a 4-year-old's going to say, oh, well, these three are the same, and the banana is different. I mean, come on.
Correct. Now, that's because you're talking about a higher classification. Kingdom, phylum, class, order, family, genus, species. Man has decided to make this chart to begin with and to try to classify them. The animals, again, don't care. We've decided to put humans, chimpanzees, orangutans all in one family. Okay. They're not interfertile.
I think the point was asking a 5-year-old isn't a very good.
Okay.
I mean, that's not going to get you anywhere. I mean,
Do you believe?
Very good point.
Do you believe a human and a chimpanzee can mate and produce a baby?
Nope. And I don't think a cheetah and a tiger can mate and produce a baby, but creationists generally accept them as the same kind. So that point you're trying to make right now does not follow.
Okay. So your question, is a cheetah a totally separate kind? And I answered at the beginning, I don't know. That's a good field of research. I know it's not related to a banana. I know that.
How do you know that? How do you determine that? You can't determine if it's related to a tiger. So how do you determine
Well, let's see. Can they bring forth?
It's just empty claims.
God said if they can bring forth, they're the same kind. And again,
already
you're
been
trying to
doing
shift
this.
the burden of proof to me. I don't have to prove any of this. You guys got to prove the cheetah and the banana had a common ancestor, because that's what you want taught. You want to call it science. You think you're related to a banana, yet you eat them. How can you do such a thing?
If
That's
you're
your
going to say
discrimination.
it's
You're
not the
eating your
same
cousin.
kind and we've never seen something produce a different kind, and then you can't tell me what the kind is or how you would determine if they're the same kind, then, I mean, it's just empty claims.
Well, can you tell me what a species is? None of the people on the internet can. They don't know what a
I can tell
species
you when
is.
two things are not the same species if they cannot interbreed. Now,
Bingo.
yeah.
Then it's the same for kind. If they cannot interbreed, they're no longer the same kind.
Well, then
I'll use-
we're gonna bust up your kinds all the time, just like we busted cheetah away from the rest of the cats. We can do the same thing with all these different these kind orchids. They're gonna get broken up into dozens or thousands of different kinds until they can't fit on the ark anymore.
Well, he brought two of each kind onto the ark. And again, you're trying to shift the burden of proof. I don't have to prove the Bible story or the flood story. You guys want your religion taught in schools. You believe you're related to a cousin or to a banana, and yet you eat them. They're your distant cousin. If they're distant enough, it's okay to eat them. Is it okay to eat another human if they're distant enough related from you?
Well, I don't think so.
Oh, okay.
I guess it
Some
just
people do.
depends
Hey,
if they have
there's
your
tribes.
consent.
There are tribes around the world that think it's okay to eat other humans.
Yeah.
Are they okay? Is that good that
Not
they
in
do
my
that?
opinion.
Okay. And it's not in my opinion that you should eat your cousin banana. Stop eating bananas, okay? I think you should stop. Okay. All right. Donnie, going nowhere here. What else you got?
All right. Well, Mr. Archaeopteryx, feel free to stick around as we move around the room, and then as we move towards the 2-hour mark as well. Okay. So Kent, Mr. Archaeopteryx, thank you for the back and forth. Next on the panel is Josh. Josh, I believe this is your first time here in one of our open mics. And so feel free to give yourself a real brief introduction. Let us know what position you hold to creation or evolution. And then if you had a question for Kent or Luca, go ahead.
Okay. Hi, my name is Josh. I'm from California. I'm a creationist in the sense that I believe what the Bible says. It's 4,000-year-old book written thousands of years apart by multiple different peoples, and everything lines up. So I have reason to believe that this is real. But I have some questions for Kent, because Kent's argument towards Luca and towards the evolutionists is that there's no logical evidence, there's no scientific evidence, there's no dogma, there's no observable science. Well, we can say the exact same thing about the Bible. There's a verse here where it says the first indication that God created something. It says, God said, let the waters bring forth abundantly the moving creatures that have life. And, it doesn't really go into detail about like how that was accomplished. Right. So I went to school, and growing up, I was taught evolution. I was taught dinosaurs. I was taught all these things. And younger me was kind of on the page of like, well, maybe that's the method that God used. Maybe the Big Bang is the method that God used. Maybe the timing is wrong. Maybe we think it was millions of years. But, I think a lot of people have spent a lot of time like looking at the DNA. Like even like, for example, like when you look at, and I'm just looking on Google, I type DNA difference between a banana DNA and a human. And it says that the banana is 60% genetically similar to humans. That's just straight from Google. And I'm just wondering, like, why are you being so tough on the evolutionists for trying to make reason of how things could have possibly came from a single cell organism to everything, when it just makes sense that, let's say, for example, God created a whale, right? That's the next thing it says that's really identified in the Bible. The next verse it says, and then it says God created the great wells, right? So let's just say you're starting with a well. Like how do we know that it wasn't a single cell organism, that then God put all the building blocks on top of it to get to the point where it was a well? And then he said, well, you know, we should also make smaller fishes. So let me remove this and add this to that fish. And I kind of heard what you were saying about like, oh, well, I'm not the one that has to prove.
Josh, why don't we wrap it up there and allow Kent to respond to everything you've said so far,
sorry.
and then we can move on to more later.
Yeah, we
Go
got
ahead.
4 different questions going here, one at a time. Let's see. I take by faith that this is God's word. I cannot scientifically prove everything in here. I don't need to. I've chosen to believe it. I admit mine's a religion. I believe this. These guys do not admit theirs is a religion. That's all. They need to admit they've never seen an amoeba produce a non-amoeba. They've never seen a bacteria produce a non-bacteria. They believe it. Okay, well then fix that dog. Is that on my end here?
Josh, is that your end? If so, I'm going to mute you. Okay. Go ahead.
Nobody has ever seen this. Nobody's ever seen the evolution family tree that they talk about. We don't see any of it happening, but they won't admit it's a religion. They want to call it science. I admit mine's a religion. I did not see God make Adam from the dirt and Eve from a rib. I didn't see Noah put all the animals on the ark. I believe by faith he made it all instantly in 6 days, because later in the 10 Commandments, he wrote on a rock with his own finger, in 6 days, the Lord made heaven, earth, sea, and all that is. So from that verse, I can conclude that the days are normal days, and he made everything perfect to begin with. Jesus said the creation of Adam was the beginning. Matthew 19:4, Mark 10:6. I have chosen to believe that. That is my faith. I admit it's my faith. I admit it's my religion. I think all the scientific evidence points to the fact, wow, dogs make dogs every time we see it, every time. And these guys want to believe dogs and birds are related. Okay, that's fine, believe that. But quit calling it science. It's a religious belief you have. These family trees are nothing but propaganda designed to deceive the students. This isn't science. That's all. Go ahead.
Thank you, Kent. Josh, yeah, I just see you unmuted yourself. Go ahead with your follow-up question or point.
Yeah, no, I think you make a very good point. You know, for the evolutionists, it would be my next question. Like, considering, like Kent said, that there's certain things that we just can't explain in the Bible, right? Like, and we're okay with that. We're willing to admit that. We can't explain how Jesus resurrected. We can't explain how he mysteriously vanished. We can't explain how he took a man that was blind and made him see. We just can't explain it. We going by faith that that's how that happened. So for Luca or Mr. Archaeologist, whatever your name is, sorry, I butchered that. What's holding you back from admitting that there might potentially be some flaws in your evolution theory?
Nothing. There are, and there is no problem in it. If something is perfect, you have nothing more to do. So it's the worst thing ever. So no, it's not a problem to say that evolution is not all figured out. And if you do figure out everything about it, there will be nothing more to discuss. So that would suck, if you ask me.
Okay. I don't really have any other questions, and thank you guys for the opportunity to be able to speak. And I do hope that you guys, Luca or any other evolutionist, can find a little faith, you know, believe in something more than just what man has came up with.
Okay, Josh.
Sorry, I can answer to the last part. I want to make something clear. When you became an atheist, at least for me, you lose your faith, and it's not even a choice, because let's be real, I'm in a country that basically everyone is a Catholic. To be an atheist will be it's to be quite alone. It's not a good thing, but it's not my choice. I no longer believe. So at this point, it's not a choice for me.
And if I could address that also, you say, you know, have something a little more faith and something than other than what man you know, is saying. Most people that accept evolution are religious. I think if you look at like Jewish people and Hindus and Buddhists, and even to some degree Muslims and Christians, certainly all these different groups, they accept evolution. It's really got nothing to do with faith. Kent likes to, and a lot of creationists, they like to equate accepting evolution with being an atheist, and it's just not the case at all.
Okay, thank you, Mr. Archie. Kent, yeah, if you want to unmute yourself on your end, Kent, then we'll give you the opportunity to respond whenever you're
Okay,
good.
yes, sir. I don't think I've ever said all evolutionists are atheists, but I think that all atheists I know are evolutionists. Do you have another explanation for how the world got here? And I don't never heard of one. They all seem, and this goes back to the definition of the word evolution, which I try to hit in my seminar. There are 6 different levels or meanings or stages. We have many different levels of classifying animals: kingdom, phylum, class, order, family, genus, species. Well, there are different levels of meaning to this word evolution. There is cosmic evolution, the origin of time, space, matter. They have to have time, space, matter get here to even start the process. They answer that with 2 words, Big Bang, and want to move right on. Whoa, whoa, whoa. What exploded? Where was it? What did it explode into? Where did space come from? Where did time come from? If the Big Bang was 13.772 billion years ago, what was here 13.773 billion years ago? Where did time start? And where did space come from? Where did matter come from? They don't have an answer to that, so they want to skip right over it. Guys, you can't skip over that, because you can't have anything to start evolving if there isn't something to start with. Then there'd be chemical evolution. They say their Big Bang produced hydrogen, helium, and maybe a little lithium. Okay, how do you get silver, platinum, and gold from hydrogen gas? You have to have a system you have to have a scientific explanation for the higher elements, and they don't. You can't fuse past iron. And where's this energy coming from? They just assume it's all happening and want to skip over this. Stellar and planetary evolution. Nobody's ever seen a star form. They see spots get brighter in the sky and think it's a star forming. Well, there might be a supernova way out there that's light's just now reaching us. We've never seen a star form. Nobody has, okay? Then you have to have organic evolution. Life has to get started. If it can happen long ago and far away in a warm little pond, we'll get a warm little pond and do it today where we can photograph it. Nobody understands how life got started from non-living material. We can't make life in the lab. And if a bunch of scientists did make life in the lab, that would prove it takes intelligence to make life, wouldn't it? We don't see it happening in warm little ponds anywhere else. Then you have to have macroevolution, where an animal changes to a different kind of animal. That has never been observed. All we've ever observed is what probably should not be called evolution at all, but it's microevolution, variations within the same kind. That's observed. The first 5 are religious, and they want to skip right over those and assume they're part of, because we see variations within the kind, and somebody chooses to call that, with that magic word, microevolution. See, you believe in evolution. No, I don't. I believe in variations within the kind. Quit calling it microevolution, and the argument's over. All we see is varieties of cows. We see varieties of dogs. We do not see dogs and cows having a common ancestor. That takes place in the imagination. It's a fairy tale for grown-ups. That's all it is. So we need to more clearly define exactly what you mean by evolution. But I would agree, Mr. Archaeopteryx, there are some religious people who believe in evolution. They need to be unbrainwashed. I'm here to help them. Have them call me, 855-BIG-DINO, extension 3. I'll unbrainwash them over the phone. Okay?
Thank you, Kent. Anybody from the evolutionist side, either Mr. Archaeopteryx or Luca, feel free to.
I want to say something funny. Some atheists do reject evolution. I can think about Mauro Biglino, as a good example. That guy is basically insane, but is a biblical literalist, atheist, and it does not believe in evolution. That's a tough one, but yeah, they do exist. Also, I need to say that I was a Catholic for a good chunk of my life, and evolution was not a problem. Catholics do accept evolution. So I'm an atheist, but evolution has nothing to do with it. I'm an atheist for different reason. I did talk about that over Rebecca's channel. So yeah, if someone want to know, it's there.
Okay. Thank you, Luca. Let's do this. Kent, go ahead. Let's
Yeah,
have your
just one quick comment. I appreciate what Luca's saying. There is an insane atheist who does not believe in evolution. And he very wisely used the word believe in evolution. Mr. Archaeopteryx, you have to accept evolution. No, you don't accept evolution. You believe in evolution. You can accept what is scientifically observable. That I would accept. Nobody's ever seen a cow produce a non-cow. You believe cows and bananas have a common ancestor. You don't accept something like that. You can only accept a fact that's observed. I accept the fact that we never see this. So you believe in evolution. I wish you guys, all I'm asking is just admit it's a religion and get it out of our schools and go believe whatever you want to believe and teach it to your kids. But don't make everybody pay to teach it to everybody's kids.
Yeah.
I'll never give up that battle.
Well, you'll never win it either.
Sorry, I want to clarify. It's not like it's very late, so I did sleep and I did say believe, but it's not a belief to say that evolution is true, because I do try to find evidence. Also, Bellino, I said that is basically insane, but not because it does not accept evolution. It's a very peculiar guy. If you search for it, a biblical literalist that does not accept evolution better, and I think that God is an alien. I think it's quite crazy, at least for me. So yeah, it's important to clarify. It's not a belief, of course. I'm just very, very tired because it's 3:30 a.m. up here. So yeah, sorry for that.
Okay, Luca, thank you for the response. Gentlemen, let's bring in the next person. Since Josh was on the creationist side, we'll bring in somebody from the evolutionist side. Carlos, welcome to the open mic.
Hi there.
Oh, I hear an echo on your end.
Oh, do you? Is that? It might be. Hold on. How about now?
Yes, sounds like it's. Yeah, I think we're good.
How about now? Oh, we're good?
Actually, do another mic test, Carlos.
Yeah, sorry. I know I got to get a new mic. This thing's been messing with me lately.
I think it's coming in, though. I think we're good. So, Carlos, I believe this is your first time in one of our Evolution open mics. And so just a real quick introduction in terms of what your specific position is on this issue. And then if you had an argument or a point or a line of evidence that you wanted to present to Dr. Dino, feel free to go ahead and we can go back and forth on it.
Yeah, no problem. Sounds good. Thank you, Donny, for having me here. Hello, everybody. Pleasure to be here. My apologies. I don't often do any type of public speaking, so if I'm a little nervous or my words tend to mash together, that'll be the reason why. So my position is for evolution. I feel there's an abundance of evidence. I will grant that I am just, an average layman. I'm not a scientist or have any degrees in any regards. So I'm not going to hold anybody to the fire for that. my problem, or the point that I want to raise and address, is with the way Kent represents evolution. I feel like you're doing a great disservice in your straw man. There are two that are notably prevalent. One you just utilized with the previous caller. What was his name?
We had Josh, possibly Josh, who's still here.
Just the one just before me.
Yeah, Josh.
Yeah, Josh. With Josh. So you said to Josh, nobody's ever seen a cow produce a non-cow, and this is one of your favorite things to say. Now, I want to start by prefacing with the fact that can we both acknowledge, Kent, that when you say produce, you mean to give birth, correct? Hence why you say a farmer has never seen a cow produce a non-cow?
Correct. To my knowledge, no. Every farmer, when they crossbreed cows, expect to get a calf, and that's all that's been observed in human history. But yes, produce. I think
All
I
right.
would make a baby. Right.
Okay, Kent. So my question, or it's been rather a challenge that I've been pulling to rather every theist that brings up such a statement. Can you provide one modern source in a textbook, a scientific textbook, not a creationist textbook, that says anything even remotely similar to the notion that a cow can produce a non-cow is taught by evolution? Now, hold on, Ken, before you start flipping, I kind of know where you're going to go with these charts that you like to do. And so I'd like to point out that those charts do not say that any of those organisms, if you could pick two organisms, you could pick the amoeba and a human. At no point does that chart say the amoeba is giving birth to a human. So I would like to provide a source and not pretend that the chart is showing X organism giving birth to Y organism.
Okay, Carlos, thank you for your question and argument. We'll give Kent equal time to respond now. Appreciate it. Kent, floor is yours.
I am surrounded by a library of textbooks, science textbooks, biology, earth science, physical science, which I taught 15 years. Here's one from a long time ago, 94. All the many forms of life on Earth today are descended from a common ancestor found in a population of primitive unicellular organisms. This textbook is clearly saying all the life forms today came from a primitive unicellular organism like an amoeba or protozoa or bacteria. No traces of those events remain. These charts are found in every evolution teaching. And you asked an impossible question. You asked, can I find something in a secular textbook? I think I can. Showing these charts is indeed teaching that one animal turns to a different kind of animal. They draw the lines on paper, and that is an indication that they think they came from that previous one. But see, if you went to Nazi Germany in the early 1940s, could you find a public school textbook that spoke out against Hitler? Well, no. Well, therefore, Hitler must be a good guy. Can you go to communist China today and find a textbook that speaks out against communism? Well, no. Can you go to a Catholic country and find a book that speaks against Catholicism? Probably going to be difficult. Can you go to a Muslim country and find a book that speaks against Islam or Muhammad? No. So to find our public school textbook, I think, have been co-opted and taken over by these evolution religious zealots, and they've won the battle for the textbooks. Though I'm going to win the battle for the mind. Thousands and millions of students do not believe in evolution, and I'm going to keep fueling that fire to overturn this. This is clearly showing a bunch of lines on paper connecting a single-celled creature. Here we go. Protozoa turned into a human. Yes, they teach that. They don't say it directly, but they'll say your ancestor was a single-celled creature. Why can't you admit that they do teach this? Why are you putting the burden of proof on me? I show this all the time. You were concerned I might show my chart. Well, this is from the public school textbook. This is what they're teaching. I think that's propaganda. I think it's not science. There's no evidence of any animal producing anything other than their kind.
Can I respond to that?
Yes, go ahead.
Okay, so Ken, in a way you answered the question, and I'll tell you how you did insofar as you said you think you can find a modern textbook that says that. But the rest of what you said did not address my point. Now, Kent, you are using an equivocation fallacy. You use several, actually, Kent. So, first off, the textbook that you showed, it says descends. It does not say that a cow can give birth to a non-cow. It says a non-cow can descend from a non-cow. Those are not equivalent statements. Granted, the direct offspring is a descendant, but that is not, again, the same use of the word in this example. Now, further, to show another equivocation fallacy, you said that the lines on the paper clearly show Y organism coming from X organism. Yes, coming from. But again, you are pretending that the diagram shows X organism giving birth to Y organism, which is a misrepresentation of evolution.
Okay, Carlos. Over many generations, they slowly changed from an amoeba to a cow. Is that what you believe? Do you believe the amoeba turned to a cow? Not instantly, but over many generations.
No, I don't like your verbiage, Kent, because what you're doing here is, this goes into the second example that I have. What you're doing here is where you're going to use that that silly thing you say, where you say, if a frog turns into a prince quickly, it's a fairy tale. If a frog turns into prince over many generations, it's evolution and science. No, Kent, that is also a misrepresentation, because in that analogy that you're giving, that example, the frog turning into a prince, you are saying that X organism shape-shifted into Y organism. Hence, the story of the frog, that same individual specific frog becomes a prince. That does not happen. This is not Pokemon, Kent. That is a misrepresentation of evolution.
Well, do you believe the protozoa in this
No. Are you going to acknowledge that that's a misrepresentation?
I'm going to jump in. If you have
I'm
something to
not
object
saying-
to, save it, Carlos. Okay, go ahead.
Okay, my apologies.
You believe all life forms have a common ancestor. So the amoeba shape-shifted into a frog over millions of generations, didn't it?
No, it has a common ancestor, which means that amoeba produced more amoeba, and those amoeba produce more amoeba, and so on and so on and so on. And each generation, each reproduction, the offspring, were slightly different until we get to where we are today, that we have frogs. That is not saying that an individual organism, let's say Fred, shape-shifted, that same amoeba Fred shape-shifted into a frog. No, there was an amoeba named Fred, and it has a descendant that is not Fred, and we will name this frog Jerry. Jerry and Fred are related. They are not the same individual as your analogy pretends to be. So that is a misrepresentation of evolution.
Okay, Carlos, let's just pick a number and say to change from the protozoa to the frog, like this textbook shows, it took 1,000 generations, probably took billions or trillions in your thinking. But so at some point, the protozoa produced a baby that was 1% frog. It wasn't frog yet, but it was 1% frog.
No.
Yes, you have to believe that.
No, that's not how DNA works. We can compare percentage of similarity in our DNAs, but to say that an organism is 1% frog is nonsense. Now, the organism can produce a creature that looks similar, and what's happened, as you said, we are the ones that name these things. What happens is, at some point, an organism which we would consider to be a frog arises. That is not the same as saying that an organism transformed or gave birth to a different organism.
Okay, let's take the very first frog that got here.
We can't do that because that makes no sense. You would have to arbitrarily. It's like if I asked you to pick the very first shade of red between, if I had red and blue. What is it, red and blue? Yeah, red and blue. If I had red and blue, I asked you to take the very first shade of purple, you wouldn't be able to do it because there's two different shades of purple on each end for one that come in. If you want to arbitrarily say the very first one that looks slightly remotely purple, you'd have at least two different shades coming from the red end and the blue end. It is a gradient. So to ask for the very first one is nonsensical.
Okay. Was there ever a time in world history where the predecessor of the frog was not considered a frog?
Of course.
Well, then what did that one look like?
Whatever that one looked like, but you're not making a point there. You're just trying to bloviate at this point. You're just saying that there was a different organism, that the ancestor was different at some point. That's not a point. That's literally just evolution. That's not making a counterpoint.
Well, your analogy is muddying the water about the purple and the blue and the red. We see genetically, amoebas always produce amoebas. They don't produce 1% frog or 0.5% frog.
That doesn't follow.
Every time. Now, this is where I wish you guys would just admit you believe this happened. It's a religion, Carlos. You don't have science. Nobody sees amoeba produce a non-amoeba. You have a story you like to tell about it gradually changing. Show it to me in the laboratory. Show me an amoeba turn to something non-amoeba. You have a religious belief and you're welcome to it. But quit calling it science. You're polluting good science with your stupid religion.
You're using sophistry again, Ken, because you just did it again. You're saying that organism turned into. No, that organism did not turn into anything. They came from. You cannot keep using the equivocation fallacy where you equate came from with turned into. That's fallacious, Ken. It shows that you're misrepresenting evolution.
Well, you're picking at straws. Okay.
No, I'm picking at straw men. Correct. Actually, I'm picking at straw men.
Okay, go ahead.
All right. Your Honor, objection. Did the amoeba produce a non-amoeba at some point? It didn't? Well, then why there are still amoebas and they're still making babies?
Yes.
It's
Those
the
amoebas
language you're using, Kent.
It's the language you're using, Ken. Yes, exactly. Sorry, go ahead.
No, yeah,
Well,
I mean, you say these things all the time. Like, I've never seen a cow give birth to a kitten, and people call you out on that, and then you bring up this chart showing millions of years and millions of ancestries, as if that's the same thing you just said.
Yeah, exactly. He'll say he'll say a cow gave birth to a non-cow. Then when we call him out on it, what he'll do is he'll say this chart shows shows an amoeba or a human coming from an amoeba, which is not the same as saying the chart shows an amoeba giving birth to a human. Those are two different statements.
Okay, let's let Kent respond. Go ahead, Kent.
So it slowly, over many generations, gave birth to something a little different, different. But finally, this is what you guys. Why can't you? You don't even know your own religion, Carlos.
Ken, hold on, Ken. Because you're.
Hey, Carlos, what we'll do?
Okay, I'll let him show.
I'll let finish his thoughts, and then you can go.
Do you believe these charts, like they show in the textbook? Do you believe this represents science, that all life forms descended from an amoeba of some kind, a protozoa? Do you believe these charts are science, or is this imagination?
You're trying to change the subject, Ken. I believe that chart is science. Hold on. No, wait.
You're trying to avoid it. Yeah.
Donny, can you mute him while I respond? Like I was muted. Thank you.
Okay, Carlos, go ahead and respond. Then we'll throw it back.
So, Kent.
Yes.
Okay. So you did it again. So what you're doing here is you're saying the problem that I had, why I said no before you started saying I don't even know my own religion, which is not a religion. If you know the definition of religion, it's not a religion by definition. But anyways, you're saying that amoeba gave birth over many generations to these other organisms. It did not. That amoeba gave birth to its subsequent offspring. All right. And then those offspring had offspring. What you're doing here is the equivalent of Kent of saying your grandmother gave birth to your son, Eric, which is nonsensical. Oh, you're saying over many generations, your grandmother, great granny Hovind, gave birth to Eric Hovind, and that makes no sense. That is not what happened.
Okay.
So that is a misrepresentation of evolution.
Well, you are muddying the water. Let me answer the question here. I do not believe...
I would like to explain how I'm muddying the waters, Ken. Don't just say I am.
Donny, control the mic here. I believe my grandmother gave birth to my parent, and I believe that parent gave birth to me, and I believe I caused Eric to be born, and I think we're all human, every one of us. I've never met my great-great-great-grandmother, but I'd be willing to bet $5 my great-great-great-grandmother was a human also. But you believe your great-great-great-great-great-great-great-great-great-great-great-grandpa was an amoeba, don't you?
So, Ken, in the same way that you believe your grandmother gave birth to your mother, and your mother gave birth to you, and your wife gave birth to your son, it's the same with the amoebas. The amoebas produced more amoebas, those produce more, and every reproduction, same way as with as you can see in your own family tree, there was a difference in the offspring, same way as there was a difference between you and your mother and your grandmother, and you and your son and your grandmother. There was a difference every generation in how you looked. And every time that happened, it kept happening until eventually we came about. At no point did the original starting organism produce all the following organisms by itself. You are misrepresenting evolution. You are using what's called sophistry.
I'm going to jump in before Carlos finish your thought, and then I want to say something before.
No, I'll leave it there. He's using sophistry.
Okay, Kent,
I'm pretty sure everyone knows what that is.
Before you go, I just want to be cognizant of the time, Kent. I'm going to give you the last word. Since Kent is the guest, we're going to give you the last word next, Kent. And then we're going to bring in the next couple people because we are coming close to the 2-hour mark, and I do want to respect the agreed upon time. So, Kent.
All right. Well, actually, you can start real quick, Donny. If before Kent gets that last word, can I just say one more thing then? If that's going to be, because I understand he's going to get the case.
If it's a different topic, no, let's stick on this topic.
Yeah, no, it's a prediction. You're just going to rehash the exact same thing and use the same straw man that I just refuted. You're just going to say it's a religion. Nobody's ever seen a cow produce a non-cow or any so on and so forth. When I just used it because repetition.
Carlos, I'm going to jump in. I don't want you. I want to be respectful, and so we're going to wrap it up there. Feel free to stick around for when we get to the 2-hour mark. We can discuss.
Yeah, no problem.
Kent, floor is yours. Go ahead.
This is what he does not see or understand. Probably does not want to understand. I agree. There are differences. My grandmother and my mother and my sister have differences, but they're still human. The 450 breeds of cows they've now created are still cow. There are limits. There are variations. Certainly there are variations. The amoeba might produce a variety of amoeba babies. Some might survive better in warm water or cold water. I don't know. I don't care. But they're still amoeba. They're still human in the case that he's giving. But he wants to think because there's variations within the humans. Grandma was not the same as son and daughter and great-grandpa. I agree. There's a lot of variations in humans today. Look around the planet. There's tall ones and short ones and fat ones and skinny ones and blonde hair, red hair, brown hair, black hair. They're still human. But you want to believe that humans are related to a frog because of these differences. We see variations in humans. Therefore, these family trees are true. This is where you guys refuse to admit or understand you have a religious belief that the variations can be unlimited. You think that protozoa, let me get him up here again, that protozoa can turn to everything on this chart. That's what they're teaching the kids anyway. This is a junior high textbook showing the kids the protozoa is the great-great-great-great-great-great-great-great-great-grandmother of everything. This is propaganda. This isn't science. It's a lie. It's not observable. It's your religious belief that all the animals came from a single-celled creature. Over billion, I'll give you quadrillions of generations. It doesn't matter. It doesn't happen. It's not observed. It's not science. That's my point. Donny, I'm tired. I had a long day today. Gave a bunch of tours. I got a bunch to give tomorrow. Come on down, tour Dinosaur Adventureland in Lenox, Alabama. Okay, but I promised you 2 hours. I'm about done. Go ahead.
Sorry, I can say one thing to Kent before he goes. So, Kent, I beg of you, can you send the chart with me and the cow and all other evolutionists in it? I want to show them to my grandkids one day. So, can you send me that chart, please? I beg of you.
You send an email to Donny to give him the address. Donny will send it to me. I'll be glad to email you. You can get all of my slides. I'll help you any way I can. I want to see you get converted, Luca.
Okay, Kent, Luca, appreciate it. Kent, before you get going, I have had Taylor K here waiting patiently to ask one question, she said. So maybe we'll wrap it up with a quick question from Taylor. So Taylor, good to have you. How you doing tonight? And what's your question?
Okay, so I'm doing great, and so I only have one question tonight, and it's for Kent. So, yeah. Okay, so the question is, Noah's flood can be used to explain all the layers we see in the rocks and dirt. But why are there layers in the rocks and dirt on Mars which didn't have a flood?
Well, I'm only understanding half of that. You're talking to high, several octaves above what I'm used to listening to.
Okay, I'll go a little slower. Okay. Noah's flood can be used to explain all the layers we see in the rocks and dirt. But why are there only layers in the rocks and dirt on Mars which didn't have a flood?
Are there rock layers on Mars? Is that what you're saying or alleging?
Yeah, there's basically.
I've never heard that. If it's true, I'd like to see the evidence for that. I think all of the planets are being plastered with dust from space as they travel around the sun. They're all receiving cosmic dust, and Earth is getting some too. It's minimal. I don't know that Mars didn't have a flood. Maybe some of the, maybe Earth's, the fountains of the deep breaking open were enough to eject some of our water or rocks beyond our gravitational pull, and they're still floating around, and planets are running into them hundreds of years later. I think we might still be running into space dust that came off the Earth when the fountains of the deep broke open. I don't know. All you'd have to do is reach escape velocity, and which diminishes with distance. So that's interesting. Send me the pictures, Taylor, of the layers on Mars and the evidence that they used to see that, and I'll see if I can come up with an explanation. Good point. I don't know. Don't have an answer right now.
I will.
Okay.
Oh, that's a great answer. So thank you for answering.
All right, Taylor, we saved the best for last. So appreciate you joining and getting your question in right at the 2-hour mark. So feel free, join anytime. We got another open mic to anybody else next week on the 12th. Taylor, any last words?
All right, Donny, can you handle it from here?
Yes.
Take
Ken,
over.
We're gonna let you get over. You get a good sleep. Thank you for 2 hours, brother. God bless. All right. Well, okay. So we're moving into our next phase then, which is at the 2-hour mark. We'll have just another 2 hours of open mic, more so a free for all, creationists versus evolutionists. And so next on the panel though was Mars Hill. And so to be fair, Mars, let's hand it over to you, brother. Good to have you on. Keep up the good work on your channel, that's for sure. And if you had a point or an argument you wanted to present, we'll allow you and a couple of the evolutionists on the panel to go back and forth on it.
Yes, my mic okay?
Yes.
Okay, so yeah, I kind of wanted Kent here, but he had to go respectfully. Yes, when they try to like corner him about the whole what is a kind, I think that they're a little harsh in that department, because on their end of things, you're the duck-billed platypus, and it seems like they have to squeeze that into the mammal category, and they don't even know what to say about that, because you have a mammal, even though, according to my knowledge, it lays eggs, correct?
Yes.
So we're talking about a kind. Meanwhile, you can't even I'm not saying you directly, but your worldview doesn't even have a categorization for a duck-billed platypus, because it is one in its own. And I think that actually caters the young earth creationist aspect, where when God created these animals, he didn't really care how we classify them. So I think the duck-billed platypus is a great example. Yeah, you can touch on that before I keep rambling.
Yes.
Touch on that. Anyway.
Oh, sorry.
Oh no, go ahead. Go ahead. Go ahead. I can wait. I will remember what I'm going to say.
If you want to make a point,
oh no, trust me. I get very rambly. So go ahead. I'll remember the point, because he's talking about kinds. I'll remember it. I assure you.
Go on, Carlos.
Okay. So the point with the kinds, I have to say, first off, I disagree that it's a problem that we harp on him for that, because if you're going to engage in debates, it is very, and I acknowledge that words are descriptive, not prescriptive. However, if you're going to engage in debates, it is very crucial that you have these terms well defined. Otherwise, you get into, as I said earlier, equivocation fallacies. All right. Now, as for kind, with Kent specifically, this is a big problem because he circumvents a lot of things that we're talking about. So first off, he never really defines what kind is. He'll just say the Bible defines kind. But the Bible mentions kind. The Bible never especially defines kind. So he never really gets into a definition. From what I've gathered, kind, as he uses it, typically refers to genus or family, because he says things like, it's still a dog, it's still a cow. And those are colloquial terms that we use for the family or genus. To your point of, and his point of the God not caring about how we name these things, these are human names. God appointed Adam to name the animals. So I would think how we classify them is quite important, and how we name them is quite important. I'm done.
Okay, Luca, do you want to go, or do you want me to respond?
Okay, on the platypus is quite a good topic.
Oh, you got me. I did forget about the platypus. Go ahead.
Sorry?
Oh, I said you got me. I did forget to say what I was going to say about the platypus, but go ahead.
So the platypus, it's a very good example. First of all, it does not have a duck bill. It's a different structure. If you look at a platypus skeleton, you can see that. On the fact that it does have eggs, it's not a problem, because in evolution, you must have mammals evolving from creatures creating eggs. Sorry, deponing eggs. I'm very, very tired. So my inner Italian is leaking. Sorry. So it's not a problem. It's evidence for evolution, because you need something like the platypus, if you think about it. Something in between a mammal and a reptile, something like that. You will need that point of connection between those two things.
So are you
Yeah,
saying
but
that this animal existed for a really long time, the platypus? Is it almost like a transitional animal in this evolution puzzle?
Of course, it's not a transition, but it's just an animal growing in a very isolated part of the world that does have a very ancient trait for a mammal to lay eggs.
So would you say the mammals came? Would you say the egg came before the mammal?
Yes.
So I just hopped in. I got a question for you, atheists.
Mm-hmm.
Well, before that, Darth, my apologies. I'm also new here. It's my first time. I have a lot of thoughts. But I would like to add on to what's this gentleman thing Luca was saying about the platypus in response to Mars. So Mars, the thing with the platypus is that a lot of taxonomy is based primarily on generality. So when it comes to defining a mammal, or defining any of these classes, we generally focus on the general things that make this thing. And then as we get more specified, we put them into more specific groupings. So with the platypus, it meets pretty much all the other things that would make it a mammal. It's just this one or these few things compared to these many things that don't make it similar to a mammal. And to Luca's point, and how somebody, I think it was you that said it was a transitional. It does show that, as far as evolution goes, that even in these groups, we have these occasions where they can branch out into seemingly other taxonomic clades while still being predominantly one type of organism. Go ahead, Darth.
Which violates the law of monophyly, correct?
Yeah.
No, because it's still in its clade. It's just that it has certain characteristics of other creatures. That doesn't mean it's gone from a different clade. And again,
Well,
with the way the clades are, the clades get more specified. So it's like, if you're going to think about clades aren't, it's one bubble here and then it's connected to this bubble. No, clades are, this is one bubble of organism. So we'll say mammal. And then if we go further into that, but we'll make a smaller bubble inside of the mammal, and then we make another smaller bubble every time they get specified. It's like saying, do boots break the law of mono? Just a rough analogy. I know law of monophyly doesn't apply to boots, but when you think about shoes, you know what I'm saying? You have the category shoes, then you get more specific, and you have boots, and you have sneakers, and you have sandals. Then you get more specific into those, and you have steel toe boots and non-steel toe boots. You have high top sneakers and non-high top sneakers, and you get more and more specified
and you know,
of those.
and you know what they all are? And you know what they all are? Footwear.
And you know what we all are? Eukaryotes. We're all organisms. We're all.
But you're saying that the amoeba was giving birth to these other amoebas that gave birth to different animals, violating the law of monophyly.
No, because these creatures that give birth, again, we're going off of how specified they are. We're focusing in on more distinct things. So we have an amoeba that has whatever characteristics, right? It may not have a lot of characteristics. Let's say it's small, it's blue, and it's slow. All right. And then what happens?
But going from fish to fisherman. But going from fish to fisherman violates the law of monophyly.
No, because
and where did all this DNA information come from? That was going to bring the fish to fishermen.
They're not proposing Pokemon evolution. So every time you're proposing this Pokemon evolution, you're strawmanning the atheists.
Thank you, Darth. That was a
no, it's not Pokemon evolution. It's what they believe.
No,
look at the phylogenetic trees.
Those phylogenetic trees aren't showing that, because Pokemon evolution would be, if I have one individual organism, let's say that organism's name is Fred, right? That Fred is a fish, and then Fred transforms or shapeshifts into a human. That's Pokemon evolution. Evolution doesn't say that happens. Scientific evolution doesn't say that happens. No, it doesn't.
Yeah, it does.
You will not find. No, it doesn't.
Yeah, it does. You're saying that a common ancestor gave from an amoeba or protozoa, eukaryote, prokaryote, gave birth to everything that we see today.
Well, Centurion, it's not the atheists who believe in Pokemon evolution; it's the Christians who believe in the Pokemon evolution. Pokemon evolution.
I don't believe in Pokemon evolution. I think evolution is dumb.
Let me finish. So in Pokemon, if you actually watch the cartoon, they have a god. So Pokemon isn't an atheist show. They have a god, and they create this Pokemon. The Poke God creates the Pokemon.
Arceus.
but the Pokemon have a predetermined evolution. So it's not. So their evolution isn't random. So they have specified evolutionary. So it's still creation, but it's literally guided in their little Pokemon DNA.
But again, that goes back to SpongeBob imagination, which that evolution.
That's imagination, but because we don't believe in that. We don't believe in that form of evolution. What we believe would be more akin to if we had somebody that was blonde-haired, blue-eyed, super tall, right? And we had somebody that was brown-haired, brown-eyed, and super short. What would happen is after a long amount of time, there would be so many small changes between each subsequent generation that you will end up with a population of people that is tall, blonde-haired, blue-eyed, short, black-haired, brown-eyed, short, blonde-haired, blue-eyed, and so in these mixes.
And
but
still
the problem
people.
is, but
and there's still people.
But hold on. But that's because we're looking at the time span. In the time span of my analogy, yes, there's still people.
There's still people. That's called variation.
Wait, Centurion, let me reply. Well, this analogy is very flawed, Carlos, because you're already presupposing that you already have these variations. So you're starting with a variation to begin with, and then you're just mixing the variation. But the problem is, how do you arrive at the variation from one singular?
Exactly. Where does it? Where does the information in the DNA come from to take fish
Well,
to fish?
the problem is you're presupposing that the term, because okay, so you're having a misunderstanding of when they say we have the one common ancestor. Okay, it's like when are you familiar with Y
No,
chromosome
not.
Adam and mitochondrial Eve?
Oh yeah. Yep. And
Okay.
one of my questions was going to be for Donnie was going to be on the Y chromosome.
Okay, so one common misconception that a lot of people tend to have is that Y chromosomal Adam and mitochondrial Eve are set individuals, meaning that those individuals will never change. That is not the case. Okay, so when you're saying we came from one so far in as we can trace it back, but that doesn't mean that one is the one that did it all by itself.
By
You see
one,
what
I
I'm saying
mean
here?
no. By one, I mean one.
No,
One
Y
variety of
chromosome.
population. So you don't start off with like multiple varieties of populations. So you start with one variety of population that spreads into different varieties. And what's wrong with your analogy is that you're already starting off with a variety of populations to explain the mixing of those populations. You can't do that.
What I'm saying is that it could be the case that there was one that started, but that one in and of itself doesn't necessarily have to be the one that caused all those subsequent variations. So for example, it could be the case that we have one that reproduced, right? And then somewhere else there was another one that reproduced differently. And somewhere along the line, those two can come into contact, or several other ones can come into contact, and that causes a mix and variation. Also, we're also forgetting the fact that I'll use your terms, evolutionist notions, this is all based
Hold
off
on,
of
can I interrupt next? You guys kind of
chemical
took
things
over
that
where I
are
was
here.
going from.
Oh, sorry. Yeah, you know, yeah.
Yeah.
Yeah, go ahead, Mars.
Yeah.
Sorry.
So we really sidetracked from where this all started. I was trying to paint a picture here that based on presuppositional worldview, when you guys get into scrutinizing Kent to the 90th power, okay, he makes it clear if you pay attention to his debates, he actually even breaks down evolution of the 7 different stages, such as stellar, cosmic, and then it trickles all the way down, which he's trying to let you guys know that you guys are the ones who want to separate all these stages, because when you slap them all together, they look pretty crazy. And the verbiage of saying something turned into something, that's called figurative speech. But let me continue by going on with this, okay? By that same standard that you guys don't like when he says, a cat produces a cat. Oh, but where does that end? You guys want to get into, right? And it's pretty obvious. There's something that has a cat-like features. That's what he talks about the 4th grader or the 4-year-old being able to distinguish this, okay? But then when you guys want to talk about a duckbill platypus is a minor distinction. No, a mammal that lays eggs is not a minor distinction. This is astronomical difference. And you guys want to just chalk that off like it's just something that's a dime a dozen. No, it doesn't fly.
So, we're trying to say that reptiles laying eggs gave birth to mammals. How's that work?
Okay, that's on your worldview, right? And you have no explanation for that transition and to why the duckbill platypus is still here and where did it come from?
Exactly. Well, that's what I'm saying. They want to believe that reptiles, dinosaurs, great lizards gave birth to mammals. Laid the egg, and then
I didn't realize it was you. Sorry.
Yeah, no, that's all right, brother. That's okay.
I'm gonna jump in real quick because I want to. Well, firstly, I want to address something that
we need structure, Donny.
Yes, structure is back. So I want to address something.
Donny, I was waiting for you. My corpse basically was waiting for you.
Yes, I want to address the Iceman eventually, but first I wanted to address something that Carlos said. Yeah. And let's try and do this, gentlemen. Whoever's not talking, let's try and be cognizant of just being on mute if we're not in the midst of talk, because I do hear random feedback noises going on, and typically it's because people aren't muted when other people are talking. Otangelo, Andrew, and Ryan have all joined us, so it's good to have you gentlemen. And so we're just going to have a back and forth open mic night focusing on the topic, which is evidence for evolution. And so before I get into your point, though, Luca, I did want to, and then that's going to bring us into a whole discussion on genetic entropy, which I know Andrew is interested in engaging in. But I like to focus on differentiating lines of evidence, okay? So the evolutionary model would say that evolution is essentially changes in allele frequencies and populations over time, okay? Now, the question is, do those changes lead to large-scale evolution? I would say no, due to low impact, nearly neutral deleterious mutation accumulation. We'll get into that in a second with Iceman. But to Carlos, you were
Yes.
talking about mitochondrial Eve, Y chromosome Adam.
Yes.
So I'd be curious as to your thoughts on the Y chromosome data, which I would argue genetics has discovered the one Y chromosomal ancestor from whom we've all descended from, Y chromosome Noah. We can get into that for sure. And also the one mitochondrial DNA ancestor of whom we've all descended from. This is based on mutation rates, based on the fact that we have low genetic diversity in both DNA compartments, which means with fast mutation rates and low diversity, it is a trivial amount of DNA differences to account for, really in just a couple hundred generations. But a strong differentiating line of evidence in order to answer the question of ancestry is the Y chromosome data within the great apes. And so I'll present this, and then Carlos, feel free to respond. So notice here on this phylogeny, this picture and study is directly from the conventional literature. And so these are Y chromosomes of humans and your great apes. Evolutionists would say humans are human great apes, and then your chimpanzees, bonobos, gorillas, orangutans are non-human great apes. Now notice, the human Y chromosome and the chimpanzee Y chromosome. Okay, supposedly, according to the evolutionary story, the chimpanzee is our closest cousin. Okay, the human and chimpanzees go back to a common ancestor right here, about 6 million years ago, apparently. Now, when you examine the Y chromosomes of both humans and chimpanzees, firstly, Y chromosomes are uniparentally inherited DNA. Okay, so they're not autosomal DNA, which means you're not really going to get any recombination. You might get a little bit at the tips, but nonetheless, it's a less messy chromosome, okay, because there's no recombination, again, for the most part, scrambling of DNA differences every single generation. Okay, so that's why Y chromosome and mitochondrial DNA is a great way to answer the question of ancestors. We can build these really nice family trees and trace back to common ancestors in the past. Anyways, to make a long story short, when you consider overall gene content, size differences, and architecture, the human Y, and you can see it here on the picture, is only about 35 to 40% the same as the chimpanzee Y. You notice the gene content's totally different. The architecture is different. It's half the size. So right off the bat, you're starting at 50%. And the human Y and the gorilla Y are actually more similar to each other than either are to the chimpanzee Y. And so from a separate ancestry model, this makes sense because we would argue humans and chimpanzees are not related through common ancestry. But for the common descent model, this poses a challenge. This was not predicted. This was a major surprise. And the question is, Carlos, two questions. What are your thoughts on this? Question two, how do you account for such massive differences in Y chromosome DNA in just roughly 6 million years since the split? Go ahead, take your time.
Okay, so it's a very interesting question, particularly why I like to watch these videos, especially because I'm not much adept in biology, I would say, in terms of genetics and whatnot. So I like listening to these parts. Where I tend to focus is with regards to physics and quantum physics. Again, I'm not scholarly educated, formally educated in those, but that's generally where I look in. My thing is, what was your first question? I'm gonna go there them one at a time. Your first question was, what do I think about?
Yes, basically, what are your overall thoughts on this, just in case this is the first time you're seeing this? And then secondly, how would you, from the common descent starting point, how would you address this challenge? Essentially, you can see right on the screen the human Y and the chimpanzee Y. You can go directly in the paper. This is right from the conventional literature. So it says the chimpanzee.
So I think so. It's gonna be kind of tricky because again, I'm not too big on genetics. My thing is, from what I've seen, from what you said, those may be massive differences in terms of what. Those may be massive differences with regards to looking between these species, humans, chimps, gorillas, and whatnot. But again, a lot of biology deals with generality. So when we're comparing that to the totality of the genetic makeup, it seems to me that it's the case that quote unquote massive difference is objectively minor compared to the rest of the similarity that we share.
Well, I would argue, no, Bubbles. I want to finish my point before anyone jumps in. I appreciate that response. We can compare the entire genome. We can compare autosomal DNA. Okay. The point I'm trying to make is the Y chromosome should be relatively more stable. Okay. It does have a fast mutation rate, roughly 1 to 3 per person per generation. And there's really only a few DNA differences in the Y chromosome separating any two people. And I can demonstrate that through Y chromosome phylogenetics. But the point is, it lacks recombination. And so it's less messy, it's more stable, and that's why it's a better chromosome to look at. And notice directly from the paper, they say the chimpanzee Y is only half the size of the human Y. So right off the bat, you're starting with a 50% difference. It says the percentage of gene families shared by these two chromosomes that split roughly 6 million years ago, as I said, is similar to that shared by human and chicken autosomes that split roughly 310 million years ago. They say in the paper, puzzlingly, so they didn't predict this. This was a surprise. It's a puzzle to them. In terms of shared genes and overall architecture, the human Y is more similar to the gorilla Y than to the chimpanzee Y. Okay. So the whole point is, if common descent is true, how are you going to explain such massive chromosomal rearrangements, the addition of new gene families, the size differences, the fact, I mean, how did the chimpanzee Y become half the size since the split? And the last point I want to make, when we actually look at only human male Y chromosomes, Carlos, every single male Y chromosome on the planet, whether it's mine or yours, or if I'm looking at, Otangelo's, Luca's, our Y chromosomes are nearly identical, very little variation. Okay. And yet we have a fast mutation rate. Well, if we go back about 200,000 years to some kind of out of Africa scenario, and we're accumulating mutations every single generation, we should have a lot more diversity if common descent is true. But once we bring in the chimpanzees now, remember, the human Y chromosomes are incredibly homogeneous, little variation. That's what that means, rather than heterozygous. But then you bring in your chimpanzee Y chromosome, and you can see it right here. The audience can see the chimpanzee Y is nothing like the human Y. But if they are our closest cousin, I mean, how is that the case, Carlos?
Well, I would say first off, it's the first issue we would have here would be the fact that yes, they're our closest cousin, but it doesn't necessarily follow that it has that part of the genome has to be that much, have the same degree of similarity to ours. We know that they're our closest cousin because of how similar they are, but there's no necessity for specific parts to be the same. As far as I mean, of course, there's probably obviously certain genetic parts that I'm not a geneticist that have to be the same, obviously. But with regards to this, I'm not sure, from what I know, which isn't much, obviously, in regards to genetics, how much there's a necessity for that to be the same. As for how that happened, I would say that going off of how we we generally, those who are for evolution, explain evolution, there would be notions such as, this isn't surprising that it's different because, again, small changes, those would be aggregate of which may cause such a difference.
I got a question.
But there would have
changes-
be environmental pressures.
I understand, Carlos, but the problem is small changes won't account for these size differences. Again, it's only half the size. Notice the gene content is totally different. Look at all this heterochromatin, this these densely packed pieces of DNA here. It comprising a lot of satellite DNA, repetitive DNA. Here in the human Y, you see in the gray,
yeah,
it's almost non-existent in your chimpanzee. Like, these are massive differences. And
I don't think he would understand.
We can say
need to take place.
We can say that those small changes won't allow for that, but that's supposing a certain sample size. So one thing I think that we tend to ignore is the massive amount of reproduction that is capable by a lot of organisms. You know what I'm saying? So yes, if you want to say, oh, this specific organism can only do it so much, but when we take into the account the totality of how many organisms are reproducing in a generation, you know what I'm saying? Like, if we were just to look at today, I know today organisms are much different than they were back then, but if we were just to look today, an octopus gives birth to over 1,000 children. So even if you want to say the rate of change and variety is very small, with the sample size being that large, that's going to a creature that's small, yes, but
right,
that's a creature that exists now that's small, evolved to have a smaller sample size. You know what I'm saying?
Well,
but
Carlos,
back then there was no necessary, it wasn't necessarily the case, because again, the ancestor being an amoeba, yes.
Well, Carlos,
Donny, can I ask you something? Wouldn't that just mean that we have a common ancestor with gorillas if the X chromosome and the Y chromosome both are so similar?
Well, they do think the guys they share ancestor with gorillas.
Yes. How do you disprove that claim if someone just shifts and says, "Oh, okay, we have not the chimpanzees as our closest common ancestors, but gorillas"? So how would you answer to that claim?
I'm sorry. I don't think I'm following the question.
What Antangelo and Donny are saying is that if you look at this chart, the gorilla DNA is more similar to human than the chimps. So their question
yes, in that regard.
Yeah. So like, why are you guys drawing this this tree of evolution with a mismatching? It's a mismatching phylogeny tree. So it's
no, because that section of the DNA may be most similar to humans, but if you're looking at the totality, the chimpanzee outweighs it.
That's
it's like saying, hey, you and I, our outfits, you know what I'm saying? We're wearing outfits, right? If we're wearing the same outfit, if we have three people, you, me, and Donny, and we're all wearing the same outfit, and you and I, most of our outfit is blue, but Donny and I both have a red suitcase.
Well, here's the thing.
And then you say that red suitcase is more similar than than your gray suitcase. Yes, but the entirety of our suit is more so similar than that suitcase.
Yeah, I get these analogies, but here's the thing. I know you're not a biologist, but what percentage of DNA do you think humans and chimps share?
I believe it was 98%, 98.7%, or 97.8%.
Well, that turns out to be false. This is actually very misleading data. Do you know how they get that 98%, 97%?
Well, let me jump in before you answer that, Carlos. I want to keep Carlos focused, because before we get to the entirety of the genome, I still think my point is being missed. Is yes, we could look to the entirety of the genome, okay? Mm-hmm. But even when we look at that, there's massive gaps, unalignable regions that aren't accounted for or looked at, size differences. Okay, it's a little messy, especially when you're looking at autosomal DNA. We have scrambling every generation. Okay, my point is the Y chromosome is less messy, it's more stable, and so it should be more similar humans and chimpanzees when we compare. This is a direct prediction of the separate ancestry model.
Can I ask why it would have to be more stable or more similar?
because the Y chromosome is a smaller DNA compartment, just like the mitochondrial DNA. It lacks recombination. Carlos, do you know what recombination is?
Somewhat, I wouldn't say, I would say no, but from what I understand, it's the manner in which RNA or DNA convert into each other, and vice versa.
Well, you do have gene expression, the process by which a gene is turned on and off to produce an RNA product or a protein product. Okay, DNA
Okay.
transcribed in RNA translated into protein, the protein synthesis process. But recombination itself is basically every generation you have your chromosomes line up and they exchange genetic information with each other. That's why you are a mix, right?
That's the whole half my parents and half of each of my
Right.
parents' chromosomes. Okay.
Exactly. So you're basically a shuffled mix of your parent, of your mom 50%, and then your dad 50%. Okay. But we also have the Y chromosome, and then we have the mitochondrial DNA, which is the powerhouse of the cell. It exists outside of the nucleus. Okay. The Y chromosome is also uniparentally inherited DNA. So rather than being biparentally inherited, where you get this process of recombination, where pre-existing DNA variants are shuffling every generation, the Y chromosome, you don't get that. And you get a little bit at the tip.
Yeah, because it's only from the father, correct?
Right, because the Y chromosomes are passed down on the father's side, paternally, you're right. And so they're less messy, they're easier to look at, they're easier to build a family tree through. And so hypothetically, they should be more stable. So it's a good DNA compartment to look at, okay? And both creationists and evolutionists can agree that the DNA differences that we find in the Y chromosome are actually due to mutations. When we look to autosomal nuclear DNA, creationists explain most.
I think I understand what your question is. I think I haven't answered your question. So
Okay,
you're asking why they would be so different when they kind of, because of how they go, they kind of necessarily have to be the same. I would say they're different because it would probably, in my opinion, most have to do with environmental pressures. I would say that while it does have to be stable, it may be the case that it changed so much due to the pressures that X population was under. And so at any given point, in order to, being that evolution is about which expressions survive or not survive, allow you to reproduce. The ones that were reproducing were probably the ones that had this difference or a diminishing difference. And it could be the case that it continued to diminish in this way.
But the issue with that is, okay, and I go back to how homogeneous, very little diversity exists within human Y chromosome. So here's a human Y chromosomal phylogeny. Okay. And so this represents DNA variation worldwide. This is an unrooted tree. And these are Y chromosomes. And what we find is very little variation, very few DNA differences separating any two people. Again, the rate as to which the Y chromosome accumulates mutations every generation is fast. It's somewhere between 1 and 3, with only a few DNA differences separating any two people. Okay. It is very easy in biblical time to explain how that DNA variety can come about. So the point is, if you're saying environmental pressures might be a reason for the rapidly changing Y chromosome, well, even according to your own model, humans go back to an out of Africa bottleneck about 200,000 years ago, somewhere between 100 and 200,000 years ago. Okay. And through coalescence, that's how you explain the one Y chromosomal ancestor that we have. So why aren't human Y chromosomes more different? How come we don't find any really divergent people groups globally? We don't find that. And so if environment was dictating a rapidly changing Y chromosome, we should find a lot more differences in the human Y chromosome, but we don't. Then we bring in the chimpanzee Y chromosome and it's nothing alike. And I feel like these are just so stories, and I do appreciate your responses, but they're certainly not scientific, because you're going to have to present a highly sophisticated mathematical model, Carlos, to explain how in 6 million years you go from a Y chromosome that's basically the same to one that's only about 40% the same when you consider overall architecture, gene content, and size differences.
Well,
this is a major challenge. Go ahead, Carlos.
I would have to disagree on the basis of being that my point was about environmental pressures. It is important to highlight the fact that our evolutionary characteristic is our brains. So would you agree, Donny, that we can live in places that most animals generally would not be able to branch out to, simply on the basis of our intellect allows for a capacity of technology that allows us to endure such climates?
Yeah,
And how did that
if you're talking about brain function, like right here, here's a paper from the conventional literature.
No. What I'm asking is, would you agree that because of how smart we are capable of living, of circumventing certain environmental pressures? Like, we can live in places that are too cold for humans to live without technology, correct?
Well,
we can live in places that are too dry and dangerous, like, deserts, to be lived in by humans without technology, i.e. clothing, fire, tools, correct?
Right, through tools, fire
Okay,
making.
so
and
so
we
my point
understand this-
here, my point here, Donnie, is that you cannot say that the environmental pressures works against my argument, because environmental pressures causes that difference for those other species, but we are so smart essentially that we circumvent those environmental pressures. What normally would happen, and this is a key point that I think a lot of creationists miss, is the impact that our intelligence has had on even evolution itself. Because we can look at dogs, for example, right? People tend to say, why don't we see evolution, macroevolution happening nowadays? Why don't we see it in the lab? I would argue we could. But first off, there's a lot of hurdles we'd have to jump through. If we brought up the notion of, like, just look at cloning. We can't even do cloning technically without the legal issues, that people have with morality and whatnot like that. So to say, hey, we're gonna take this animal and we're gonna put it in tests where we're forcing them to reproduce over and over and over until we get something different.
I'm going to jump in.
An ethical issue that societally we may not allow.
I feel like you're ranting. You're not answering the question. We're going to leave it up to the audience. You have not provided a single good reason as to why the Y chromosomes between humans and chimpanzees is so incredibly different. You haven't provided, and that's okay. You haven't read the paper.
I think I did. My answer is that
environmental pressures is not going to change a Y chromosome.
It's that other organisms are subject to environmental pressures and we aren't.
No. Environmental pressures is not going to provide massive chromosomal rearrangements, okay, in the chimpanzee line. It's not going to alter the Y chromosome to the point where it's literally half the size, where apparently if chimpanzees and humans go back to a common ancestor 6 million years ago, the Y chromosome in the chimpanzee, it's essentially been broken off. It's only half the size. So a lot of the genes aren't even present in the chimpanzee that are present in the human Y chromosome. So the point is, the most parsimonious explanation for this challenge is the separate ancestry model. This is what we predicted. One Y chromosomal ancestor of all people. Okay. This is what we find in DNA. And the fact that humans and chimpanzees aren't related. And this is what we find in terms of the Y chromosome dissimilarity. And so I would just challenge you to go to the drawing board and provide a sophisticated mathematical model, not just, environmental pressures. Okay, I mean, you can believe that.
And sample size. It's not one thing. It's several factors. And I think trying to reduce it down to one specific factor is problematic.
So hypothetically, if the Y chromosomes of chimpanzees and humans was a lot more similar, what would you say? Let's say they were 90% the same. What would you say?
So I don't, again, I'm not too exactly, you gave me a little rundown of what they do, but I'd have to look more exactly into what they do to exactly say, to give you an answer to that. So I don't want to
if they were I'm saying if they were highly similar, would you conclude common ancestry, similarity due to common ancestry?
I would say, again, probably not, because I don't think the fact that part is specifically similar or not matters. I think it's, again, the matter of totality, because that's generally what we look like.
Carlos, I got a question. Would you appeal to like different mutation rates to explain this away? Would you say the mutation rates were different?
Sorry.
I'm not sure. I would perhaps maybe from what I know now, maybe it could be the case that there are varying mutation rates in different organisms, and at a prior point in time, that may have been something that was prevalent. But I'm not sure too much, again, about what the mutation rates. 'Cause I've heard that we can guess those mutation rates. So
Well, I don't think there would be
or
anything
calculate them. My bad.
Actually,
Well-
before you talk, Bubbles, I just wanted to. We got Theo who just joined. I'm not familiar with who Theo is, so I just have to vet him. Theo,
Let
can
me
you
mute me.
quickly introduce yourself to the panel, just so I know that we're dealing with somebody legit? Theo, a real quick intro.
Yeah, I am Theophilus. I am a creationist.
Okay.
I love watching your channel. Hey, is this? I have some. I would like somebody to look up the 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 new discovery of about the Big Bang, about the Big Bang.
Okay. Theo, I appreciate it. We are currently discussing evolution and genetics, and so we're going to stick to that for now. But that's certainly a great topic, the Big Bang. So, Theo, feel free to stick around. I'm going to bring us back to the topic at hand. Carlos, I will say,
Pardon me. Sorry, Donny, sorry to cut you off. I just want to say, Donny, if you do have a debate about like physics and stuff like that at some point, let me know. I'd love to get in on that. Physics is such a fun topic.
I can debate physics with you.
Okay, so I'd like to bring us back to specifically Luca as the first hour with Luca versus
Donny,
right?
while you present your argument, I'll have breakfast because I'll go to work in very, very soon. I'll leave in 10-15 minutes max because I really need to. So
let me ask a question before you
I
leave.
did wait for you.
Well, hey, Bubbles, don't worry. You're going to get a chance, but I do
Well,
want to give Luca the respect because he's been looking for an answer to the Iceman. And so I've got a couple responses, and feel free, everybody can get in on the fun.
Okay,
for this
just keep
topic.
it short and don't hog the whole debate again. I know you're a debate
Bubbles,
hogger.
we want to stick to the actual topic of evidence for evolution. And as creationists, we need to stick to differentiating lines of evidence. Okay. There's no sense in arguing all night about non-discriminatory lines of evidence. Notice how I brought the Y chromosome dissimilarity to the table, and it actually demonstrated the power of the separate ancestry model, because that is a line of evidence that only the separate ancestry model can explain. And we got a number of powerful lines of evidence.
I think that was a good question, being that I don't do biology much. So,
but you brought it up.
It's something I should look up. Well, no, I brought up Y chromosome.
You brought up you brought up
but his specific point is something I didn't know. I brought up the general understanding, the layman's understanding, because I know the layman's understanding. But I'm saying that his question was a good question because it's something for me to go and look at, because I didn't dig into that part of the biology again because I'm not into biology like that. So it's a good question for me to go and look into.
Well, you would be able to appeal to different mutation rates. That's one thing you can do with Christians.
Yeah.
Well, differing mutation rates is not going to account again for a 70% difference. Okay, varying. We already know that the mutation rate is high in the Y chromosome, and yet, according to the evolutionary model, they have 200,000 years for humans to accumulate mutations and novel genetic diversity in the Y chromosome. And guess what? The Y chromosomes of human men are extremely homogeneous and not heterozygous or heterogeneous. Okay, but if varying mutation rates in terms of some chromosomes have faster mutation rates, which is true. Okay. If that could explain the data, then the human Y chromosome should be more different than it is. And so that's not going to work either.
Well, Carl's going to.
Hey, Donny, I got a question for you.
Yeah,
Donny, I got a question for you. Hey, on that paper I sent you on the sequencing of the Y chromosome, now that it's been totally sequenced, and this is a paper from August of this year, 2003, how much more difference would there be now than with the that it's been sequenced? And I think it said that there was 30 million new pairs added and 41 new protein-based genes. How would that now compare to the chimpanzee, the fallacy of the chimpanzee comparison or the great ape, now that it's been sequenced?
Well, typically the better sequencing data you get over time, the more dissimilar and the more divergent these creatures get. And so I would argue with better Y chromosomal DNA data and sequencing technologies, it'd be an even bigger problem. But I find it funny because it doesn't even have to be a bigger problem for them, because already it's a massive problem. I think, as the audience could tell with the visual, the Y chromosomes between humans and chimpanzees they're nothing alike. I mean, the gene content's different, the size differences are different, the architecture is different. Go ahead. I hear someone talking.
Yeah, can I ask something to Luca before he leaves? I know
Yeah, go ahead. Go ahead.
So, Luca, in the actual topic of the debate about evidence for evolution, do you think don't you think you should have genetic evidence for evolution? Do you hear me, Luca?
Yes, sorry, just very, very tired.
Okay.
Yes, genetic evidence for evolution. You are asking me if there are genetic evidence for evolution.
Yes.
I think there are, and I did bring to the table.
Well, your whole Iceman argument was
Iceman. It's a different thing. It's about genetic entropy.
What is this Iceman thing?
Evidence for evolution could be the one that I brought up with the wheat. How we know that genetic information, I do not like that term, is increased during the time.
Well, here's the thing. Well, here's the thing, Luca. Let's see. What's the question I was going to ask? I freaking forgot. I mean, you are a biologist, right?
I am. Sorry, what?
Are you? I think you have a PhD in biology, or like, are you an
evolutionist? No, I do have a degree in chemistry. No PhD there. I'm not a doctor.
Okay, so I thought you were just like a college educator on evolution. Well, let's see if you actually have genetic evidence for evolution, which I don't think you guys have genetic evidence for evolution. For example, according to evolution, the Dalmatia originated from the gray wolf, and if that's true, well, the question becomes simple: provide to us one single transitional between the Dalmatia and the gray wolf. Can you do that for us there, Luca?
I did something similar with bubblegum gum, and I did show a chart where you can see the between those animals.
Yeah,
so
there's
yes,
nothing.
You can show something in between.
Well, there's none. There's nothing in between, actually. If you actually bring up those,
there is nothing.
No, there's nothing. So
even for creationists to get from a wolf to a dog, it's not a problem.
Well, it doesn't matter
not
what
even
the
a different species. It's more like a subspecies.
Well, it doesn't matter.
You can still have.
We already believe that wolves and domestic dogs share a common ancestor. Bubbles. This is not a differentiating line of evidence.
Yes, it is. Please,
listen.
So it doesn't matter what the
agree that domestic dogs and wolves share a common ancestor. Maybe the polytheists of the world, like you, don't. Okay, because I want to address. I'm the host. I'm the moderator. I want to address Luca's argument that he's been looking for an answer for.
Well, I'm asking a Luca
since the beginning of the debate with Iceman. Okay, you've asked your question. Is there a transitional form between a Shih Tzu and a Dalmatian?
Well, he didn't give me one. I'm asking for him to give me one.
You are bubblegum.
But it's not a differentiating line of evidence or even questioning.
Yes, it is.
Creationists already agree that Dalmatians, Bulldogs, and Shih Tzus and Great Danes are related to common ancestry.
No, Christians believe in Pokemon evolution. They're not technically creationists.
Okay, Bubblegum, I want to address Luca's actual argument that he brought up in the debate. Okay, if you want to engage genetic entropy, Bubblegum, then feel free, jump in. None of this show me a transitional form between a Dalmatian and a Great
A
Dane.
great wolf.
We're not getting anywhere with that. Okay.
Yes,
Let's
that would be
focus on the differentiating lines of evidence. Let's get into
because I'm asking
the
about
meat
actual
and
evidence
potatoes
for
here.
evolution. So I'm asking for actual genetic evidence for evolution. This would be actual genetic evidence. So it's not an inference.
So,
if you
Bubbles,
don't,
it's your position that domestic dogs are not related, correct?
well, I'm not an evolutionist. No.
Evolution, as in the theory of evolution, is descent with modification, the model or theory that says all life is related through common ancestry.
Well, yeah, Charles Darwin wasn't the first evolutionist. I think a lot of people are misguided by that. Charles Darwin only came up with the natural selection, but evolution existed prior to Charles Darwin, and Charles Darwin got his ideas from Christians.
Okay, well, I appreciate it, Bubbles. Luca, before you leave, so Iceman, I don't believe it is a rebuttal or response, and feel free to engage with me on this issue because you brought it up with Paul Price as well. I don't believe that the existence of Iceman from X-Men, no, I'm just kidding, Iceman that they discovered from supposedly somewhere between 4,000 and 5,000 years ago is a challenge to the genetic entropy thesis, okay? Couple reasons why. And before I get to those couple reasons, let me point out, if you actually look at the details in the papers themselves of Otzi, he was riddled with degeneration from the environment that he lived in. Apparently, he was riddled with Lyme disease and all types of problems and issues. He was definitely beat.
Well, let him answer my question first.
What's your question?
The Dalmatian question. So
let him answer real quick. Then we're going to get back to the actual topic.
Bubble, I did answer. I did a stream of 2 hours with you, if you remember.
Yeah, and you never presented in an actual transitional.
Slaughter, to be
Luca, at what point in that discussion did you present a transitional that existed?
Because it's almost 5 a.m.
Luca,
yeah,
at what point
I'm jumping in, Bubbles. Bubbles.
I'd love to talk with you. I'm not against it, but I think it's not the time.
And it's also not really the topic because
yes, it is.
No creationist. And are you going to interrupt me again, Bubbles?
Well, I'm asking him a simple question.
I'm trying to answer a question that Luca actually a question to an objection that Luca actually brought up in the debate. That's what this is. This is an open mic about the debate. So the existence of Iceman is not a challenge to genetic entropy, Luca, because even according to the young Earth creation model, going back 4,000 to 5,000 years should not provide us with tremendous evidence for genetic degeneration. Because remember, this is a problem for evolutionary time scale, where you actually have hundreds of thousands to millions of years where there is what's called
Donny, can you please let him answer my question first?
Fixation equilibrium. Bubbles, do not interrupt me one more time or you're getting booted for the night, okay? We're not talking about transitional forms between organisms that we all agree are related, like domestic dogs, okay?
This is
not edifying to the audience that comprises 0 people who would deny the fact that all domestic dogs are related, okay? This is not going to answer the question of ancestry.
So, question about
to answer your question, Luca, it's not a problem because, again, 5,000 years or 4,000 years is not enough time for us to see the significant level of genetic degeneration that we would argue exists if evolutionary timescales are true. And therefore, fixation equilibrium is a reality. Okay, this is a mathematical reality, and what that is basically your nearly neutral mutation rate, your per generation mutation rate, as you can see here, equals your long-term substitution rate or fixation rate, because evolutionary timescales allow for fixation equilibrium. So, say the mutation rate's 50 per generation. That means 50 are also becoming fixed in the population per generation if evolution is true. And that is irreversible and irreparable damage every single generation. And so if you go back hundreds of thousands to millions of years, that is a problem that puts shelf lives on genomes. You don't have hundreds of thousands to millions of years in light of this challenge, in light of the reality of fixation equilibrium. But we're not going to be able to see that in 4,000 to 5,000 years. And so if Iceman's genetics are very similar to us today, yeah, that's expected, because that's not what genetic entropy is saying. Luca, go ahead. How would you respond?
Donny, the problem is in your model, not in mine. Otzi, it's a very good example. Why? Because in your timeline is very, very close to the flood. If it's 5,000 years old, is before the flood even.
Yeah.
And that's quite a challenge for a creationist.
Well, no, Iceman wouldn't be from before the flood.
Sorry.
He's post-flood.
I give to you
Iceman's
that
post-flood.
I don't care. Let's say that is 4,100 years old. For this discussion is not important.
Okay.
The problem is, if Otzi is close to the flood, it will have genetics very, very close to Noah. And in your model, that's important. If Otzi is very, very close to us, why? In your model, you should see a degradation over time from the flood to us. If we are not degrading fast enough to see that degradation, we cannot prove your theory.
Wait, I want to ask you, Luca, was Otzi's genome, was it degraded? Did it have the accumulation of deleterious mutations?
I think that Otzi DNA is very, very close to us.
So it is. Are you saying so? It's accumulated a lot of mutations
for your model.
Well, I want you to be more specific, Luca, and I apologize because I want the audience to understand.
Yes.
When you say very close to ours today, are you saying it has or hasn't accumulated a lot of mutations?
Of course, it does have mutation, but I need to see that DNA has degraded in a
it's only but
way
4,000 to 5,000 years is
better
nothing.
than us.
Oh, that's not how it works, because there's many influencers, Luca. Would you agree that a small population, let's say Neanderthals or Hobbit, or you can even take Naledi, does a small population, will they accumulate more recessive mutations over time than a larger population?
True, but we are not talking about that. Otzi is a full human, and we do have his ancestor today, so we know that it did not have that kind of problems.
No, but you're saying his genetics were close to us today, right? Humans?
Well, it's a human, and I think that it's pretty close. 5,000 years in evolutionary time is not that.
Well, Luke, I want to. So here's the thing. This is consistent with the young Earth creation model, because if we've only existed for 6,000 years, or specifically 4,500 years since the flood, well, answer me this: how large is the genome, the nuclear DNA? How large is it?
How large? What do you mean in
how many
base
nucleotides?
pairs?
Yeah,
Because
how many
I
base
do not
pairs?
know that. 25 chromosomes. You mean that? What are you
Well,
asking?
if we go by haploid, then we're 3.3 billion letters, right?
Okay.
We're about 6 billion. Mom and dad, 50% from each. So the point is, we have a lot of base pairs. When we're talking about autosomal DNA, where we accumulate 100 new mutations per person per generation in autosomal nuclear DNA, okay, those are mutations. Yeah, that's a high mutation rate. But on a DNA compartment that has a lot of base pairs, okay, so if young Earth creation is true, and we only go back 4,500 years to the flood, and we're looking at a post-flood human being like the Iceman, and we're looking at a human being today, then yeah, there's not really going to be that much of a difference, because that's only about 4,500 years of mutations accumulating in a genome that comprises 6 billion DNA letters. So you're not going to see a whole
Donny,
lot.
and I ask you this, and then I go because I really need to go.
Of course, Luca. Yeah.
To see that difference, because after the flood, people in the Bible were living for hundreds of years. What we should find? Oh, sorry, I think that someone is trying to tell me to shut up.
Luca, yeah, real quick. Well, Luca, you've really given us a lot of your time. We did hit the 3-hour mark, and that's what you agreed to give us. And so I don't want to keep you any longer than the time you offered, as I know it's been a late night for you. I could answer that question quickly, and then you give a final word if you'd like. But again, I want to respect your time. So how would you like to proceed?
I think I must go. We can talk about it later.
Yes.
Another time. So good night, Donny. And I really need to go.
Luca, appreciate all the time that you've given to us for tonight's epic 3-hour show so far. Time has been flying by, lots of good discussion and topic. You and I will set up just a one-on-one show where we can go into the nitty-gritty of genetic entropy and Otzi the Iceman. So, Luca, we'll see you later. Appreciate your time.
See you.
Okay, so good to have people here. Maybe Otangelo, you've been sitting patiently, brother. Is there any thoughts you had? Is there anything you wanted to bring up? We do look like we got a decent mix of, we got at least a couple evolutionists here who might want to engage. And so Otangelo, always a pleasure, my brother. You do some great work for the Lord. And so how are you? And what would you like to discuss?
Yes, thank you, Donny. It's a pleasure to be at your channel. After a long time, I've been absent in the English-speaking region for several months. So, yeah. Well, I am studying, actually writing a book on evolution. And what I can see as a general thing is that the view that only genetic information defines organismal form and complexity, that has been overcome in the last 15 years or so. And the more science is investigating, the more it is not genetic, but in special other codes. And I have recently discovered, I had about 50 epigenetic codes listed until recently. And with ChatGPT, I discovered there are 230 different codes operating in the cell. So this is a huge number. And what is even more staggering is that many of them, they work in interdependent fashion together, and they are also crosstalk together. And that means that in order for you to have a system or anything biological, you need to have these codes and languages instantiated together. Because if you have only one language and you don't have another, you cannot instantiate certain things of multicellular organisms. So this is, in my understanding, very powerful evidence that complex organisms, they have to be constructed from the beginning in all their complexity, and there is just a limit up to what point they can actually adapt and change in their physiognomy and adapt to the environment. And the claim that the tree of life is true and that all life forms, they have a common ancestor, that is simply not evidenced.
Well, what the atheists are saying is not that a cow gives direct birth to a platypus, but it is the accumulation of microevolution into the macro. So what in your worldview stops the micro from accumulating into the macro?
Yeah, these micro, I would better describe that as adaptation of an organism, which has to be inbuilt since the inception of life itself, because if the organism cannot adapt to the environment, it will immediately die. So there are mechanisms like heat shock proteins and signaling pathways which detect the different environments, and then based on that information, the different protein species will be expressed in order to the organism to be better suited to adapt to the environment. So this would be adaptation, which commonly is called microevolution. But the mechanisms to actually build complex multicellular organisms, there is also something which I recently discovered. I had up to 17 different mechanisms listed, and now I am up to 47. And these 47 mechanisms, they also work in an interdependent fashion together in order to construct these multicellular organisms. And that means to me that evolutionary mechanisms are completely inadequate to explain the organismal complexity that we observe and see in the natural world.
So you're saying it's built in, right?
Yes.
So you're saying, like, for example, let's say take a dog and a wolf. The genomics for a dog would already be within the wolf, correct?
I would say this, that there is limited common ancestry, speciation. This is observed. There is no doubt about that, and creationists and intelligent design proponents do not doubt about this. Now, where the limit is, this is something which nobody has really an answer for. This is a difficult problem in biology to make a drawing line.
But you would say, like, the genomics for a dog are within the wolf, right? So they're already there.
It is commonly assumed that dogs, they have a common ancestor, which is a wolf.
So you would say they're already there, right? Those genetics for the dog are already there.
Yes.
Okay. So, like, yeah, this is like Pokemon evolution. So, for example, in Pokemon, the evolution for Charizard, it's already in the Charmeleon. So it's already in there. So, but you're saying there wouldn't be. So you don't say there's a limit or an identifiable limit, right? To the microevolution.
For what I know, science doesn't have a clear cut.
I'd like to point out that I think you have a misunderstanding of the word adaptation. I also have issue with the notion of DNA as a code, but we'll save that for later. You're using the colloquial sense of adaptation. So in the sense that, human beings can adapt to their environment. Like if you right now went out to somewhere that was super cold, you can adapt in such that, you can find ways to keep yourself warm. If you give yourself time, you can actually get used to a certain degree of coldness. That is not the same as when we're talking about evolutionary adaptation, which is something that is gained as a consequence of reproduction. So, for example, a proper notion of adaptation would be, we have this population of organisms in an environment, right? Let's say woolly mammoths, right? Now, it is not the case that what's going to happen is we're looking for woolly mammoths that are shedding their skin more or that lose all their hair. What happens is the woolly mammoths that already have less fur or will shed more are going to produce more woolly mammoths with that same characteristic. It's not the case that one woolly mammoth is actually gaining or losing the ability to do that thing. It's that the offspring that it's producing will survive based on whether or not they have traits that meet the conditions of the pressures.
Well, here's the thing. He's saying they already have those traits, and they're simply shedding those traits off. So they're losing this DNA. But if that was true, there should be genetic evidence for that. So he should be able to show a wolf today that still has the genomics for a potential Dalmatia.
Yeah, one big problem is that you cannot actually measure I forgot the name now. I forgot the name. I'm sorry, but yeah, differential reproduction. You cannot measure that, and that would be necessary in order for you to actually know if a specific allele variation or change would be selected for and then spread through the population based on a certain environmental condition. You cannot measure it because there are many different factors involved which are unpredictable. And this is a big problem in evolutionary theory. And this is something which basically makes the theory unpredictable and non-scientific.
I disagree. This is the one way that entropy is somewhat properly used when talking about genetic entropy, because genetic entropy, when you're using the word entropy, it's being used incorrectly, honestly, if we're talking about how it goes for quantum mechanics. Because with genetic entropy, you're talking about the accumulation of what's the word? Deleterious mutations, I believe.
Yeah.
Which is in no way similar to the quantum mechanics version of entropy. And yet they still utilize the whole notion of lost information, which most people do not understand what that means with regards to quantum mechanics. Which is why I said if we were talking about quantum mechanics, it's probably a whole different conversation.
I have no idea what quantum mechanics has to do with evolution, but you need different.
I'm just talking about the fact that it uses the word entropy. It's just funny to me.
The thing is that if you look at the big transitions in life, and with this I mean from a last universal common ancestor to the three domains of life, or to go from a unicellular eukaryotic cell to multicellularity, or from multicellularity to mammals and other kind of more complex organisms. That means you need entire new systems, and they cannot just arise individually. If you want to have a new limb, you need new tissues, you need new veins, you need new nerve systems, you need new neurons, you need new brain cells which can interact with these new members of the body. There is a whole lot of new things which have to arise together. You cannot have just one thing. And the small example here is if you want to go from a unicellular to multicellular organisms, you need two fundamental innovations. One is cellular signaling and communication, new pathways and codes and languages, so that these two new cells that they can interact together. And you need also membranes that have proteins that they can stick together. And you need to have these two innovations together. And if you have just one and not the other, no deals. You cannot move from one situation to another. And this is much more accentuated when it comes to, for example, explain the origin of a new limb of a body. These are huge, complex systems which have to be innovated, and you cannot explain that by simple evolutionary changes. That is simply an inadequate explanation.
Well, they could the atheists could simply say genetic recombination. For example, one populations of cells over here could have a built upon a RNA strand, and then a different population over here build a RNA different strand, and eventually these populations will intermix, and that RNA strand will migrate from one cell of that population to the other cell of that population. And they could use this to explain the sudden arrival.
Yeah, these are simplistic explanations which are completely inadequate to explain the fact that you have huge interdependence and irreducible complexity in these systems. You have many signaling pathways which have to work together. You have, as I said previously, 47 different mechanisms that are in place to explain development and organismal complexity. And these mechanisms, some of them, they work together in an interdependent fashion. So you cannot have an innovation of one new code and not the other. If these two codes talk to each other and they crosstalk and need one and the other to work together.
Well, are you saying it's impossible for like cells for like an E. coli and like a different virus to share their genetic information?
No, horizontal gene transfer, that is something which is very common, which is even life essential in order to have genomic variety. But that's not what I am talking about. I am talking that in order for you to transition in the big changes, you need huge amounts of new structures, new cells, new types of cells, new codes, new signaling pathways, new kind of cells. So these distances, they are enormous, and cells, they always they work in an interdependent fashion together.
Some people would consider the leap from a wolf to a dog enormous, but you believe in that. And so to go from a single cell to a multi-cell shouldn't be any more of a further leap.
Well, as I said, if the genes, if the possibility for a dog to have this variation is already inbuilt in the genome, so that explains it. And we see huge evolutionary changes in a very short period of time. We can even observe it. There are some lizards in Africa which change from one system of reproduction to another in a few generations.
But I think you're doing exactly what Darth said. Still, is that you're still acting as if these macro transitions, you're saying going to these macro transitions is not one lump sum. That's the point he's telling you. It's not one lump sum. You're saying that, yes, okay, so a certain structure needs this thing and that thing, otherwise it can't exist. True, but it's not the case that one, that thing just came into existence already set up, and two, that's not an argument against the notion that there is one thing that has a property that has the one property and another thing that has the second property. And as Darth was saying, those two things coming into contact and producing something that has both those properties and is thus the structure in question.
I'm going to jump
I
in.
don't know how. Yeah.
I would argue that the biggest reason why you're not going to get these large scale changes, you're not going to get a single-celled like organism into a multi-celled organism, into a fish, into an amphibian, into a reptile, a mammal, and eventually man, is because your mechanisms to do so of genetic change, of evolutionary change, natural selection, and mutations providing the novel source of genetic variation for selection to act upon, they are very severely inadequate. And the thesis of genetic entropy, Carlos, it's not to be confused with thermodynamics, although I would argue there is an overlap. It simply has to do.
If I may, real quick, sorry to interrupt you. I know it doesn't. I'm just saying that I was just trying to point out that I think it's funny that the word is used and then given a whole different definition. I just think that's funny because there are people that I've interacted with that then go and try to bring up the whole second law of thermodynamics. And I'm like, that's not what genetic entropy is about. It has nothing to do with thermodynamics. You're definitely right on that. I'm not trying to say that it has anything to do with quantum mechanics. Okay. I think it's funny that they're using it when it doesn't.
I appreciate that.
Sorry, continue though. I'll mute myself.
Maybe I can add, I had recently a good conversation with a theistic evolutionist scientist, which works in the field. And we had a private discussion, and I tried to understand why he is a God believer and nonetheless proposes evolution. And basically what he said is that those which actually work in the field, they see that there are much closer, much less diversity at the advanced animals when they are phylogenetically compared together than at the root of the tree. So at the root, there are huge differences. Like, for example, from a bacteria to go to a eukaryotic cell, these are immense gaps which science has absolutely no explanation for. They come up with endosymbiosis, but there are over 20 different hypotheses which they try to bring into the discussion to overcome these gaps. But that doesn't solve the problem. And he actually admitted, and he said, well, I can admit actually that probably evolution doesn't explain the origin of the 3 domains of life. Now, in regards of advanced organisms, the differences, the genetic differences, they are much finer, much smaller. So I was not able to go much more into that, but I think this is an interesting thing that he brought up.
Can you, by any chance, name one of those major differences, Otangelo?
Well, the structure of the eukaryotic cell is much different. It has a nucleus. It has a much bigger size, volume size. It has organelles, many different things that prokaryotic cells do not have. I have actually made a new list. I have actually made, let me finish, please. Let me finish, please. This is important. I made actually a list, and I can put it here in the side chat, of 52 reasons why universal common ancestry is not true, and the differences between the 3 domains of life. From a list of 10, I went up to 52 differences.
Are any of them genetic?
Well, I will put the list here in the side chat, and then you guys can look it up. I think it is pretty.
I'm not terribly interested in reading your list there, unless you can give me a few examples, to be honest.
Well, for example, the ribosome is of the bacteria is different. The RNA polymerase is different. The cell membrane is different from archaea to eukaryotes, and so on. There are many differences.
Well, of course it's different from archaea and eukaryotes and bacteria. Archaea tend to live in very hostile environments to other life forms. That's not very much of a surprise.
Well, yeah, I mean,
are they also made of phospholipids?
I mean, with pseudoscience, you cannot tell away everything and say, well, that's not evidence, well, that's not remarkable, and things like that. But that's not the way it works.
Well, the atheists would say the same. Wouldn't you say that microevolution is evidence for evolution?
Yeah, but the type of change
it's not like
the type of change you're typically getting when it comes to micro variations within a population, they're usually reductive if we're looking at mutations, or they're non-reductive epigenetic adaptive episodes, or when it comes to true speciation episodes, like we see with Darwin's finches. We recently, I think it was 2017, we witnessed a new species of finch form, and it was through genetically a shift in heterozygosity, that's just more allelic variability, to less heterozygosity. So basically a shift from more heterozygosity, or from less heterozygosity and more homozygosity. And so over time, through these speciation events, you're not going to get any large scale changes, any true changes from pond scum to people, because organisms hit walls. More and more genetic variability is lost over time. And at the same time, more and more deleterious mutations accumulate over time. And so that's why my question to the panel, when it comes to genetic degeneration, just the fact that genomes are going downhill, and also to Bubbles, who is saying enough micro evolution could lead to macroevolution. And so young earth creationists are basically evolutionists too. No, that misunderstands the design diversity hypothesis, where over time, more and more shifts in heterozygosity to homozygosity means animals are losing the ability to vary. And so if you go back in time, yeah, animals have more levels of heterozygosity and so more ability to change. But as time goes on, you eventually get creatures like a Chihuahua, where you're not going to get. Go ahead.
It's not
I
that
don't
they
see why
hit
that's
a
a problem
wall.
then.
It's not that they hit a wall. It's that they hit a new species. For example, from the wolf to the dog. It's not that the wolf hit a wall. It's that it hit a new species.
If I may, I don't see. So now I'm confused, because then I don't see what the issue is here then, because if you're saying we hit a wall, then how can you on the other hand say, well, we don't see that kind of evolution happening today? Of course not. We hit a wall. I'm
Let
confused.
me give you an example.
It's contradictory, honestly.
Andrew asked me about the difference. For example, we have in eukaryotic cell the histone code, which isn't extant in bacteria. And in order for you to have communication, you need a sender, you need a information transmission system, and the receiver. And the receiver needs to understand what the sender is sending. And you have all this in the histones. In the histone tail, there is encoded information which then specific machinery can read. And then based on that information, there is an entire orchestra going on in regards of gene expression, which doesn't exist in bacteria. So you would need to evolve at the same time several new things in order to instantiate this entire new way of gene expression. How do you do that? By unguided evolutionary means. You need a new language. You need the mechanisms to read, to write on the histone tail. You need the mechanisms of the proteins which read the information and then actually on that order of that information then express, open up the histones in order for the DNA being able to be read by RNA polymerase, or closing it in order for not being able to be read. So these are entire new systems which would have to evolve at the same time. It isn't enough that you have suddenly a new epigenetic code language if you don't have the hardware actually to use that language.
It's not that they evolve at the same time, Angelo. It's that they evolve together. See, evolution is a net. So a population of cells over here can have a mutation for a new protein, and they could infect a mammal or a reptile and then pass on that genetic information to the reptile.
Well, we're not quite at the reptile mammal.
This is about the transition from a bacteria to a eukaryotic cell. And if you have the new code, the epigenetic code, but you don't have the machinery to write on the histone tail, the machinery actually to read the information, and then the erasers to remove the information and then to rewrite on the tail. If you don't have the hardware and the software new together, no deal. You can have all these proteins which read and write on the tail, but if you don't have the code and the language, no deal. So this is something which has to emerge together.
Are you talking about abiogenesis?
No, this is a bit of the transition to go from a prokaryotic cell, from a bacteria, to a eukaryotic cell where you have histones, which have histones tails, which then can be used as an information carrier. And based on that information, then the whole orchestration of gene expression in eukaryotic cells takes place.
Like I said, Intangelo, evolution is a web of life. So these cells, there could be a population of cells that specify on one specific part of the gene, and a bunch of other populations that specify in their own section of the gene, and they could intermingle. And of course, you would accept that cells could do exchange genetic information. And so one of these new populations of cells that share that genetic information could
Okay,
arrive.
I'm jumping in, Bubbles. This is storytelling. The differentiating line of evidence here, and I appreciate this, gentlemen, is the fact that in order to take a single cell-like organism like a bacteria into a whale over time, indirectly, natural selection, mutation, reproduction, or the recombination, gene flow, all these things, I understand. But the point is you require millions to billions of years. You don't have millions to billions of years because deleterious mutation accumulation, which is a real problem. Remember, the vast majority of mutations are deleterious, as we can see on the screen here. So let's speak to this gentleman, okay? And the vast majority of mutations are also neutral or nearly neutral. And so selection can't see them. And when selection can't see them, they're subject to what? Can anyone answer that question? If a mutation can't be seen by selection, what's it subject to?
That's true, Donny. And the problem is,
Stacking?
let's
I don't know.
suppose
No,
you
wait,
have.
I'm looking for an answer to my question. If a mutation is nearly neutral, what's it subject to? Anybody can answer.
They're subject to drift, but they're also
Right.
technically subject to selection as well. That's not what nearly neutral means anyway.
Well,
the genetic drift will never produce you a new system of hardware and software, because just to have a new protein, for example, a reader of the histone code, that is already.
I'm not entirely sure how to respond to your argument,
please? Can I
but I
finish,
will
please?
say,
Andrew, can I finish, please?
I mean, you kind of already made your point, so I'm not sure what you're trying to say anymore.
Guys, rather than, because now we're at 3.5 hours, rather than everybody giving long statements, let's cross-examine each other. Let's have some free-flowing discussion. Okay. So Andrew,
Sure.
I appreciate what you said. Yes, mutations that are neutral. We can argue what nearly neutral, effectively neutral means. Okay. They are subject to genetic drift. What that means is they spread randomly throughout the population. And according to evolutionary time scale, what they do is they drift to fixation. Okay, we have a fixation equilibrium, which means the amount of mutations that accumulate per generation, neutral wise, that equals the fixation rate. And so the bigger picture in all this is you don't have millions of years to take single-celled like ancestors into highly complex organisms, okay, with novel proteins, novel systems, so on and so forth, because deleterious mutation accumulation puts shelf lives on genomes. So Andrew, feel free to respond to that, and we'll go from here.
So before I go into some of the more fundamental issues with this idea of genetic entropy, I will say, I think it was a slide you pulled up earlier that was talking about what you were just saying about the neutral mutation rate equaling the substitution or fixation rate. I think that was a book by Foytoima, right? Did I read that correctly?
Yeah, Patuma.
Okay, so I actually have a textbook, I think a newer edition by Foytoima in front of me, and he actually acknowledges that purifying selection and other factors can reduce the neutral mutation rate compared to the what he calls the total mutation rate. So he is saying it's what he's talking about there is a simple molecular clock. It's approximate. It doesn't take into account like selection and some of the factors involved with drift, which there are some more complex molecular clock-like models out there that do. I don't know exactly where they're used, but they are used in certain places. So,
but the whole reason why,
colonization.
I appreciate that. The whole reason why they're called neutral in the first place, even according to the evolutionists and the evolutionary scientists, is because they're not subject to selection. And so by you saying, well, they are subject to selection, you don't mean in a single generation, do you?
Well, I wasn't saying that all of them were subject to, well, so let me clarify. So I was saying that he was saying some of the mutations were subject to selection. So that's why the substitution rate does not equal the mutation rate over the long run. Now, it is true that selection does act even on what are called effectively neutral mutations, but the point is that the relative strength of drift on those mutations overcomes the relative strength of selection. So that's why they effectively fluctuate in their frequency in a population under drift alone, but that doesn't technically mean that they're not that they're unselectable, quote unquote. It can also vary on the the size of the population, for example, that's also encompassed into it. But
well, when you have a smaller population, so for example, in your out of Africa model, you go back to a population size of somewhere between 1,000 and 10,000 people, and you're going to have population surges, population shrinkages, and this is allowing for faster rates of fixation in order to allow for today, where we have 8 billion people and therefore slower rates of fixation because people are spread out in all parts of the globe. That allows for your fixation equilibrium, as in it's a mathematical reality according to evolutionary timescales and the way that genetic drift works, the way mutations accumulate, the way selection acts upon mutations and populations as well. And so if I'm understanding you correctly, and speak to this, enough, not all, but enough neutral mutations would accumulate to the point where the population has enough of these mutations that selection can now see the load and remove that load from the equation because it's now big enough to be amplified. Is that more or less how you're trying to argue?
well, what I was trying to say, and so I guess I had one thing I want to quibble about what you said, but I'll move on to my main point here, is that like I was saying, the relative strength of drift versus natural selection depends on the effective population size, which, among other things, encompasses these, like I was saying, random fluctuations in frequency among the population of these individuals. So, for example, if, like you were saying, in a small population where the effective population size is very, very small, the census population size obviously isn't the same as the effective population size, but that's not
Andrew. Before you continue, I just wanted to before you because sure. Andrew, if you can hear, I don't know if there's a lag on your end. You're kind of, it's good enough to hear, but you are somewhat lagging at times and becoming. If there's nothing you can do about it, that's fine. We can deal with it. But if there is something on your end that maybe you can do to fix that or improve it.
Am I still lagging?
You're good. It's intermittent.
Okay?
So it sounds good now.
Okay.
I suspect it might lag here and there, but if there's nothing we can do about it, no worries. I just wanted to let you know.
I don't know why it does that. It's so weird. Yeah.
I'll make sure to not mute.
Just
I know sometimes
keep me up to date on it. Yeah.
Okay. Go ahead, Andrew.
Yeah.
Finish your thoughts.
So what was I saying? Yeah. So the main point I want to make was that it all depends on the effective population size. So there are some organisms, bacteria, unicellular eukaryotes, very small multicellular eukaryotes like mice and Drosophila or fruit flies, etc., that have very, very large effective population sizes to the point where there might be a few effectively neutral mutations that are affected more by drift than others, but their effective population size at that point is so large that the relative strength of selection out of drift for most of the mutations in that population. So essentially, there are little to no effectively neutral, quote unquote, mutations in those very large populations.
You kind of broke up a couple more times there, but I think I got most of what you said. My first question would be, definitionally, would you agree or disagree that effectively neutral means unselectable?
Well, again, it depends what you mean by unselectable, because we're talking about the relative strengths of selection versus drift here. They're always kind of present among a population. It's not like one goes away all of a sudden. That's not how the population genetics works.
So, for example, here
does that make sense? Sorry, go ahead.
It does and it doesn't, because I'll answer it through this citation and I'll get your opinion on it. And so sure. Kitely and Walker.
And then I can probably give like a abstract example after you do that to maybe drive the point home.
Okay. To counter your first point on Fatuma and the effectively neutral mutation rate equaling the fixation rate, which is necessary for evolutionary timescales to even allow for a molecular clock. I mean, if you don't have fixation events, you don't have evolution, right? You require species-wide change. That's basically what fixation is it's species-wide change. It's how quickly or how slowly a species overall can change, right? But if there are things at play, like you're mentioning, okay, bottlenecks, population sizes, natural selection, whatever that number of mutations is that accumulates per generation, that is by definition unselectable, that is neutral to the operations of selection. That number, whatever it may be, will equal the fixation rate. And that's just basic population genetics. Okay. And so whether the neutral mutation rate is reduced, I think is besides the point. You can respond to that in a second, but here it says it seems unlikely that any mutation is truly neutral in the sense that it has no effect on fitness. Okay. The word fitness there, we can, debate on what's the best definition of fitness. I would argue it's total functionality, because reproductive success is not necessarily helpful, since you can accumulate many deleterious mutations that are neutral to selection, that are slightly harmful, but yet not harmful enough to stop you from having kids. And therefore, those mutations will be passed on to progeny, even though they are neutral to reproduction, as in they're not harmful to reproduction, but they are yet still slightly deleterious. Okay. And so here he says all mutations must have some effect, even if that effect is vanishingly small. However, there is a class of mutations that we can term effectively neutral. But in this quote, and then you can respond after this, Kimura says, under the present model, effectively neutral, but in fact, very slightly deleterious mutants accumulate continuously in every species. And so, again, here, there is a class of mutations that we could term effectively neutral. And that class of mutations is, according to Kimura here, a class of mutations that are slightly deleterious and therefore unselectable, because they're not harmful enough to prevent reproduction. Go ahead, Andrew, if you want to take that from the beginning, go ahead.
So yeah, so again, like you're saying, a vanishingly small effect doesn't mean completely zero effect. And what I was saying earlier about the fixation, I wasn't saying that anything about where the fixation rate exists or not. I don't know where you got that from. I was saying that the fixation rate doesn't always equal the mutation rate per generation, like I was saying, because some mutations obviously don't go to fixation because of selection or because of random fluctuations due to drift. So going back to this definition of what effectively neutral means, again, all right, so let me give an example of this. So say you have a very, very
Andrew, I'm going to stop you there. I wonder if you left to refresh your system and then came back in. I wonder if that would work, because you keep going into robotic mode, and sometimes you go into robotic mode in a moment that's pertinent to the discussion.
Okay.
And
are you a Decepticon or an Autobot?
Yeah, try. He's a Decepticon. I'm an Auto. It's Optimus Prime versus Megatron right now. So Andrew, Andrew, maybe that would. Yeah, okay. So he's gonna leave. As we wait for him, to be fair, we have Matt and Dan, and so these gentlemen joined in the free-for-all stage of tonight. And so we haven't had a chance to have you both introduce yourselves. And so maybe as we're waiting for Andrew, we'll give you both an opportunity to introduce yourselves and maybe provide some feedback on what you've heard tonight. Go ahead.
My name is Matt, or Matt at Yahoo. I am a creationist. I believe in the biblical model of the universe, being that not the NASA model. I do have a question for the atheist. I was just wondering, I don't have an education. I graduated high school. I work in a factory. All the studying I do is on my own. So all the scientific terms and stuff, I don't know. But I was just wondering if you have a example of a mutation where, say, a creature doesn't have hair, and then it, say, gets the precursor to hair follicles or bones or anything where a creature develops a new feature
What about
that's
muscle?
helpful, not a tumor or something like along that line, something, wings. Like, here's how this creature, along its evolutionary path developed wings. If you can give it a fossilized or in modern, observable times. So thank you for having me on.
My pleasure. Andrew, before we go back at it, Carlos, since you're probably the best to answer that question, since you're the opposition, did you want to answer it real quick?
My issue is, again, I'm not too heavy in biology and genetics. I tend to go towards more, arguing the logistics of what's being said. So, I don't know if you got that one message I sent in chat, Donny, about you sending me that list at some point. Probably whenever you can, so I can look at that on my own time. I would say I don't personally, if I'm going to be honest, because I don't go too heavy into the genetics portion of it. I haven't really looked. My area is generally, again, like I was telling Donnie earlier about more in the quantum mechanics side. I tend to discourse with quantum mystics and stuff like that.
Okay.
The reason I ask is because you guys are always debating kind versus species and all this, and you can't classify a platypus, and you're always nitpicking Dr. Kent about this. And I think that's where Dr. Kent's going with it, is like, here's a lizard, we have a lizard, and here's where it developed hair. And evolution cannot give us any examples of that, which I would call cross species leap of some kind, even just the development of the precursor to hair follicles. Like I said, I'm not a biologist either. I don't know, but I would think that at this point in where we're at in science, that you would be able to give us some kind of example of a beneficial mutation of some kind. So that's the reason I ask, is because you guys are always the ones that are nitpicking of the kind versus species. And, I kind of agree with Dr. Ken. A kind knows its kind. A species knows its species, if you will. I don't, it's tomato to me. So
let me ask you a question before I give you a decent response to that. Would you agree that if we're going to have a serious conversation, a serious debate, that we have to understand, we have to at least agree on what certain terms mean? Or even if we don't agree on what certain terms mean, let me phrase that. We have to at least understand what the opposition means by the terms that they use. Would you agree to that?
I would.
Okay.
And as like Dr. Kent points out, in the scientific documents that you guys use, they use kind and species interchangeably.
Well, again,
so to me, it
that's
seems
a
like
matter of
you're arguing over semantics at that point.
Well,
what we want to see is where that, we don't want to argue over what's what. We want to say, okay, here it doesn't have fur, here it has fur. Here it doesn't have bones, here it has bones. Here it doesn't have horns, here it has horns. Anything that would prove that evolution, like if through generations, does exist. I mean, who cares if somebody's using the word kind or species? Me as the layman that's coming here to learn, I'm just telling you that's what we think. We don't care.
I would say that as far as the word kind goes, again, it's very important that we at least understand what the opposition means. So the problem is, the reason why we pick at Kent when he says kind is because he doesn't give us an actual definition. Now you can
I can give you a definition,
where,
Carlos. So
what?
my definition, and I've debated it numerous times in formal debate,
Mhm.
is a kind is a group of organisms that can be traced back to a common ancestor. Okay. And that is why I used earlier from the Y chromosome and mitochondrial DNA data, I demonstrated why humans belong to their own created kind, separate from your chimpanzee and bonobo created kind, separate from your gorilla created kind, because using genetic data, we can actually trace all humans, including your extinct human groups like Neanderthals, Naledi, Erectus, Floresiensis, Luzonensis. We can trace them all back to a couple common ancestors, a mitochondrial Eve and a Y chromosome Noah. And I could, for sake of argument, show a phylogeny of that. And so, yes, I think we have a good definition of a kind. And so you can give us a group of organisms. And again, if, like, for example, your felid kind, if I can use genetic data to demonstrate that your panthers, tigers, lions, house cats, and cheetahs go back to a single archetype about 400 years ago, that right there would be a phylogeny or a demonstration of that kind of
So
a
you're
felid
saying
kind
we can't do the
separate from
same
other forms
with
of life.
humans and like other apes? Is that like?
Yeah, well, I showed you that in the Y
Yeah.
chromosome phylogeny. I showed you that humans belong to their own kind because of how dissimilar they are to. So basically, what we want to look at to determine kind boundaries, Carlos, is what's called continuities versus discontinuities. And so I would argue that it's in our genetics that is the best way to answer the question of ancestry, because remember, it's our genes, traits, and genetics that are inherited sperm and egg, not a rock, not a bone, not geography, okay, not geology, but genetics. And so if I can demonstrate through genetics that we have extreme discontinuities, one example, the Y chromosome, that the evolutionists can't explain, then we have evidence for separate ancestry. Okay, does that make sense?
Yes. My where I have an issue though is that it seems like what you're kind of doing is midway through the argument, pushing the goalpost. So I'll explain why I say this. So the reason I say this is because when you first started, when you gave your definition of a kind, your definition of a kind was organisms that you can show have a common ancestor. However, you can't just leave it there, and you subconsciously acknowledge this by the way you continue, because if you had just left it there, going off the chart you showed me previously, we can see that there is a common ancestor. At some point, we say here's a common ancestor for humans and the other apes. So you can't just leave it there. So you kind of push the goalpost then to say, hey, now it's about discontinuity and continuity. But I don't want to, because again, I'm not too heavy into genetics. I don't want to push past that thought that I had on that, because I feel if I do anymore, it may get dishonest because I may not know too much about continuity and discontinuity. So
well, here's what I'm talking about visually. Okay. And so this, in a way, is an answer to Aaron Ra's famous phylogeny challenge. And Aaron Ra is more than welcome to join our open mics that we do every 10 days, and I'll challenge him on this. He'll have
that would be, I think it would be awesome to be in a mic room with Aaron Ra. That would be kind of awesome. I'm not gonna lie.
He's been invited for the last year and a half since we've been doing these, but he's been running. Okay, so notice here we have a phylogeny of humans. You start with Adam and Eve, and here we have extant humans. You have your extinct human groups to the side: Hobbit, Naledi, Denisovans, Neanderthals, Erectus. Now we have separate created kinds over here. In order to build a phylogeny or justify a phylogeny like this, we have to have the genetic data to support it. But within the genetic data, we have to have enough discontinuities to justify such a thing. And that's why Y chromosome dissimilarity. I could look to linkage blocks, the fact that humans have so many large linkage blocks that have no evidence for recombination and gene conversion that would go back a couple 100,000 years. We could look to DNA function. We could look to orphan genes. I mean, I could discuss with you for the next 10 hours many lines of evidence that separate us from.
And I'm gonna copy. I see that you sent that that one link. I'm gonna copy that so I can start looking into stuff like that. So we can have decent, more decent, in-depth conversations with regards to genetics.
Yeah, because
yeah,
the
Donny,
other
I
field,
would strongly encourage you, Donny, that you make one of these PowerPoints available to any of us. I mean, I am in Brazil. We have many communities talking about the origin and common ancestry of humans and chimps, and many of the informations that you have, they are not shared here. And I would really like to dedicate some time to learn about what you have, and then being able to share it here in our country.
Yeah, to that point, that actually reminds me of something I was going to say to you earlier, Donny. Two things. One, you need a soundboard so that when you bring people into the ring, you can go ding, ding, ding. And second, I think it'd be, I'm not sure if anyone else would agree, but I think it might have some benefit to set up maybe like some kind of common forum where we can like agree on, see where people on both sides of the spectrum agree on certain sources. Because a lot of time we get situations where people are like, I don't like the source you used, blah, 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 blah. So I'm not sure if you might be interested in doing something where we can try and see if we can get, some kind of consensus on sources that everybody agrees on. Maybe that will go some way in these discussions. But I'll mute myself for now.
Okay, I appreciate it, Carlos. Andrew Cumming, I'm not sure if you're still out there, but if you've refreshed your system or you're willing to rejoin and test your mic. Okay, he said, give me a second. Yeah, we're good now. Andrew Cumming was waiting patiently. So as we do wait for Andrew, what I could do, Carlos, if you are interested in participating more and more in our debate community that we have going on, is I'd be more than happy to send you various links to secular papers that I typically like to discuss, and you can have a look at them, and then we can discuss the implications of those papers, like the Y chromosome paper we talked about earlier, and you can come to a consensus or come to some, see, a lot of people, Tangelo, you know this, so speak to this if you'd like to, brother. I wrote a book. It's behind me somewhere right here. The Endogenous Retrovirus Handbook. And so a lot of evolutionists, they argue that endogenous retroviruses, shared endogenous retroviruses in the biological world, specifically primates, provide irrefutable evidence for common ancestry. And so I wrote a book debunking that using their own literature. So using the conventional literature, I cite dozens of papers showing how rather than being the ancient remnants of past viral infections, ERVs mostly represent created units of DNA function. Now, that's based on the data. Evolutionists, unfortunately, they go to the conclusions or the discussion portions of these papers, and they just blindly assume or believe that the conclusions of these evolutionary scientists and authors are correct. It's like, no, that's what's debate. We have the data. For example, ERVs are functional in gene expression, determining cell types, embryological development. What's the implications of that? Just because the authors of the paper conclude, well, those functions came about through co-option, and so they're still the ancient remnants of past viral infections. No, the point is, those are the conclusions that are up for debate. Someone like me and Otangelo, we would actually contest that. And so that's where I think the evolutionists need to employ better critical thinking skills when digging through the conventional literature and say to themselves, the conclusions that these authors just provided in light of the data, is this empirical? Has this been tested? Is this a parsimonious explanation? Otangelo, have you noticed the same thing? Do you agree with that, brother?
Absolutely. I've been so many times criticized that I brought up a science paper providing some data, and then in the discussion section, the author of the paper, he made a philosophical inference based on that data. And then I was called a liar because I wasn't agreeing with the inference of the author, because my inference was diverging with the inference of the author. But that's precisely not the evidence. That is the inference, what you make out of the data. That is the philosophical circle around the data. So I am free to diverge with the author about what that scientific data means. And I cannot be accused of being a liar just because I disagree with the author. I mean, the author, he isn't the ultimate word or authority on what that evidence means. And we all know that today the entire scientific venture is based on philosophical naturalism. You cannot invoke a deity as the best explanation of the data. So every time you will see an explanation which leads to a naturalistic explanation.
Amen. I agree with every word. I've gotten it too. Oh, you're lying because the authors said, you know, sperm competition and gene conversion can explain the Y chromosomal dissimilarity. It's like, yeah, they said that. They threw that in there because they can't conclude, oh, well, this data suggests that humans and chimpanzees aren't related. They're not going to get published. And so they got to toss in a couple possible explanations. But it's funny because there's so many circumstances where the evolutionary authors themselves, they'll admit these are untested hypotheses. These are ideas. Maybe this, maybe that. And that's where we need to critically think through these conclusions. Are these legit? Are these empirical? We're not a liar because we disagree with those conclusions.
Yeah, exactly.
Okay. Well, Andrew, let's test your mic. Martino Berto, appreciate the super chat and support. We do love these open mics. And so God bless you. And there's been a few others that have sent in SWE and Sal Diaz. Unfortunately, these open mics get lively and eventful, and so I don't always catch them. And so if I missed any super chats, I do apologize. I just want to thank everybody for their support. So Andrew, go ahead, my good man.
Testing. Is it sounding better now? I hope.
That sounded good.
Okay. Yeah, I guess I need to refresh it. That's always the solution, isn't it? With computers.
You have
by
a
refreshing it
that you didn't have before. Sorry,
well,
Donny.
Andrew, I'll say this: by refreshing it, you've invoked computer selection, so natural selection, and it's wiped away all the glitches and errors within your system, and so now you're good to go. That's selection at work there right away, right now. And so I guess I'd like you to answer this question and then go into what you were saying earlier.
Okay.
At what point does a mutation become selectable, where it's only now subject to genetic drift? And then go ahead with your response, because just to clarify.
So when a mutation is only subject to drift or selection, sorry, you kind of worded that in a weird way.
At what point, or what is your definition of a mutation that is only subject to drift and not selection?
Well, if it has a fitness effect, then it is by definition affected by selection, whether it is where the dominant force behind whether it gets fixated or not in the population is selection. That's a different discussion. Like I was saying, there's no point where only drift or only selection is acting. They're kind of it's a relative thing going on here.
If I have a mutation,
and so
if I have a mutation that decreases my lifespan by 5 years, let's say, okay, so I have a mutation, and rather than living to 80, I can only live to 75. Quick question before I move forward: is that going to prevent me from having children?
Well, assuming you've already reached the point of sexual maturity, you've kind of already had children at that point.
Okay. So is it neutral to reproductive success?
At that point, yeah, kind of, yeah.
So at that point, it does or doesn't affect reproductive success?
Yeah, it doesn't. There are some mutations that have effects early in life, some late in life, some early in life, and then late in life. So it kind of depends.
But okay,
If
but
I
you
may,
would
I
agree,
think I
but
think
you
a good
would
answer
agree.
would have just been sorry. I'm sorry. I think a
No,
good
that's
answer would
okay.
have
Go
just
ahead. Go ahead.
been not inherently. I think it depends on the circumstance. So, for example, if that person, there are other factors involved. So yes, you could say, that you lost 5 years. That lessens the time frame for you to have kids. So we could. I think a better if we go
Yeah, that's a good
more
point. Yeah.
steel manning. Try to steel man your thing would be more of if we took somebody who could only live, they had a mutation, they could only live to like their mid-20s. You know
Right,
what I'm
but
saying?
here's the right. And
To
no, no,
steel
no,
man
hey,
you.
Carlos, I see what you're saying, but that's where I'm going. Okay, so
Yeah.
at first, I have a mutation that decreases my lifespan by 5 years. It has no effect on my ability to reproduce and have progeny. But we would all agree that it's still slightly deleterious, even
Yes.
if that effect is vanishingly small. Because if I could live till 60 or live to 75, I can still have lots of kids. Okay, so that mutation's passed on to my kids, and so now they have a growing genetic load, and now they can only live to 70, and then their kids can only live to 65, and so on and so forth. Eventually, okay, that mutational load, those deleterious effects will reach a point like a ticking time bomb. Basically, you got a bomb that's, let's say, it's ticking down from 2 minutes, a minute, not, all the way down to 0. Well, there's not going to be any noticeable effects other than anxiety and fear as the bomb ticks away. But once it hits 0, now we've got disastrous effects. And so again, this mutation, for example, that is passed on every generation, and the lifespan is decreased more and more and more. Eventually it hits a point where now people are dying at age 35 or 30. And so now it's reached a point like the ticking time bomb where reproductive fitness is affected. But by that point, it's too late, because now you have a population that has descended into genetic sickness. And so now, rather than a horizontal line, okay, now it's going to start going down more and more. And there's no way at that point to increase total fitness.
Yeah, but then it just goes extinct. So I wouldn't say that's much of a problem for us, because then at the point it just goes extinct. And so we're still in line with evolution, because it just goes extinct. It's a matter of
the whole
whether it
population
reproduces or
goes
not.
extinct, though.
Well, that population that has that, but we're assuming that what's happening is that like there's no branching of populations, because it could be the case. It's what was that?
They are being fixed. Yeah, mutations. The fixation equilibrium is a reality in the evolutionary model. Okay, and
yes,
so
no. What I'm saying is, I should have rephrased it. We can say that the entire population may have that, but there's a difference between saying the entire population has that and the entire population is expressing that. There's a big difference there.
Would
so it
you
could
agree?
be it's like saying the entire population has the gene for green eyes, but that doesn't mean the entire population is expressing the gene for green eyes, the mutation for green eyes.
Well, the more mutations that accumulate, the more the genomes become incomprehensible, in the same way that the more typographical errors that are introduced into a text, at first it's inconsequential, right? If you have a book the size of an encyclopedia and you start introducing typographical errors, you're still going to be able to read the book and understand it just fine. But as time goes on, and the more typographical errors that are introduced to that book, eventually that book becomes unreadable. There's too many mistakes now that have accumulated, just like we see in, and this brings me to these citations, and feel free to comment, gentlemen. I should ask, do you guys agree with this quote from Kitely and Lynch, that the vast majority of mutations are deleterious?
From what I've heard other people say, I would say no. I would say that depends again largely on circumstance. And Andrew, you seem like you know more about this, so I'm gonna need you to straighten me out as well, buddy.
Go ahead, Andrew.
So if we want to say like slightly deleterious, then yeah, most mutations on average are deleterious. That's kind of just the distribution of fitness effects curves we see so often. I would like to ask you a question though, SFT, if you don't mind, just so we're kind of on the same page moving forward here.
Yes, you can, but I don't want anybody in the audience or the panel to be confused. I'm not saying that the vast majority of mutations are deleterious in the sense that they're going to exhibit disastrous harm, okay, where it's just these big mutations accumulating, leading to massive damage every generation. No, it's similar to what I just said, that it's a mutation that doesn't necessarily affect reproductive fitness, but it is still slightly deleterious, much like the illustration that I gave, that you can have a mutation that decreases your lifespan by 5 years. You can still have kids, so it's not affecting reproductive fitness, but in terms of total functionality, it's a slight decrease. And over time, total functionality decreases more and more and more and more, to the point where population-wide you have genetic sickness. And this is what we're seeing, I would argue, and this is what we're going to talk about in the human population, okay, to clarify. And so, yes, Andrew, go ahead, take your time. So
I will say that no, I'm gonna ask my question first, because then we might go on another tangent. So Donny, what do you? Yeah. So Donny, what do you think genetic drift means? Like, or just what's your conception of it? Just so I know what we're kind of talking about here, so we're on the same page. You know,
random changes. Yeah, it's random changes in gene frequency and in populations over time, where a population can shift in gene frequency, basically, in genes that are present in that population. And so an allele that becomes fixed is an allele that was at one point a wild type allele. It's drifted randomly, and it's now become, if it's fixed, it becomes stuck in place. Okay, so
Donny, can I ask you a
drifted
question?
randomly. Yeah, go ahead.
For what I know, the proposal of genetic drift, I know only Larry Moran, but besides him, not many advocate for that variation of evolution as being the explanation of biodiversity. I think this is a small minority.
Well, we're not saying it for biodiversity, just for molecular changes over time.
Andrew, would you agree with my definition of genetic drift and fixation?
Yeah, I like the way you phrased that. And I just want to harp on that point, though, that you included the word random there, because you seem to be under the impression that if it's under drift, then it is going to fixate if it's effectively neutral. But you're also saying that it's random fluctuations, like I was saying in the population. Like I could bring up a graph here if need be, but if
right,
they're random fluctuations essentially, then a lot of those mutations are also going to be lost from the population, even some of the beneficial ones.
But here's the thing. It's like you're climbing up a mountain. Let's say you have a lot of people. So basically you could have a genetic variant that is randomly drifting in a population, and it is increasing in frequency, or maybe it's decreasing in other gene variants can be decreasing in frequency. Okay. And many are lost. 99% are lost. But the thing is, many are not. And think of, you're climbing up a mountain. Okay. And the top of the mountain is fixation, people reaching the top of the mountain. But say you got 1 million people walking up the mountain. Okay. Many are just going to randomly walk up and not really be able to make it to the top. Maybe they'll kind of hover around the middle part or 3/4 of the way through. They just can't quite make it to the top. Many people will fall off. Okay. Mutations are being lost, but there's always going to be a select few that make it to the top, and that's genetic fixation. But in light of that, in evolutionary time scale, again, you have equilibrium points where you have many mutations that are accumulating per generation, effectively neutral mutations, reaching fixation per generation. And you guys need that in the first place, because again, you need species-wide change to occur, right? Andrew, like you need the fixation of these wild type alleles, correct?
But let me ask a question, Donny. So if you have a fixation of a mutation, the question is, if you really want to have a new trait and macroevolution, which would be new body plans and new body forms, You need entire new systems. You need new metabolic pathways. You need new proteins. You need new genetic, epigenetic information. You need many systems that start to interact and work together. That is like in a factory where you want to create and construct an entire new section with an entire new production line, and then interconnect it with the old part of the factory. And that needs lots and lots and lots of new information. I cannot fathom how you actually synchronize all that innovation that is required.
Can I say one thing?
Sure, go ahead.
Okay, this is to Carlos and Andrew. So I just want to say a point, and then I want to ask a question to illustrate the point. So
finally,
evolution.
because I was going to tell you to be quiet, or because you've been talking so much this whole time.
Oh, can you hear me?
Yeah. No, I was just making a joke. I was saying that I was going to tell you to be quiet because you've been talking way too much this whole time. It was the joke.
Okay.
You're kind of cutting out. I'm not sure. Whoever was just on screen share. Was that you, Carlos?
Yeah, you're a little bit quiet.
Yeah, you were suddenly kind of quiet there. But guys, I don't want to drift off.
Sorry,
I got to jump in because we are. I've been at this now for over 4 hours nonstop, and so I really don't want to drift off from our focus topic here. We're gonna really hone in, okay, and try and wrap it up at the 4.5 hour mark. So, Andrew, continue with what you're saying in terms of your rebuttal to genetic entropy. Because again, if genetic degeneration is a reality, which I argue it is, it puts shelf lives on genomes. Okay, that means species cannot persist for millions of years into the future. It certainly means that species could not have persisted for millions of years into the past. We understand that the rock strata that evolutionists, actualists, or uniformitarians assume is billions of years of history. Well, you find fossils all throughout that rock strata. We find fossils of horseshoe crabs that look basically the same as they do today in rock strata that's somewhere between 200 and 300 million years. And so the point is, we also have biology reflected in what? The fossil record. And so if genetic entropy is a reality and it limits the lifespan of biology, then it also indirectly demonstrates that your rock strata is also young, because what we find in the rock strata is extinct biology. And so that's why I think genetic entropy is the bigger picture argument, because again, if it's a reality, then the evolutionary community, they don't have millions to billions of years to take single-celled like ancestors into all the forms of life that we see today.
Well, and what to say about cyanobacteria, which are supposed to be 3.5 billion years old, and in that time span didn't change at all.
Yeah.
Yeah, that's not
Stasis.
strictly true, but yeah.
Okay, Andrew, let's get right back to genetic entropy, because I think you agree that a lot
guys, I will
rides on
leave,
this being true or not.
I will leave, but it was great to be at your channel again, Donny.
Absolutely.
And I hope that you can send me some material and that I can interact more and learn, because I think you have a lot of things that I want to dive in and keep up.
Well, Tangelo, always a pleasure, my brother. We are doing many of these. I'm going to try and implement them as we've been doing every 10 days. So please do join. It's great to see you back in the community. You keep up the great work, my brother. And it's a privilege. It really is to have you here.
Thank you. Thank you. Have a good night, everyone. See you next time. Bye-bye.
God bless. So, Andrew, my response earlier, it's still, I'm not sure if you fully understand Tuma here. I want to get to the, okay. Standard population genetics theory teaches that the rate of fixation of neutral mutations, which includes effectively neutral mutations, okay, in a population equals the neutral mutation rate. How can selection slow that down? Because in order for selection to slow that down, the mutations can't be neutral, because by definition, a neutral mutation is a mutation that's not seen by selection. Unless what you're saying is what we were talking about earlier with the mutation that decreases the lifespan of an individual, where at first it's neutral to reproductive fitness, but eventually the harm is amplified to the point where now selection can see it because people can only now live to 30 or 35. And so now it's affecting reproductive fitness. Is that basically what you're saying here? And speak to that, Andrew. Take your time.
So one thing that can affect the neutral mutation rate, and as far as selection acting on what were previously we would consider effectively neutral mutations, i.e., those that were dominated by the influence of drift alone, we could have population sizes, or more specifically, effective population sizes that fluctuate over time. So at one point, a mutation that was effectively neutral becomes not effectively neutral because the population has grown over time. And then that can like decrease,
so the population has grown over. I want to follow you. So the population has grown over time, that these effectively neutral mutations that have accumulated, they're no longer neutral now?
Yeah, because that's what, like I was saying, the definition of, I'm not going to go into the mathematical definition because it's kind of hard to illustrate without a marker here. But essentially, like I was saying, effectively neutral means that the relative strength of drift on that mutation is greater than the relative strength of selection. It, like I was saying, it doesn't mean one suddenly goes away compared to the other. Say, for example, so this is the example I was trying to give earlier. Say you have a very, very small population in this hypothetical example,
okay,
of 1,000 individuals total. So that's your population size. And say you have a mutation that, let's say it's a deleterious one in this case. So it has an effect on fitness. So one or two of the individuals carrying that mutation, their reproductive fitness is affected. They don't pass on that mutation. But say due to genetic drift, that mutation is passed on by, say, 10 more individuals. In that case, we would say that drift compared to selection is the dominant force, aka that mutation is, by all intents and purposes, effectively neutral. So like I was saying, it doesn't mean selection suddenly goes away. It's not unselectable. And that can change, again, depending on the population size. So if we have a larger population...
It's going by being... so it's basically going by being subject to selection, to now, as the population grows, to now being more subject to genetic drift. It's like bouncing between genetic drift and selection, is what you're saying?
So the opposite, actually. So as the population grows larger, selection becomes more efficient at weeding out mutations with smaller and smaller selection coefficients, with smaller and smaller fitness effects.
How small of a selection coefficient?
That would depend on the effective population size we're talking about. So like, I think Dr. Zach Hancock, in one of his videos, for example, where he was talking about the effective population size of modern human societies would be around 7 billion-ish. In that case, when you do the math and get the selection coefficient, that would be effectively neutral in that case, where drift would overwhelm selection.
But the problem is,
it would be on the order of 1 times 10 to the negative 7th power, something like that. So a very small order of magnitude in that case, for that large population size. And of course, there are organisms with larger population sizes. So that's kind of my point here.
And the thing is, no matter how low the selection coefficient is, it's never going to be able to get rid of all of those mutations. I mean, selection's acting upon the organism. It's acting upon phenotype, not genotype. But it almost sounds like you're giving unlimited power to selection, where it can see each individual nucleotide.
Well, I'm not necessarily saying that. I'm just saying it, on average, it becomes more effective at seeing quote unquote these mutations depending on the effective population size.
Well,
So it all depends on the context of the organism we're talking about.
It becomes more efficient, hypothetically. This kind of sounds like a lot of highly contrived mathematical modeling here. But for sake of argument,
math is pretty straightforward. It's just 1/2 NE, N sub E is less than S, or sorry, negative 1/2 NE is less than S, which is less than positive 1/2 NE. That's what effectively neutral means. That's the mathematical definition. So if a mutation has a selection coefficient in that range, it is effectively neutral.
But mathematically, for NE that we were talking about earlier, right here, the same number of neutral mutations should be fixed every generation. Okay, that is not affected by population size. I pointed out earlier how, according to the evolutionary model, you have in your out of Africa scenario, you have population crashes or bottlenecks, and then population surges, and then subgroups go out into isolated tribes, where you have instances of rapid fixation of these neutral mutations. And today we have humans at somewhere between 7 and 8 billion people. Okay. But for most of evolutionary history, the population existed in a way smaller number than that. Again, 1,000, 10,000, 30,000. It was only until recently that the population has surged into the billions, and that is required for fixation equilibrium. Population geneticists want fixation equilibrium in order that species can change in their entirety. The entire population's changing, not just individually. And so I don't think any of that addresses this issue where we have irreparable.
I think you're confusing fixation equilibrium in this case with the fixation rate, because I'm not saying that no mutations, again, are going to fixation. Certainly some are. What I'm saying is what you're talking about, the fixation equilibrium, that all these neutral mutations are going to fixation. That's almost never the case. Some mutations are lost from the population and don't go to fixation.
Right. But because you have evolutionary time scale, okay, there's no fixation equilibrium when it comes to the young Earth creation model. There's almost no fixation. As a matter of fact, when we talk about mitochondrial leave and Y chromosome Noah, we're not talking about species-wide change over time. We're just talking about individual change in the sense that how many mutations are separating us, basically divergence from the Eve consensus sequence, rather than explaining substitution, where you would look at that as a coalesce sequence where each fixed allele used to be a wild type allele that's drifted to fixation. Okay. The point is, evolutionary time scale, you do have enough time and you have an out of Africa bottleneck where fixation equilibrium mathematically is a reality. And so the same number, and it's on screen here from Fatuma, the same number of neutral mutations should be fixed every generation. The rate of fixation and mutations is theoretically constant and equals the mutation rate. I mean, that's what Fatuma here even says this is the theoretical basis of the molecular clock. And so, yeah, you have a lot of
the basis of it, but not all molecular clock models use that. Some are, like I said, some are much more complex than that. They have other factors added to it. They incorporate selection and other geographical effects.
Would you agree once fixation rate equilibrium is reached, then this is a mathematical reality for NE?
Sorry, can you repeat that one more time?
Would you agree that after fixation rate equilibrium, once you get to a point of fixation rate equilibrium, now 4NE applies? Like for us, the young Earth creationists, we only have 6,000 years of history, so we don't have fixation rate equilibrium. But the evolutionary story has the time scale and the out of Africa model for a fixation equilibrium for this formula here, for NE to be true, as Fatuma is talking about. Would you agree with that or disagree?
How are you defining fixation equilibrium in this context?
Well, fixation equilibrium is where the neutral mutation rate equals the fixation rate. So say the fixation rate is 50 and the population's 1 million. Well, every generation, 50 nucleotide substitutions are occurring in that population of 1 million.
I have a question.
But again, that's what I'm saying is oh, someone else talking.
Oh yeah, no, go ahead. I was just gonna ask a clarifying question that I think may help whatever you're gonna say, because that's just something I was wondering.
Carlos, you're really muffled. So suddenly we can't hear you for some reason.
Very low volume.
Can you hear me now?
It's a little bit better.
A little
Still
bit.
low,
You
though.
were really good earlier, though. Let me stop my share screen and see where you've.
I can come back out and come back in if you want.
Yeah, maybe do that. Okay. So, anyways,
So
go ahead.
So what I was trying to say was that I was saying that's not what typically happens, because again, some mutations, even neutral ones, are lost from the population. They don't reach fixation. So the fixation rate doesn't equal the neutral mutation rate. You can approximate it like that in some cases, but that's not always what happens.
In fixation equilibrium, it doesn't matter. Yeah, many mutations are lost, but many are not. Remember, I gave that analogy of climbing up a.
Well, you gave an appropriate figure, for
mountain.
example, like 99% of them being lost. That's not most. That's most of them being lost over time, even beneficial mutations.
Me and Chris Roop addressed this in our technical article. And so, okay, I'm going to screen share real quick. And okay. So notice this. Me and Chris Roop wrote this. It is true that the vast majority of mutations are lost from the population via genetic drift, as you've said, right? Especially immediately after they first enter the population while they are very rare alleles. The wild type allele I was talking about, okay? However, our critics should know that two things can be true at the same time. So I think this is what you're missing, Andrew. Even with ongoing random loss due to genetic drift, classical population genetic theory states that over evolutionary timescales, as I've been pointing out, a neutral mutation fixation equilibrium point will be reached. When this occurs, the neutral mutation rate will equal the fixation rate. For example, if the effectively neutral mutation rate is 50 per person per generation, then that means 50 nearly neutral, or in fact, very slightly deleterious mutations will become fixed every single generation. And so you hold to the evolutionary time scale. And so you have a model that has reached fixation equilibrium. We don't. Creationists don't. But you do. That's just a mathematical certainty. Do you disagree with that, Andrew?
So to clarify, are you saying like 50 mutations per generation in a single individual, or has this already reached fixation? Because I think we're confusing the mutation rate from the substitution rate.
No, the point is, well, is the substitution rate and fixation rate synonymous?
As far as I'm aware.
Right. Okay. You're right. So if the effectively neutral mutation rate is 50 per person per generation, yes. Okay. So if it's 50 per person, then that means 50 nearly neutral mutations will become fixed every generation. And Fatuma here, he verifies this. This is 4NE. this is fixation equilibrium, and he says this is the theoretical basis of the molecular clock. So the point is, yeah, a lot of mutations are lost, but many are not. And according to evolutionary time scale and 4NE, you have a lot of mutations that are drifting to fixation, and everything, anytime a mutation's fixed, even when a beneficial mutation's fixed, all the deleterious mutations in the linkage block are fixed with it. And so that's not going to counterbalance any of the damage, because you have so many nearly neutral mutations drifting to fixation, leading to irreversible and irreparable damage if evolution is true.
Or recombination can help counter that as well.
Well, recombination doesn't really act upon large linkage blocks, because those
Well, it can
linkage
act
blocks
between
are
certain
all of
genes.
those nucleotides are linked, right?
Right, within a gene, sure.
Yeah, so you could have a linkage block
But like
of
the genes,
10,000 you could have a linkage block of 10,000 nucleotides. And this goes back to something I was talking about earlier with Carlos. We have many large linkage blocks in the human genome that have no evidence at all for shuffling. They have no evidence at all for having been recombined. And so what I would argue, that speaks to the youth of the genome, because there hasn't been enough generations to scramble the genome as much as it should. But that just brings us back to your point here about recombination. It wouldn't be effective.
right? Because that's not applicable to all chromosomes in the genome. Like you're saying, it's only a select few.
Yeah. Okay. So my point is, this is a reality according to Fatuma and population genetics theory. And so this amplifies
So let me just
entropy
clarify
problem.
here. If we get to the molecular clock, what he's saying here, where's your logic going from here? Just so I'm trying to understand the flow of your argument a little bit better.
Basically, even if we were to imply the scenarios you've been talking about and more complex math, 4NE still applies. It's just a mathematical reality based on evolutionary timescales, based on the out of Africa model, based on genetic drift, based on selection. I mean, it's right here in front of you. This is Douglas Fatuma from an introductory level evolutionary textbook. I mean, this is what he's saying.
Right, but
Same
I'm
number
just
of mutations.
curious what that means for genetic entropy specifically. Like, where are you going from here, assuming this is true?
So, assuming this is true, then what that means is you have a large number of mutations that are reaching fixation. And so rather than just randomly drifting throughout the population, never reaching fixation, you actually have a model where many slightly deleterious mutations are reaching the point of fixation. And when they reach the point of fixation, they're stuck in place in every individual. That wild type allele has, the wild type allele started off rare, and it drifted more and more to a higher frequency where it's now fixed. And when it's fixed, that's irreversible damage. There's nothing you can do about it. Selection can't remove the entire population. That's extinction. So that's the problem, Andrew. Does that make sense? If it's fixed, it's a typographical error that's basically just boom, it's just stuck in place. There's nothing you can do to wipe it out. Does that help, Andrew?
Yeah, I think so, but that's, I mean, it can get to that to a certain point, but it's not going to happen throughout the genome. You're not going to have saturation of these deleterious mutations throughout the genome. There are mechanisms to counteract that.
No, because if you have all of those mutations per generation, right, the per generation neutral mutation, which is high, if that same amount are being fixed every generation in a population that's at fixation equilibrium, that's a lot of damage being stuck in place. No?
Well, this, I feel like we're going in circles here, because like I was saying, you're saying, again, the mutation rate equals the fixation rate. I'm saying that's not what's occurring even for neutral mutations. And this goes back to, again, depending on the effective population size of the organism, of the species.
No, I have an excerpt from a paper here. Okay, I don't know if we got time to get into it. I have it in front of me, and it says that 4NE still applies, even regardless of the population size. I mean, do you disagree with this citation in front of me from this textbook from Douglas?
Do you have
Fatima?
a quote for that specifically, or?
Well, I have this quote
for
right
what
here.
you just said.
Yeah, I'll have to get that citation after. I don't have a slide on it or anything. I have it.
Or
Okay,
could you
so
just read it real quick? Or
let me find it. I had it saved in my phone. Okay.
I'm just
So,
curious what it says.
for sake of argument, if it doesn't, if it's not affected by population size, okay, which is the case, I assure you, but you don't have to believe me if you don't want to. How does that? I don't know. I'm just kind of flabbergasted. Like right here is what Fatima is saying. You're disagreeing with it?
Well, I'm not disagreeing with it. I'm just saying it can't be applied to all cases.
But Fatima said,
like,
okay, it can't apply to all cases. Elaborate on that.
Well, just like I said, it's an approximation. It works for certain. Well, like of course, mutation rates differ for different organisms. So obviously, the molecular clock is going to differ as well. But also, like going back to what I was saying is I'm just curious what you have that says that the effective population size wouldn't affect this, because in my mind and according to my understanding, it would.
So it's from a textbook. I have a photo of it right here because, as you know, whoa, earthquake from T-Rock. Thanks, brother. Okay, welcome, gentlemen.
I guess what I'm trying to understand is, it seems like you're saying there are certain mutations that are kind of always neutral, so they're going to fixation due to this mechanism.
Listen,
and what I'm saying,
wait,
is
I
that
got the
there aren't.
screenshot. Wait, Andrew, I got the screen. You got to give me time, man.
Okay.
I got the screenshot from the textbook. As I told you, Christopher Roop and I wrote that highly technical article there on this issue. And so it says, since on average, it will take 4NE generations for such mutations to reach fixation, about the same number of neutral mutations should be fixed in every generation. The rate of fixation of mutations is theoretically constant and equals the neutral mutation rate. This is the theoretical basis of the molecular clock, but it continues. This is the part I didn't have. Notice that, surprisingly, the rate of substitution does not depend on the population size. Each mutation drifts toward fixation more slowly if the population is large, but this is compensated for by the greater number of mutations that arise. So, I mean, that's in the same section that I showed to you from this Fatima.
Okay, I think I see what he's saying there. Yeah.
See right here?
I guess I'd have to look into the context of that. Yeah, because I understand what he's saying there. I'd have to think about that.
I'd like to say something on that, if I may.
Yeah, you know, it sounds counterintuitive to a lot of people, and it's definitely not the case if humans only go back 4,500 years. There's no time for all of that substitution. There's not a time. There's no time to reach a fixation equilibrium. But the point is, most mutations are deleterious. Most mutations are neutral, but they are slightly deleterious. They just don't have a better example could be, and Paul Price uses this example, Andrew. And so tell me what you think about it. If, let's say I got a mutation that decreased my ability to breathe effectively every generation. Okay. Well, at first, you know, my ability to intake oxygen and my ability to just breathe, respiration. Okay. At first, it's not going to affect reproduction. I'm still going to be able to have lots of kids, but eventually that mutation will be passed on, and it'll spread enough to where the ability to respirate effectively will decrease. Total functionality will decrease, even though reproductive fitness has stayed the same. So you have reproductive fitness staying the same, it's stable. But total functionality is slowly going down. Okay, so here's total functionality slowly going down. Reproductive fitness is the same. But eventually it reaches a point where total functionality has gone down so much, and pretend this is reproductive fitness. Now reproductive fitness starts going down, and they're both going down together like a ticking time bomb. Okay, and fixation equilibrium makes the problem worse because it's like a ratchet where it gets worse and worse and worse, more and more damage accumulates. And what happens is you reach a point where total functionality has been decreased so much that there is no increasing total fitness. Total fitness always goes down, even if reproductive fitness can be stable for a while. Speak to that. Tell me if that makes sense. Go ahead.
So I just have to question how you could demonstrate that premise that the breathing would somehow not affect reproductive fitness. And the other thing that I would like to clarify is, so what you're talking about seems to be more of a population kind of crash at the very end. Like it reaches a certain point and then the population declines dramatically. But that doesn't sound like what you're talking about with genetic entropy in terms of these mutations accumulating and the fitness declining at this what you're saying, a time bomb, basically. Like that, those seem to be kind of separate from one another. Does that make sense?
Well, it's any mutation with a low. What does this mean to you? A mutation having a low selection coefficient.
Well, that means it has a low impact on reproductive fitness.
A low impact on reproductive fitness. And so what does that mean then?
So it means
that
you have fewer offspring than the average.
It's going to get passed on. Right. Okay. So it's going to get passed on. But it doesn't mean that mutation is not also slightly deleterious. In ineffective respiration, think of it like asthma. People with asthma, it's more difficult for them to breathe effectively, but they can still have a lot of kids. But if we take the analogy,
right, but on average, if you're saying it has some deleterious effect, on average, they will have fewer kids than the rest of the population. Otherwise, it wouldn't be deleterious.
I was going to push back on this, if I may.
Go ahead. And
yeah, no, go ahead, Donny.
And before you do, Carlos, I just want a T-Rock and jungle jargon.
Yeah, of course. No problem. Of course.
I was going to shut it down at the 4-hour mark. It's almost the 5-hour mark. So what I'm going to do, I've been going nonstop for 5 hours. But since T-Rock is here, and T-Rock, he knows a thing or two about a thing or two. And so we're going to let you guys go at it for a bit because I got to get some food and drink in me, okay? So if I've been hogging the mic for a while, this is your chance, guys, for everybody to get in on it. Go ahead, Andrew. What were you saying?
Oh, I was just saying I'm going to have to take off too anyway. It's getting late where I live. But
okay.
What was I going
to? If you wanted to engage, if you wanted to engage T-Rock for a few minutes, I know T-Rock was saying that he missed you, Andrew. Because Andrew, you're a well-rounded evolutionist, and we love engaging people who are well-rounded because it makes it more fun. And if I keep doing these 5-hour open mics, forsaking the gym, I'm going to become very well-rounded horizontally here. So, gentlemen, I'm taking a quick break. This has been an excellent genetic entropy showdown. Carlos,
yeah, thanks.
Go ahead. I know you wanted to push back, and I got faith in T-Rock to answer your objections. Go ahead.
So my pushback is, one, I think it's one thing to say that, the rate at which fixed mutations will occur is constant. I think it's a different thing to say that the same applies to the rate
Carlos,
at which any given.
I got to say, yeah, it's. I don't know why it's. Have you done anything differently? Because for the majority of the time, your audio was great. It was loud.
It was really low.
bounding.
Yeah,
So now we
yeah. I'm not sure too much. Let me know. Yeah, how do I sound right now?
Seems
Are
like
you
we're
on
both
your
having
phone?
some
Different?
tech issues.
Yeah. All right. So you know what? I think I'll wrap it up here for now then, and
Actually,
I'll
Carlos,
catch you
you
guys
do
next
sound
time
a
on
little
conversation.
better. Carl, you do sound a little better. I pumped up your volume, and so
Okay.
yeah, go ahead. You're good.
It might be also because I'm trying to be a little bit quieter because it is kind of like it's approaching 1 o'clock in my area. So one thing I want to say is that it's one thing to say that the rate at which fixation may occur is constant. It's another thing to say the rate at which any given mutation becoming more deleterious is constant. So in your example of asthma, I think that was a good one because I was going to bring up something like that. It's one thing to say that, you know what I'm saying, that, you know, asthma is going to affect you a little bit, and then the next generation, they're going to have worse asthma. That's a whole different thing than saying, you know, the population overall is going to get more mutations. However, the real pushback that I have is, while you can say that initially, while it was slightly deleterious and had no impact on reproduction, it is not necessarily the case that as it continues to decline and become slightly more deleterious, that it will stay having no impact on reproduction. So, for example, we see this with people all the time. You know, if you have really bad asthma, yeah, you can have a lot of kids, but socially, we're going to look at you like, no, we probably don't want our future kids to do this. You know, we do this all the time. You know, I ask myself, do I want to have children with somebody that has cancer or somebody that has, you know, leukemia, or can pass on whatever, you know, to my offspring. So in that regard, I would push back and say that if it would get to a point, I was going to ask you my question earlier, clarifying on does this only apply to things that we can't see? Because if it applies to things that we can see, mutations that we would be able to see, at some point we're going to say, okay, you know, we're probably not going to breed with those people. That person's literally going to have a harder time socially breeding. You know, even in other animals, we see things where there are like slight outcasts because the animals notice there's something slightly different about this animal, about this member of my species. And so that would be my pushback onto that. Like if this person has a lot of trouble breathing right now, but it's not that bad. But you know what I'm saying, if compare that to somebody else that literally is on a respirator, at that point, probably he's not going to have somebody that's going to want to breed with him. It's my pushback.
To my understanding, it's not just deleterious to physical attributes. It would be deleterious to other physiological processes as well, if I'm understanding it correctly.
Yeah, because he made the example earlier also of the lifespan. Well, that's why I had that question of if it was only about things that, you know, we couldn't see or things that weren't physical like that. But that's why I have that subsequent pushback of, you know, it's not the case that every time the subsequent generation becomes more deleterious that we can say it's has an equal low impact on reproduction, because that may not be the case. If we look at it, you know what I'm saying, if your lifespan is deteriorating to a point where the population isn't going to get past that point, it's going to happen that, you know, the people that are still living with that are probably going to notice. You know what I'm saying? The species might notice, or if not, that portion of the species will die off, and the rest of the species will continue.
I'm not sure if he was saying that as the mutation reaches fixate, or as it goes to fixation, the overall health declines as well. I understand what you're saying. I'm trying to figure out if that's what he's saying, or if he's saying the mutations are accumulating one after another after each one reaches fixation. You know, I kind of see the point you're making. The other,
it seemed
the last, yeah. Sorry, go ahead.
Well, it seemed to me what he was saying was that, like, so it's hard because I don't know what he would think would be a good example. But let's say we have a certain mutation, and that mutation is only slightly deleterious. It has low impact on your ability to reproduce, right? But the next one, and let's assume that one also becomes fixated because it's part of the situation. That one becomes fixated. So then the next generation, we have to assume, one, that mutation got even more deleterious, which may not be the case for this generation. And two, we have to assume that specific mutation is also going to be one of the fixated ones, which also may not be the case. And
That's actually a good point. Yeah.
If we do that, then we are also led to this situation where if we assume both of those things, so then we can keep going to the point of, hey, so the next generation is going to be worse than the last one. But what's going to happen is at some point we have to assume that every member, just because it's fixated, that doesn't mean again that every member is expressing it. So we'd have to assume that every member is expressing it in order for the entire population to die out. Otherwise, what's going to happen is we have one section of the population that is expressing it and is dying out, and another section that isn't expressing it and dying out. And they will notice this most likely if they have a certain degree of intelligence. And if they don't, well, then there may be some measure of counterbalance between those two mixing in. And in humans, this is why I was saying specifically with humans, we're so intelligent, we circumvent a lot of these issues just in the way that we socially interact with each other. Eugenics played a part in this, and eugenics is horrible, but that obviously played some part in it. You know what I'm saying? People were saying there, I don't want to reproduce with somebody that has these traits or has this sickness. So that's going to circumnavigate a pretty big part of that issue.
Right, and that also brings to mind.
Hey guys, I'm going to jump
like
in. I'm going to jump in. Are any creationists engaging you guys in your points?
No, I think we're actually having a back and forth on what you were talking about, which is kind of weird.
I thought somebody was going to jump in and debate for me, but if I got to address these arguments, I'll do it.
Yeah, it seems like we're actually trying to argue on which version of this you're on. So I guess we need your input on who's closer.
So, Carlos, I apologize. I don't know you very well, Carlos.
Yeah, no problem. I'm new, man.
I was sitting here listening, trying to figure out which side of the fence you're on, because I just don't know you, and I was just
evolution.
Okay, so does that mean we have 2 evolutionists and the rest are creationists?
I believe so.
Okay. I mean, I would be glad to engage some of the points. I was just kind of listening to follow along where you guys were in the conversation, but
oh, no worries. I was upstairs getting some food ready, and I just could hear. I felt like it was just Carlos and Andrew.
So correct me if I'm wrong, but the general gist of this whole line of conversation has to do with genetic entropy, right?
Yep.
Specifically genetic entropy. So I was listening earlier, a couple hours ago. I was outside working on my trailer, but I was listening to quite a bit of the conversation, especially while Luca was still in the live stream. And so I'll be honest with you, I heard some really bad arguments, but one of them was I heard somebody say something to the effect that, and I don't want to misrepresent anybody, but it really sounded like what they were saying was classical thermodynamics, second law. The second law of thermodynamics has nothing to do with genetics.
No, so what I was saying was that the second law of thermodynamics has nothing to do with the way entropy is used in the term genetic entropy. So genetic entropy refers to, from my understanding, the accumulation of slightly deleterious mutations, which apparently, as you guys are saying, become fixated over time.
I guess, okay, so I mean that's great for the clarification, thank you, because I guess I couldn't take issue one way or the other, but I think I would agree with you by and large that when most people say genetic entropy, they're not really talking about the second law of thermodynamics.
Yeah, they're not really talking about entropy at all. I would say, of course, entropy happens with every process. That's just by one definition of entropy. That is just what happens. You know what I'm saying? We lose quote information. I don't want to get bogged down on what that means because people misunderstand that as well. But it's just, I thought it was funny that they use the term entropy, but completely give it a different definition because it has nothing to do with entropy.
That's a fair observation. I think by and large, I would agree with that most of them really don't have second law of thermodynamics in mind when they're talking about it. However, having said that, I mean, I'm sure you're aware, I'm a creationist. Genetic entropy is a real problem for evolution, and it's specifically because the second law of thermodynamics absolutely does apply to biological processes.
how would you correlate genetic entropy itself though, but as it's defined with the second law of thermodynamics in itself? Because those are two different issues. You know what I'm saying? In terms of like, let me ask you first. What's your rundown of entropy?
I mean, in a real simple sense, entropy just refers to the randomization of matter and energy in the world. That basically the all processes have a tendency towards disorder. Basically, that's the simple definition. I know there's
that's generally the layman's understanding. Yes.
I mean, I know there's some nuances, and this is my exact problem with arguing against entropy and actual second law of thermodynamics entropy in biological processes, is because in classical thermodynamics there are a lot of nuances about closed systems and isolated systems and blah blah blah,
Right.
and so you have to go chase all these rabbit trails down. But the reality is that biological systems are open systems, right? I think you
yes.
I think you would agree with that.
Yeah.
But one of the really bad arguments that I've heard evolutionists make, so it's pretty common, you'll hear people say, well, abiogenesis can't happen because of the second law of thermodynamics, and the classic response is,
that's a horrible statement.
I disagree with that, but I'll tell you the classical response from the evolutionist is that, well, that's true in closed systems, but the Earth is an open system, right?
Yeah, generally yes, but if I may, finish your point.
So the whole point there then is that in entropy, when you are talking about functional entropy that you can observe and test and demonstrate, the more open a system is, the faster entropy happens. You have to close up and disallow all of the incorrect types of energy into the system in order to reduce entropy. And Earth being an open system is exactly why things like abiogenesis cannot happen, because the Earth is too open. There's too much random energy allowed into the processes.
So when you say it's a matter of disorder and you're talking about energy, can you elaborate on what your notion and understanding of that is with regards to how entropy, like I really want to understand what you know about entropy, like as scientific as you can give me.
So I mean, entropy, when you're talking about entropy, you are talking about randomness. You're talking about generally, so you got to keep in mind, I come from a mechanical engineering background. I do not have a graduate degree at all in mechanical engineering, but that is...
I don't have any degree, bro. Don't worry about it, man. As long as you're not pretending to be somebody that has a degree, I don't have a problem, you know?
I'm not making any big claims about that, but I do come from a mechanical engineering background. And my only point there is that in mechanical engineering, you have to actually be able to apply the principles. If you can't apply them, then they're just purely fantasy as far as we're concerned, because there's nothing you can do with them.
Granted, but would you acknowledge that there are differences in the way that different mathematical branches apply certain notions?
Sure.
Okay, so it is likely the case that however it's applied in mechanical engineering is much different than how it's applied in quantum mechanics. This is a common issue that people have when you have people that are math scholars. It's a common joke that math scholars hate the way that physicists do math, because they do a lot of things contrary to how regular people do math, because there's certain other things that they have to take account for.
I mean, honestly, I wouldn't bother arguing that point at all. I would just
I actually want to hone in on the whole point of randomness.
Well,
so the issue with the randomness is, what does that mean to you? What does the randomness mean to you?
So basically, in any given system, a certain amount of energy is just lost to heat. In other words, it's energy that dissipates away in a form that you can't use, and it can't be captured and reused in a meaningful way. So in mechanical engineering, what they teach you about entropy is that the hypothetically most efficient engine possible is one that has infinite heat reservoir and essentially zero heat on the cold side, so that there's an infinite difference between the hot and cold side of the engine. Right? So and they say that because they're and we're talking about the hypothetical side of entropy, not the practical side. In the hypothetical side, what you want to do is take the heat that is not used for useful energy, recapture it, bring it back into the system, and convert it back to useful energy, and just keep that cycle going. Well, here's the problem with that in the real world. In biology, living organisms have a very low operating temperature, and the delta T, it's super low, but it's the most efficient machine that anybody knows of in the world, period. So the thinking in classical thermodynamics is clearly wrong.
I would have to disagree because so if we're looking at it from the notion of how organisms operate, first off, so going back to the notion of randomness, and you were pretty spot on, in terms of energy being pretty much just lost, and there's no way to really get it back. So you move your arm, you've used energy, you can't get that energy back. But again, we are not closed systems. We're in an open system, and we can, at the end of the day, the real issue that would be debated is whether or not the universe or cosmos, depending on whether or not you make a distinction there, is an open or closed system, which we don't have proof for one way or the other. So the thing here is it's a non-problem because we're not a closed system. The Earth is not a closed system. We get energy from the sun. That energy goes into other things that we consume and whatnot. So it's just a complete cycle of energy. Yes, we will at some point. It's likely that at some point there will be an end of that energy cycle, and we'll have an eventual heat death. But saying that there's a heat death isn't really a problem in and of itself. It's just kind of pointing out an observation of what is to occur.
But in genetics, you have to maintain the order of genetics, and that's the problem with genetic entropy, is that you can't maintain the order that it had.
Well, Carlos,
that's not a problem. Well, hold on. If I can respond to that real quick, that's not really a problem because that's just the second version of entropy, which is just saying that there's no way to tell there's very little way to tell what situations occurred to get a certain outcome. Like if all you know is that I added two numbers together to get the number 8, there's no way. This is the other version of entropy. There's no way for you to tell me how I got 8. I could have added any series of those numbers.
We know what cancer is. We know that's genetic. The order is being lost.
That's just entropy in itself, though. That's not really a problem. That's a different version of genetic entropy because you're not actually talking about things being lost. Really, when you're talking about genetic entropy, you're talking about the accumulation of slightly deleterious mutations that become fixated. No, that's a big difference. The loss of information and the accumulation of deleterious information are two different things. Those are not the same thing in the slightest.
So, Carlos, let me bring it full circle for you real quick. But one of the things that I think you failed to acknowledge is that what I said early on, the more open a system is, the faster entropy occurs. And so when you apply that to genetics, particularly abiogenesis, granted, but when you apply that to first life on Earth, having this broad open system in genetics, your DNA is actually made up of a whole bunch of very weak hydrogen bonds, chemically speaking. And so having the wrong kind of energy present at all is extremely detrimental to the process. And so the easy way the average person can identify what I'm saying is that when an animal dies on the side of the road, it decomposes very rapidly, specifically because of how weak the bonds are and how little energy it takes to tear them apart. So having a wide open system absolutely does nothing to further the argument that
Well, my question here though to that is, what is the actual issue that would propose? Because you can say that yes, those things may deteriorate slightly faster, but they're with regards to fossilization, there's different, that has nothing to do with the sedimentation, because there's certain rates, different rates at which certain things will fossilize certain structures. So my question is really, what is the issue here that as you're applying it to the open system losing more energy faster? Because it really just seems to me like you're just pointing out that, hey, at the end of this, the energy is going to run out really quickly, which isn't.
No, that's not what I'm saying at all.
I understand that's not, because I'm just saying that's what it sounds like to me, and I want to be corrected on what you're saying.
I'm trying to bring, like I said, I'm trying to bring this full circle to how it applies to genetic entropy.
Okay, go ahead.
And I'm starting with abiogenesis only because that's the common usage point for the second law of thermodynamics argument from the creationist side. And the typical response from the evolutionist side is, well, it's an open system. And I'm saying, well, the creationist is actually right, because having the system too open is problematic for entropy. It doesn't solve anything. But when you extend it to genetic entropy, so you ask the question, how is it that I perceive entropy in general? And I'm talking about heat and how it randomizes processes and randomizes matter. So specifically, heat, what it does is it excites the motion of atoms, right? And subatomic particles. That's what heat is by definition. So if it excites the motion of molecules, and you think about like a deer going to the lake to get a drink, you got to think about a couple different things. Number one is that I mentioned that biological systems are the highest efficiency machines that anybody knows of, but they're still not 100% efficient. So
right, because nothing can be, as far as we know.
Exactly, that would be what we would call a perpetual motion machine, right? So,
unless the order was maintained. If the order was maintained, they would keep on going forever.
Well, right, and so this is the point. If it's less than 100%, that means you're losing some of the energy to random heat loss. And so if you take your own body operating temperature at 98.6 degrees, you find out, of course, that is a relatively substantial amount of heat, and a whole lot of your body energy is just randomizing into the atmosphere, and you can't do anything about it. You can't do anything with that heat that's lost.
Yeah, granted.
But when you bring it down to the molecular level and how it relates to DNA, you've got the same problem whenever you're doing reproduction, cellular division, any of that kind of stuff. You've got the same problem. It's less than 100%. It's losing some of its energy to, to the atmosphere. Can't get it back. And there's another element to the whole randomness point of entropy, and that is, talk about the deer going to drink out of the lake. What's in the water that the deer is drinking? And where I'm going with this is, mistakes happen. You guys talk about mutations. You talk about mutations. You talk about natural selection, but you never really get to the root cause of what drives mutations. And what I'm saying is, when that deer goes to the lake to get a drink, what's in that water is exactly what drives mutations. He's not drinking H2O. He's drinking H2O plus, some fine particulates of mud. There may be a little bit of arsenic. There may be a little bit of manganese. There may be a little bit of just about anything in that.
Somebody might have let it go in the ocean. Had it,
Sure. Absolutely. I mean, go swim in a river and pay real close attention to what's floating by. And so the point then is that when you take that stuff into your system that's less than 100% efficient, those random molecules or those random atoms of lead, arsenic, whatever it is that's really not good for you, they get into your cells in mass. And your body has a way to mitigate some of the damage, but it can't mitigate all of the damage. So what I'm saying is mutations happen because of the randomness of the chemistry in the environment. And as long as that's true, genetic entropy has to be true. And you can extend that to the mathematical distribution of where will the mutations happen. In people, you got 23 pairs of chromosomes. Your mutations.
Hold on, you kind of lost me with the because you jump from randomness of energy to the randomness of what's in the thing, which is not, again, you're delineating from what entropy at that point would be talking about to bring in this random matter, because entropy is just a matter of the randomness of where the energy is going to go. So when you're bringing in these other forms of matter, it's not really much of an issue here. I guess my big problem is, how are you tying this into this randomness of energy and heat to the accumulation of deleterious mutations?
Well, one is ordered heat, the other one is ordered information.
So, yeah, the way you tie them together is that you can't just talk about entropy like it's just energy. Energy is only energy if mass is involved, because that's what.
You were bringing out the other. So you were bringing up the other version where it was like, we also don't know what was in the water that they had. Okay.
Well,
so the loss of information. Got you.
My whole point is that random energy moves random matter.
Mm-hmm.
That's the whole point, is that random energy moves random matter. If they're not separable in any way. The basic energy equation is 1/2 mv squared. Mass is in there. So you can't have energy without mass. And the only way to have mass without energy is to have it at 0K. And so the lake example is that you've got random energy, you've got meteors striking the earth, you've got lightning storms, you've got whatever kind of energy input, tornadoes and thunderstorms and whatever you want, earthquakes, volcanoes, you've got all this random energy. And so what's in the lake is a product of random energy. So all of that, it's indelibly tied together. You can't separate the two like they're two different things.
Okay, but even if I grant that, what's the actual issue here? Because as far as I'm not really saying it really is just kind of just again making just kind of explaining what entropy is at that point. You're not explaining how how that correlates with us accumulating more negative, more deleterious things, and then saying that it breaks the second law of thermodynamics.
No, what I'm saying is I did tie it together. What I said was that once you understand that the randomness of energy randomizes matter, and that the chemistry of your environment is the product of that randomized energy and matter, you're taking things into your body that are not conducive to anything but a process of accumulating mutations, period. I mean, we don't drink pond water like the deer do. But if you go get a chemistry report on your water supply at your house, you find out that you still got that problem. Your very well filtered H2O is not really just H2O, even in your house. And so the whole point, though, then, is that the distribution of that random chemistry in your genome, it's inescapable. You've got 23 pairs of chromosomes. Which chromosome gets a mutation? Because you guys talk about this mutation rate, which is completely bogus, by the way. You talk about a mutation rate that happens 1 mutation per person per generation. That is purely hypothetical. In reality, you've got over 3 billion base pairs, and whenever you take food into your body, if the chemistry is random in your food supply, all 3 billion of your base pairs of DNA are potentially affected by that chemistry. And so what I'm saying is there are actually a lot more mutations per person per generation. It's just that there's no good way to quantify what it is. And so as long as you do a simple mathematical distribution of random mutations in all 23 of your chromosomes, You can have an alleged beneficial mutation in any position in your genome, but it doesn't negate the fact that you still accumulated deleterious ones in other places that get passed along and accumulate.
Okay, but then I think the problem here, first off, maybe I'm going to have to look more into how things are done in mechanical engineering. But
I mean, it's
as far as that goes, I would say it's, first off, it's much easier to tell what's deleterious than it is to tell what's beneficial. Because a big point that you're missing, that a lot of you tend to miss, is that what's beneficial depends mainly on circumstance involved. It's easy to say, hey, this is deleterious, because those are more easy to see the impacts of. It's way easier to see that something is negatively impacting something, as opposed to deciding whether or not something is beneficially impacting can pretty much, from our standards, be rather subjective, because you can say, I don't think this is beneficial, but I can say, I think this is beneficial. But we can both agree that something is deleterious because it objectively negatively affects what's going on. It's causing harm or disorder to the structure. Whether or not we think two different types of order are beneficial is more or less subjective, or based on the circumstance at hand. Okay. So again, this is why we harp so hard on the fact of fur, because you guys tend to just ignore it, which is, if you say, we could say that an organism gains fur to protect them from the cold, like, you know what I'm saying, like if fur occurs throughout these reproductions, that's beneficial if they're in an environment where fur keeps them warm. If they're in an environment where fur makes them hotter, it's not beneficial. That's easier to see, because how much fur, what temperature is going on, how much fur does this one individual have, what's the proper amount of fur to keep them warm. That's all open variables, as opposed to whether or not this fur is overheating them. That's not as subjectively defined. It's way more of an objective thing to see.
So I'm the first one to say that number one, I'm not sure how delved in you are to the creationist viewpoint, but there are creationists that will absolutely deny beneficial mutations exist. I am not.
I like to give everybody their chance to explain if I put them in a box like that, because obviously there's so many variation. Even among atheists, I hate when people try to put them in a box. It's a term, you know, like theist is just a term saying you believe in God. You know what I'm saying? Nothing else to it. I don't know anything else about your position.
I just want to point out that I'm not one to argue against beneficial mutations. The fact that they exist is to me perfectly normal. There's nothing wrong with that. But there are creationists who will argue against them. I'm just pointing out I'm not that one. I'm happy.
See, my problem here is that I'm wondering. Oh, hold on, I've got echo. Is that me or somebody else? I'm hearing echo.
I was just gonna ask if you can give an example of that, or give an example of, say, fur coming into a species that didn't originally have some kind of fur, where there was added information, not the loss of information. Because you guys like to use dogs and wolves as an example. Well, with the wolf being the common ancestry, you can find all the genetic traits from our common dogs in a wolf. You can see where it's all loss of information.
Well, like I said earlier, personally, I don't have genetic information like that, because I don't really delve too heavy into biology.
Well, you guys are talking about the beneficial mutation.
Well, I'll give you an example. I'll give you an example of something we can actually probably test, right? So if we take a species of dog, right? Let's say we have I'm not a breeder, but let's say we take a dog that's all white, right? Is being all white beneficial or deleterious?
It's this was one of the points I was trying to make earlier. I'm one of the first ones to tell you that, and I'm not alone by any means, but I am more than happy to tell you that the idea of beneficial mutations, or deleterious for that matter, can be highly, or generally are highly contextual.
I agree.
Which exactly makes your point.
I would say, with the caveat that, again, deleterious ones are slightly less contextual have a tendency, I should say, have a tendency to be slightly less contextual than beneficial ones,
A little
only
more
because it's
absolute,
easy.
right?
Because deleterious pretty much depends on whether or not it's detrimental and or killing you or some way or making life harder
Well,
for you, which is easy to see. You know what I'm saying? Like,
understood, but let me take it a step further on beneficial mutations, because in your example is white for beneficial or deleterious. Well, okay, if you're in the Arctic, it's obviously beneficial, but
exactly.
it's only beneficial while you're in the Arctic. As soon as you leave,
Granted.
that exact same thing becomes not necessarily so beneficial, right? And could
Granted.
actually be quote unquote deleterious or harmful in the sense that, you know, now all of a sudden you're a very visible prey to a wily predator. So anyway, all of
Granted.
that.
I agree.
Quick gut check on what I was talking about the randomness of chemistry, how the random distribution of mutations in your
Chemistry
genome.
also not one of my things. I gotta.
Okay.
I'm trying to work on getting my math up. No, don't let that deter you, because I would like to get more into these subjects. Obviously, I would like to learn more about these subjects in my own
Understood, but
time.
I'm going to make a real easy point that anybody can follow, and that's
Yeah.
exactly that's exactly why we do this in mechanical engineering. But real simple gut check: when you take an aspirin, how long does it take for the chemistry in that aspirin to diffuse into your body?
It had to be aspirin. I don't know. I'm allergic to aspirin.
You get the
I would
point,
say
though.
probably about an let's say an hour and a half, maybe I don't know. They say
30
don't take,
minutes.
what is it? 30 minutes? I don't
to
know.
an
I've never
hour,
taken an
maybe.
hour.
It's
I haven't
been a
taken
long time.
medicine in so long.
Well, you get the point, though. Whenever
Yeah,
you
I
take
get the point.
medicine, it basically has to diffuse through your body fairly quickly. And so what you're saying then, what is the chemistry of the aspirin? And when it diffuses into your body, because, and I use this example because aspirin is actually taken in a lot of cases to relieve a headache, for example. But you can also have body aches, general body aches in your joints and stuff like that. If you have a flu, for example, you might take aspirin to help reduce your fever, eliminate a headache, and eliminate body aches. So the point there then is that aspirin has to diffuse through your entire body, and it's affecting specifically, it's getting into your cells. If it's not getting into your cells, it cannot resolve a problem with your headache. And so that's all done, of course, because your body is so much liquid. If it's so much liquid, put it all together. Your body is a high percentage of liquid. The chemistry of your food supply diffuses through your body very rapidly. Your internal efficiency, ATP synthase efficiency, is less than 100%. All of that spells the same thing, and the randomness of the chemistry of your environment, it all spells the same thing. The distribution of copying mistakes during cell division is a direct product of the randomness of the chemistry. Therefore, the distribution has to, number one, it cannot be a single mutation in 3 billion base pairs. It can't be. That doesn't make any sense whatsoever, unless you're talking the hypothetical deep time required for fixation over certain size populations. But
I think that's generally what we're on my team is generally we're giving that time. And I'm going to let you continue, and I'll mute my mic so you can continue your thought. But I just do want to say I like to give pushback when people say time, because I don't understand why people give so much pushback on time as if. But we'll go back later. Go ahead.
Well, the real point there is about what's proposed to be a very slow mutation rate with fixation, when in reality, the aspirin example is very fitting, because the chemistry goes through every cell in your body practically in minutes to an hour or so. It's really quick. Every cell in your body is affected. That means if you take an aspirin and then cell division happens afterward, the cell division has to be, chemically speaking, the cell division has to have been influenced in some way by the aspirin, right? And this is exactly why pregnant women are advised not to take certain types of medication, because your cells can recover from it. I will grant that, but the real point is that the chemistry distribution, the mutation distribution, it's across the entire genome. It's not one mutation out of 3 billion base pairs. It has to be logically much more than
Okay. Well, to that, I would say it is not the case that the way we are currently is the way that organisms were. So it could be the case that they just simply circumnavigated those certain issues just off the lack of being, off the principle of being less, for lack of better terms, complex systems.
Do you recognize the loss of function that we have in our genomes?
How do you mean? I would say I could say we have loss of function in the genome, but I don't see how, if they're not really affecting reproduction, it's much of a problem. Even if you stack them, if they're not affecting reproduction, it really doesn't matter. Going back to what I said before, if it is the case that there are things that we can see, well, generally populations are going to avoid that. If there are things that we can't see, well, it's not the case that the entirety of the population is going to express that what you say, that detriment in functionality.
But it's the loss of function that causes us
That loss in function
to die, right? We die because of loss of function in our genome. You know that, right?
That's what you guys are saying. Yeah, that's fine.
No, that we lose the ends of the telomeres and all.
Oh yeah, the ends of the telomeres. Yeah.
Yeah, that's
why people are trying to do things with telomere extension. That one dude, that one dude I was just reading about. One real rich dude. He was trying to do some kind of telomere infusion.
There's all kinds of people looking into it with all kinds of supplements and everything, which I take too. I'm 65 years old, but I take.
This is probably the one of the few things I did try to look into with genetics. I did watch I think it was a few videos on telomeres and centromeres, but again, I only paid but so much attention. But that was one thing I do remember they were talking about. As the telomere. Well, because here's the thing: as the telomeres shorten, yeah, we die. But if they don't ever shorten, then we get cancer. So.
Well, I mean, if everything's working properly, you're not going to get cancer, and there are remedies for cancer too, with natural intake, natural foods.
But at the point that they're no longer deleterious to the point where they don't impact reproduction, at that point, they're not an issue of really genetic entropy right there, because then you're not talking about a mutation that is as defined by genetic entropy, which would be a mutation that is slightly deleterious but doesn't impact reproduction. Unless you want to say they're generally mutations that don't impact reproduction, but that's the only way you can do that, is if they generally don't. But then you'd have to allow generalities for things like what we propose.
So you have
going back to the
deleterious. So you have deleterious things happen to your genome after you reproduce, but not before.
I'm not sure.
That's a great point, Jungle. That's a great point. It's always happening. I had a debate here a while back with the Dr. Chris Thompson.
Yeah,
and he basically was trying to make an argument along the lines of what Jungle is suggesting. He was basically saying, well, okay, the chemistry only affects reproduction at the time of reproduction, and that's a horrible argument, especially from a guy with a PhD, because the chemistry that's in your body. I mean, you think about anybody who's ever had to take a drug test. How many months in advance do you have to get off of drugs to be able to pass the most advanced drug tests?
Well, no, because I think what he's saying then at that point would be that it only matters with regards to the point of reproduction, because if the mutation happens after I reproduced, well, that doesn't matter because I didn't pass it on, unless I reproduce again while I have the mutation. If I reproduce prior to having that mutation, then it doesn't matter. It could be the case that all these mutations are being fixed, but it's not the case that they're all being passed on, because people have children at different times in their lives. Some people don't make it to have kids after they have, it could be the case that I have a kid, then I have the mutation, then I die. That mutation never gets passed on.
No, that completely misses the point. Jungle's point is that you're developing mutations from the time you're conceived all the way up till the time you're able to reproduce, you're accumulating mutations that entire time.
That's fine, but the only ones that matter are the ones that I pass on. Anything I don't pass on doesn't matter.
That's exactly the point. Those are the ones you're going to pass on. You're going to pass on 50%, and your mate is going to pass on 50% of their accumulated mutations. And what's the net result? Basically 100% of however you want to quantify it, but numerically.
But it's not the case. But it's not the case.
You have, or the exact same amount your partner has, plus additional ones that happen because of the reproduction process.
But it's not the case that, like, we can say that a person is going to have X amount of mutations over their lifetime, X amount of deleterious mutations over their lifetime, but it's not the case that all those mutations are going to happen prior to reproduction. Yeah, I'll grant that. I can grant that we have a few of them before the person reproduces. You know, I may have, let's say if the number's 50, I may have, 25 of them before I reproduce. It's not the case I'm going to have all 50 before I reproduce. I could have 5. I could have only 3 go on before I reproduce.
We inherit all kinds of genetic deformations.
Yeah.
The only point you actually have there, though, is that yes, you do continue to accumulate mutations in your genome as you age, and you don't pass all of those on. That's true enough, but the problem is still that you passed on 50% of what you did have at the time of reproduction. Your partner passed on 50% of theirs. You added a couple more because of the reproduction process, and the net result is more accumulation. So it's irrelevant that you kept on accumulating mutations in yourself that you never passed on. That's not even part of the point. It's a simple mathematical distribution. If you've got 23 chromosomes, pairs of chromosomes, and 3 billion base pairs of nucleotides, your distribution by necessity of mutations has to be random, and there's no way to select them out.
I understand that the ones I'm inheriting the one I inherited are being passed on, but what I'm pointing out is that the ones I gained during my lifetime that aren't inherited, the ones that are random that I gained that I'm going to pass on to my children, are not necessarily a lump sum like the argument proposes. You can say that mathematically there's a set number of this, that happens every generation, but we know that circumstantially it is not the case that is going to be exactly what happens.
No, that's not the argument. The argument is just simply that between the time you're conceived and the time you reproduce, number one, at conception, you inherited mutations.
Mm-hmm.
Number two, you accumulated a minimum additional one mutation because of the reproduction process. Number three, you added additional mutations through cell division while you were maturing to sexual reproduction. Now, if you inherited some that you keep, you added some during the reproduction process that you keep, and you accumulated more before you got to reproduction maturity that you keep, and then you pass that on, that's the argument. That's it. It doesn't matter what happens after reproduction. I've already acknowledged that. It's irrelevant. The point is, you never started out with 0 mutations. You inherited additional mutations that weren't in your parent population, and you contributed more before you got to reproduction.
Okay, and that's fine because you already acknowledged that what is beneficial or deleterious is impacted by circumstance. So even if we're gaining deleterious mutations, the problem is that you're not seeing here is that the circumstances can be such that those deleterious ones are actually now beneficial, especially being, again, it's not like every animal is fucking stupid. Oh, sorry for the cursing. It's not like every animal is stupid. I need some water. Especially with humans, you know what I'm saying? So it's like we we have, especially with humans, we have a tendency to take things that we consider weaknesses and try to turn those into benefits or problems of some sort. Handicapped people do this all the time, which are, or people that have, certain other disabilities. They do that all the time. I have this issue, and so I've learned to use it to my advantage. And so organisms can take some degree of agency to depending on the organism. I would say I wouldn't assume every organism has the same degree of agency to do that, but they can be in situations where now they can make that deleteriously beneficial.
It doesn't mean it's a good thing, though. I mean, that they're trying to say it's an advantage when it could be in certain ways, but in other ways it's not an advantage.
Well, no, yeah, nobody's saying that. Again, we're not saying they're inherently one way or the other. So that's the thing. If we were saying they were inherently one way or the other, then yes, but we're not. We're saying that it's dependent on the circumstance. So if it's dependent on the circumstance, then you can't really just, aside from something that's actively causing, straight up harm to somebody's structure or their lifespan, in a quite clear way. If the situation puts them such that they can turn that into now something that's beneficial, by definition, it's not deleterious anymore.
Carlos, I was listening earlier, a couple hours ago, while you were basically making the same general argument that people with their intelligence have a way to mitigate the effects of otherwise deleterious mutations, right? That's what you were arguing earlier, and you're kind of reiterating that same point.
Yeah.
And so that is actually not a terribly uncommon thing for evolutionists to argue, except there's a massive problem with that line of reasoning, and that is that in the evolutionary timeline, people have only been as intelligent as we are for a handful of thousands of years, and the mutation rates that they propose for macroevolution are so slow that handful of thousands of years is completely irrelevant.
No, that's fine, because I already acknowledged that different organisms have different degrees of capacity with regards to how much they can mitigate certain circumstances.
But all that aside, there's another problem, because kind of what you're alluding to is basically how most of them would argue about selection. So selection pressure will do this, selection pressure will remove the deleterious, so on and so forth. And so back to your point about how contextualized beneficial mutations are. Well, here's the problem, though. In this whole grand scheme of evolution, you have this very piecewise process of developing things, an extremely piecewise process. But it's a piecewise process literally at the molecular level, while what I was describing earlier, below the molecular level, at the atomic level, your chemistry is randomized, and your body is composed largely of weak hydrogen bonds. That's why they tell you don't eat lead paint and stuff like that, because that chemistry jacks up your health really quick and mutates your cells really, really quickly. And so the point then is that piecewise processes combined with really weak hydrogen bonds that are disrupted very easily by what you might even consider relatively benign chemistry, like too much salt in your diet or too much sugar in your diet, disrupts your body chemistry. You can't piecewise anything together over time. In other words, the majority of evolutionists, almost always what they're doing is hand waving away the real mechanics of the chemistry that has to happen and just saying, oh, natural selection, oh, environmental pressures, oh, we got these magical solutions that basically say none of that is really a problem, when in everyday life it's absolutely a problem.
I disagree, because if you're saying you're hinging heavily on the fact that it's all randomized, which again I would say you're hand waving away the intelligence, because you'd say in your example of like the horse, you're talking about a horse drinking random water. We don't do that. Okay, we built societies, and going back to our intelligence, we've built societies where we pretty much regulate the way we do things. Yeah, there's going to be some degree of randomness with maybe something gets into the water system in your area, so and so. But for the most part, we try very hard to make sure that we meet certain standards to make sure things go a certain way with what we're consuming. People have their own agency to allow certain to not make certain choices. No, it's completely relevant because he's saying he's saying that it's completely random when it's not. Because if the entire population is focused on making sure that the things that they consume are as clean as free of diseases, as free of bacteria as they can be, then you're limiting the degree of randomness that you would otherwise have in an area where you don't have the technology to mitigate that degree of randomness. Again, so if you have
we already know there's populations that have more genetic mistakes than others. We already know that, and it's basically
yes, and that's probably because of lack of technologies. Because they don't have technologies to mitigate those certain things.
But it doesn't eliminate the mutations.
Because it's not supposed to eliminate the mutations. They don't have the technologies to eliminate the mutations. So of course the mutations are going to arise. We do. You notice that in those areas that don't have as many issues, they are highly technological as opposed to places that don't.
But we can't eliminate our mutations. That's just
to
suggest that we eliminated all 100% of our.
Why would we want to eliminate all that? That's eugenics.
You would want to, but to claim that you have, that's
not necessarily. That's eugenics, because again, that's eugenics. Because if we can say we want to, but then we have no real capacity to determine what is going to happen in the future with regards to what we've created as an outcome. If we got rid of those mutations, it could be the case that something else happens to us that we couldn't account for.
You would be naive to think you're getting rid of 100% of all deleterious mutations.
I agree, because why would you want to? You would cause a big eugenics problem.
Yeah, but you're assuming that mistakes are good.
No, I'm saying that circumstances can cause. I'm saying that circumstances can allow for mistakes to be good, which should not be debatable. And we even agreed. What was your? I'm sorry, I didn't catch your name.
Carlos, how can you say it should not be debatable when you can't give an example of a good mutation, a beneficial mutation?
Because do you not agree that an organism that is white, that has white fur, that evolved to have white fur, it has a beneficial mutation by having white fur if they're in the Arctic, as opposed to being somewhere like what's it called?
But
an
can
Amazon.
you prove that it's white because of a mutation? Because of its loss of information through.
You're forgetting the entire construction of the hair or a feather or a scale requires genetic information.
No, I'm not forgetting that. It's already put into the fact that there's small changes. If the problem is you're trying to leap from one state to another.
I just like to show
that the mistakes made a scale, made a feather, made a hair. It's genetic information that is ordered that made a hair, a scale, and a feather.
Yes, when it all accumulates in the same way that a wheel alone isn't a car and a bolt alone isn't a car. But if you have a wheel, a bolt, and several components, you eventually get a car. You can't just have a car with one piece. But you have all these pieces that exist prior to a car existing. You can make a car.
But those are all intelligently designed pieces.
That's not the point. The point is that I could.
No, that is the point. You cannot show me.
No, the point. It's not the point. The point is that
you
the
cannot
point was
show
that
me a
no.
species.
No, hold
let
on.
me talk. You've been talking all night. Let me talk. So
Matt, you're misrepresenting my point.
Well, let me make my point.
Okay,
so you cannot show me a beneficial. So you cannot show me a beneficial mutation of where something did not exist in a creature, say a hair, a creature that had no hair, where it got hair. Now, a white hair, yes, it is beneficial, but was that there because our creator put it there? Or can you show me where the beneficial mutation created that hair? Or created anywhere along, like the hair follicle or anything along that way? Without that, I mean, that's a... we want evidence, not
Again,
theories.
you
What you're
you could
presenting
me
is
personally,
theories.
I don't have the exact data for that specifically. I'm sure you could probably find it if you want, or something relatively close. But again, the point that I was making was more so that the point you're making essentially a fallacy of division. You're saying that the parts of the whole have to have the attributes of the whole. They don't. These things can have their individual parts. These individual things can coalesce to be one thing that has the whole thing.
That's what you
It's not the
believe.
case that one thing, when you say this organism goes to another organism having hair, that's not what happens. It's an organism that goes to an organism that has something that slightly resembles hair follicles, then an organism that goes to something that has something else that
Just
slightly more
believe.
resembles hair follicles, and starts producing keratin or whatever to produce hair, and so on and so on until we get to
Jungle.
organisms that actually
Somebody's
have
got an
hair.
echo.
So show me that. Show me any of that along
I'm
the
sure
way.
you.
Any
I'm sure
evidence
you
of
could.
that.
I'm sure you
I
could
mean, you're
search it.
saying that everything came from one cell, but you're saying all the parts were there. So no, you either have one cell or you have all the
It
parts.
came from one cell, but it's not the case that that one cell was the original cell.
So one of the big problems that I
That's
think
why I even brought up
evolutionists
the whole mitochondrial Adam and Eve thing in the first place, because it's not the case. We have a mitochondrial Adam. We have a guy that we can trace our lineage to all the way
Y
back, but it's not one
chromosome.
Y chromosome and Adam. It's not one single guy. It's one guy that can potentially change as the genome shifts and as people die off. That can change to now we can only trace it back to this other guy. And it's the same thing with the cell. We have a cell that we started, but not necessarily that one cell.
But you know the reason why we can trace ancestries like that is because of mistakes in the genome, in the Y chromosome that are being made.
Yes,
Which
but
is another
funnily
point.
enough, you accept genetics for
Which is
everything
another
except
point.
what goes against your position.
No,
If
Carlos,
we've
I
been
think
around for
one of the big
billions of years, there would be a lot more mistakes.
So,
in our Y
Carlos, I think
chromosome.
one of the big things you're missing in this whole discussion, and I can appreciate the fact I'm not a geneticist either, and I know you're not.
No, and I'm sure I am missing a few things.
Listen real close, though. Listen real close to the arguments and how they're put forth. I'll be perfectly honest with you. I was completely duped by the bait and switch that evolutionists do for a long time, and it was only very recently that I was able to kind of sort it out with the help of an evolutionist, nonetheless.
Okay, hold on real quick, because I don't think you're going to forget this point. Are you in control of what's on the screen?
No,
Yeah.
Donny's doing that.
Well, Carlos, I wanted to.
Okay, no, go ahead. Sorry, my bad.
No, that's okay. There's a couple things I wanted to address that I've heard in the last 30-ish minutes of discussion. One thing about fixation, but let's deal with the most recent comment you made about mitochondrial Eve and Y chromosome Noah.
Oh yeah, this Noah thing is new to me. That sounds pretty interesting.
Well, we say Y chromosome Noah because the last universal Y chromosomal ancestor of all men today would be Noah, because we had a flood bottleneck, right?
So the previous one was Adam.
Yeah, and then
that's
Noah to Adam. But chances are the Y chromosome of Noah and Adam wouldn't have been all that much different. And so I still think it's accurate to say Y chromosome Adam as well, because it really is just a single Y chromosome that we have on the planet, because every single male Y chromosome, again, is nearly the same. But I want to focus on the mitochondrial DNA.
I was gonna say real quick. From what I recall, don't we have two mitochondrial Eves? Like we not two, but we found there. It is the case that we have a secondary one.
Well, we have. So, for example, this is a mitochondrial.
A successor.
Yeah, we've got a mitochondrial phylogeny here. So this is worldwide mitochondrial DNA diversity, and we've got haplogroup. So for example, this is the HVR haplogroup, most common in Europe. Okay, so this represents people groups. It represents people worldwide. Now, you'll notice all these branches go back to a center point, and from that center point, you have explosive growth. It's like this starburst explosion, right? And
Yeah, I
what
was
that
wondering what
tells
kind
us,
of graph this is.
yeah, it's an unrooted phylogenetic tree. It gives us a natural representation of real mitochondrial DNA diversity. So anyways, my point is, and a counter to what you're saying, we have evidence here of one woman from whom we've all descended from. Mitochondrial DNA, and this is where I want to go to this paper and get your thoughts. This is a paper, it's from the conventional literature. It's called Mitochondrial Diversity Within Modern Human Populations, okay? And so they've actually discovered Eve. It's called the Eve consensus sequence. And I'll interpret this for you. They're basically saying that the mitochondrial DNA, it's mostly invariant. And so what that means is most of it's the same worldwide. There's only a few, it's about 25 to 30 DNA differences separating any two people in the mitochondrial genome. This is what this means, okay? And on average, so notice this. The 827 sequences within the data set contained 2,631 variant positions, and on average differed from the consensus by only about 21 nucleotides. That means any two people, they only differ by about 21 differences. Okay, so what they did is they looked at the rare deviants worldwide, okay, where we do differ and where we don't have the same nucleotide. And they were able to come up with what's called an Eve consensus sequence, as in we know what Eve's mitochondrial genome looked like. And so where you said that this Eve would have had previous ancestors or she would have existed within a population, Carlos, I appreciate the point, but it's just false. That's not what we all we have is data that suggests we've all originated from a single woman in the not so distant past. And so how can you look at this data and extrapolate it to mean that this woman existed in a larger population and had previous ancestors? Where do you get that from?
Can you I'm sorry, can you run down one more time how this how this states that she was not from a population?
Okay, so I'll use an illustration. Let's say I handed out 100 different 100 of the same manuscript. So I handed it to 100.
Hold on.
So yeah, no problem.
Hold on. My phone's dying. Oh no, I forgot.
I think he just got. Oh, is he still there? His phone probably just died.
He's still there.
But he may join or he may not. I'm not sure. We're at the 6-hour mark. So I'll just wrap up my point for anybody interested. So basically, you've got a manuscript. Okay. One manuscript. Let's say you have 100 of it. It's all the same. You hand it out to 100 different people and you say, I want each person to copy the manuscript. Well, each copy then is going to be a little different because nobody's going to copy it the same. Everyone's going to make mistakes and everyone's going to make unique mistakes. Well, how do we figure out what the original manuscript was? Well, it's easy. We take all the copies and we can easily find where all the deviants are, where all the mistakes are. We can find the unique spots as well. And we can remove those from the equation. And when we do so, what do we have? Well, we're back to the original manuscript. And so that's what they did with mitochondrial DNA, is they were able to take mitochondrial DNA worldwide. They were able to find the rare deviants, remove those from the equation. And what we're left with is Eve's mitochondrial DNA sequence, the literal sequence of Eve in terms of the mitochondrial DNA. And so, no, that doesn't go back any further than that. That's the original manuscript, is essentially my point. Anyways, gentlemen, if you had any thoughts on that, maybe Carlos will want to join. But before we shut it down, to be fair, Jungle Jargon, you didn't have enough time to ask T-Rock a question in our last open mic on the fossil record. And so maybe this was predestined to happen, where now you have the opportunity to ask T-Rock that question. Did you want to do that before we wrap things up, Jungle Jargon?
Sure, if T Rock is up for it.
Sure.
Yeah. I started before trying to ask a question, but my question was whether or not you've heard the evidence or seen the evidence for a breakup of the continents after the global flood, and it didn't seem like you understood or knew what I was trying to ask.
No, that's a fair point. I really I didn't quite get the gist of what you were asking, but you were, I guess, were asking, was I aware of specific physical evidence in the world that the breakup happened after the flood?
Yeah.
So, to be honest with you, no, I'm not really familiar with any particular evidence anybody's put forth that it happened after the flood. I've heard some of the arguments, but mostly it's centered around what the Bible says about the days of Peleg and so forth. But as far as actual physical evidence, no. But I would be glad if you could kind of share some of that.
Right, because you were addressing geology and you're an engineer, and so I was thinking you should know or understand some of this, but like you said, you never heard of any evidence. And to be honest, I haven't heard any evidence from creationists either very much, other than what the Bible says that in the days of the Peleg, the earth was divided and people began to speak their own languages.
So
But
did you have specific physical evidence that you wanted to talk about?
yeah, there's, like I said in the last time, there's a lot of evidence to support it. One of which would be the sediment layers themselves, which line up, as well as the fossil evidence. The fossils in the sediment layers line up between the continents as well. Are you aware of that?
Sure. Yeah, there's basically both the sedimentary and the fossil distribution that spans across continents that are no longer connected. Yes.
So then the question would be how, if the sediments were deposited in the global flood, and how would you have a breakup if the breakup was before the sediments were deposited? How would the sediment layers be lining up between the continents along with the fossils?
Yeah, no, that's a great question. It really is, and that's one of the difficulties in working out the specific mechanisms and some of what I was trying to put forth in my proposed model. That there are some nuances like that are really difficult to nail down, and so I've personally kind of gone back and forth on the whole continent splitting up before or before the end of the flood, at the very end, or post-flood. I'll say very generically that the continents were probably still had a fair degree of quote unquote rapid motion after the 371 days that the Bible describes. Take that for what you want, because you could put that time anywhere in there. Go ahead.
So then you think the breakup was a continuation of the global flood?
Yes, I absolutely, because it's continuing to this day. I mean, that's why you have so many evolutionists that want to harp on this idea of plate tectonics and mountain ranges lifting up and so forth. And the way I describe it is that what you see today is residual motion of the original continental sprint.
Okay, so the 5 or 6 mega sequences were deposited in the global flood and then they broke up?
Well, no, that's a great point, because that absolutely does appear to be per exactly what you identify. If you've got this sedimentary and fossil distribution, it's the sedimentary distribution to me that makes the real point. But they're kind of tied together, so it's okay to say it either way. But because they do span across no longer connected continents, that pretty much tells you that the sediments were laid down first and then the continents broke up.
Yeah,
now,
that's what it seems like it would be the case. And there's another line of evidence too. Are you familiar with the glacial striations in India that go from south to north?
no, I got to think about that for a minute. Glacial striations in India. So what you're saying is, for example, you have a very large glacier and it's got a lot of debris in its underside, and it's basically made drag marks across the continent at some point.
Yes. But this is a point that evolutionists or people that believe in deep time would bring up, the fact that there's glacial striations. And had a little bit of a discussion with AI, and I said that the striations are on top of the sediments in India going south to north, and the AI corrected me and said, no, it's on top of the bedrock.
Well, okay, so no, that's an interesting point, but I don't know. Do you spend very much time on CMI's website?
I'm sorry, I'll be back. My phone died. So I want to go back and listen to what Donnie said, so he doesn't have to backtrack. I'll be back later.
So, Jungle,
I do. I mean, I listen to their videos. Yeah. In
okay,
fact,
so
I listen to just about everything. I listen to just about anything and everything from any creation mystery, as long as it's young Earth and not too
But
boring.
do you read any of their articles?
Well, I'm trying to get to the evidence of
Okay, well, no, that's fine. That's fine. I only want to point that out because they're a good source to help you with this idea of the glacial striations in India. So I'm not trying to comment one way or the other that I think they are or aren't this, because like I've already said, I'm not really familiar with them. But CMI points out in some of their technical articles, or even if they're popular level layman articles, they point this out that argument from evolutionists about glaciation and the striation, I can't remember what they call that, but anyway, that's a common argument, but it's loaded with a major fallacy in that you can actually get that exact same thing from basically uprooted trees that drag debris with them, like rocks and dirt and stuff like that. And so it's really hard to distinguish whether it's literally from a glacier or whether it's from vegetation dragging root systems. When an entire tree root system gets pulled up, it can absolutely pick up rocks and stuff with it and do the same thing that a glacier will do.
Yeah, well, regardless, it's pretty well known what's glacial markings and stuff and deposits, but it would have the problem in India. It would have to be some kind of movement that came up out of the ocean and went north in India. That's just not going to happen.
I mean, like I said, I don't think I could comment one way or the other. What I think it is, I'm just really saying that beware of some of those evolutionary arguments, because they're not necessarily rooted in a complete picture of how processes actually play out.
Yeah. So the complete picture is that it's not just India, it's South America,
right?
It's Africa, it's Australia,
right?
And India, which were all connected to the South Pole, Antarctica.
Right.
And they all have glacial striations going from south to north from when they were still connected to Antarctica after the global flood, on top of the sediments and fossils that were deposited first. And then
so that conversation kind of approaches the idea of where's the post-flood boundary, right?
No.
It
has nothing to do. The post-flood. The post-flood boundary. Yeah,
well, the point being that if it's, it sounds like what you're kind of saying is that perhaps the continents broke up after the flood, and you had an ice age. You built up a bunch of glaciation, and now you have some geological evidence left behind. In other words, if you see these glacial striations, it's a post-flood process, right?
Well, yeah, without getting too complicated, it's probably post flood.
Right, and that was my only point. If it's post flood, that means that that probably, and what you said, it's right on top of what looks like obvious flood sediments, right?
The bedrock. It's right on top of the bedrock, which is what AI said. The glacial striations zone.
I would be really careful with what you get out of AI, though. Really, really careful.
Right, but it was just funny to me because I was trying to convince it of a whole bunch of things. One of them being the breakup of the continents, and it corrected me.
Well, that's what I'm saying. I'm not saying it wasn't.
But the correction was funny because I didn't mean that the striations are on top of soil or sediment that's not from the global flood, or erosion. I meant the stuff that was there after the global flood, not accumulations on top of it.
You just have to know that AI is actually trained to tell you more popular opinion than it is fact.
I'm aware of that.
Yeah.
That's and I actually convinced AI of a bunch of things, but that's a side note.
Yeah. So back to your original question about how you perceive when the continents broke up. So AIG and guys like Andrew Snelling and some of those guys argue very strongly against post-flood continental split, and they're like extremely adamant about it. But the majority of their reasoning has to do with 2 points. One, that the biblical text is really just referring to a division in language, not a physical division of the earth. That's the one prong of their argument. The other prong is that they think that it would literally kill everybody that was alive post flood if that happened. I don't think that's a very good argument myself.
But the thing is like I wanted to mention before when you're talking about it, it's not so much how it happened, it's just evidence that it did happen.
Right.
And then the how that it happened could be explained if you investigate or look into it.
Sure.
Because
I will tell you now. Again, I'm not trying to have. I just don't have a firm opinion on whether the continental breakup happened post flood or not, except to say that there is one very plausible reason why it started before the flood ended, and yet you still have the sedimentary distribution that you talked about, and that is that in the process of the flood, because it is a full 1 year plus time span, you've got deposition only happens for a percentage of that time anyway, and then after deposition, you're pretty much at the end of the what they call the inundation phase, and now you're in the recessive stage where the waters are receding back off the continents. So the point then is that you can lay all of the sediments in the first, we'll say, 5 months. That's the 150-day time frame given in the Bible. If you lay all the sediments in the first 5 months and then split the continents after that, you still get the same look.
Yeah, but they seem to want to use the split up as being the mechanism for the global flood, for the deep fountains of the deep breaking up. But another problem is
you got to separate those two, though. You got to separate those two. The mechanism. Well, and to be perfectly clear, whenever I was giving my presentation, I was basically disagreeing with aspects of every one of the popular models, but agreeing with some aspects of every single one of them, essentially. And so if you're talking about the CPT model, for example, they believe that the accelerated nuclear decay started plate subduction, which I strongly disagree with. It's not even physically, it's not even a viable model at all. How people with PhDs in anything would sign off on that is honestly beyond me. I just don't get it. But so what they're talking about started the deal. You are correct in that sense. They want to say that accelerated radiometric decay started the splitting process and caused the flood to ensue afterwards. So that in that model, you're correct. But if you look at the hydroplate theory, Walt Brown's, again, I disagree with a lot of what he says in his book, but I do agree with some aspects of it. His is a little different, and this is a point I honestly just do not know about his model. And that is, so he says very much what I was saying, hydroplate, the hydroplate part of it, I'm agreeing with. What he says triggers it is very different, though. He says lunar tidal pumping basically pressurizes these water chambers under the continents and in the ocean floor, and over time so much pressure is built up that they finally rip apart, and that's what starts the flood. Now if you take that at face value, you would come to the same conclusion. Per your point, he's saying that ripping the continents apart was the beginning of the flood. I'm not saying any of that, and I'm agreeing with the part that the continents set on large water chambers. They ruptured and the continents started moving, but my mechanism is different, and the timing it can be very different depending on exactly how I try and synthesize it all. But what I'm saying is the starting mechanism was either meteorite impacts, which Michael Ord identified, or we just don't know, because the Bible says very specifically in I believe Genesis chapter 6, he says the Lord says, even I do bring a flood. In other words, it was no random happenstance. The Lord did it. He does not tell us what he used. It could have been, if it wasn't the meteorites, then we just don't know. But I'm assuming in my model, it was the meteorite. So the point then, sorry, I'll try and wrap this up real quick. The point then was that if the meteorites impact out in the ocean floor, breaking open water chambers, it starts the process of the fountains of the deep breaking up, but it doesn't necessarily imply that the continents start splitting right away. What I actually suggest in my personal model is that once the fountains break up and you start depressurizing all that water that's under the continents, it takes some time to get that water out, get enough pressure release before the continents actually gravitationally start collapsing and then breaking. So there is, in my model, there is a lag in time. It's not up front at the beginning of the flood.
Okay. In regard to the mechanism, I do see the possibility of a mechanism if you look at the evidence of what happened. For example, the evidence, according to the breakup after, was that all the continents were located at the South Pole, or all the landmass was located at the South Pole, of course, on to one side. And it had to have been because of the glaciers that formed, because the glaciers would have taken 100 years to form after the global flood. They wouldn't have happened right away. I mean, it wouldn't have happened during the flood for sure.
Right. No, that's a good point. And so are you suggesting then that the glaciers existed before the flood began?
No. I'm saying they couldn't have existed before the flood.
Okay.
So they had to have existed after the flood, which means that all the continents were connected at the South Pole to one side of the Earth, like they are still today, except they're more sprayed out. Which, because you're the engineer, right? So you should know about centrifugal force, right?
Sure, and that's a good point.
And you know about cement, right? You know about the guarantee for cement, what it's guaranteed for?
I'm not. No, I mean I'm not a civil engineer, but go ahead and tell me.
Well, it's basically the same thing. Cement has, people joke, they say it has two guarantees. It's guaranteed against theft and it's guaranteed to crack.
Right.
So what happened as the sediment layers were becoming cement, basically, they began to crack. But that alone might not have been enough. There could have been another cause, like you say, an asteroid or something, which could have been the cause of the global flood to begin with. And like you said, that God caused it to happen. Yes, he did, because God causes everything to happen, whether it was an asteroid, whether it was natural, whether it was physical, whatever. Every aspect of everything is caused at the hand of God. Everything's by God anyways. So when God says he gave people or confused the languages, yes, he confused the languages by way of whatever means. He still confused the languages because everything's by his hand anyway.
Right.
So when you have all this landmass at the South Pole, but not over the South Pole, to one side of the South Pole, and it's the cement, becoming concrete, basically forming rock and cracking. And it could have been another asteroid or something with some of the more evidence, because I'm not even getting into all the evidence yet. But just as far as the cause of the breakup of the continents, could you possibly see that the plates right after the globe, or 100 years after the globe, would have been somewhat still unstable, and suppose that an asteroid came and helped the continents to crack, the sediment layers to crack, and what would have happened in a spinning Earth is the centrifugal force would have caused all of the ones connected to the South Pole, if they broke apart, once they broke apart, which direction they would move would have to be north from the South Pole because of the centrifugal force.
Centrifugal force isn't a real force.
So South America went north from where it was, Africa went north from where it was, Australia went north from where it was, India went north from where it was, and as they went north, of course, they spread apart from each other.
So, yeah, I mean, you talk about centrifugal force. In reality, just to be perfectly honest, you can't really, it's virtually impossible to make a definitive statement of centrifugal force versus, and I'll tell you what my basic explanation is. And so it's not centrifugal force per se, but if I'm following the standard mainstream view on the rotation of the Earth and everything else, and I'm happy to do that. Generally, to your point, what you conclude, this is engineering 101, literally at the 101 level. You do this, and I've heard creationists argue against the idea of the change in the tilt of the Earth. Some creationists will argue that the tilt was always what it is. Some will argue that there was no significant wobble as a result of the flood. If you follow standard mainstream viewpoint on Earth's spin, you have to conclude that the Earth wobbled and the tilt probably changed. And to your point, centrifugal force did play a part in how the continent split.
It can't, because centrifugal force is not a real force.
That's irrelevant. You understand, but you understand.
No, it's completely irrelevant. You can't say something that it doesn't exist.
No,
you're plays a part. It makes no sense. You might mean centripetal, but not centrifugal.
You're being argumentative for the sake of being
Centrifugal.
If you're saying centrifugal, then centrifugal force is not a real force.
You're being argumentative for that. You understand that the basic concept is just like when you put water in a bucket and spin it around in circles. The water wants to go to the outside. Period.
That's,
It doesn't
that's
matter.
Just a matter. That's just a matter of inertia, but that's not centrifugal force.
It doesn't. Irrelevant. You get the point of the mechanism he's describing.
It's completely irrelevant. How is something that doesn't exist being is that not irrelevant?
Carlos, you're saying if the Earth is spinning and the continents break apart, nothing is supposed to make the continents follow the rotation momentum?
No, I'm not.
That's all he's describing. If he's using words that don't mean technically what you think they should.
No, it's a big difference. It's a big difference here because centrifugal force would be. He's trying to describe the direction in which these bodies will move based off of the spin. But you're saying centrifugal force is not a real force, so it's not really going to play a part.
That's not relevant. There
Carlos, you're a little bit muffled. I'm wondering if there's I can turn up your volume on my end, but could it be your speaker on your phone? Maybe you get a.
But as far as the speed of the Earth, let me check my
Jungle. I will say this though: the one problem with a quote unquote centrifugal force cause in the separation of the continents is that they split away from a common. It's the Mid-Atlantic Ridge. They split away from a common seam point between them, and so if the Earth is spinning from east to west, then they should both move the same direction if it's strictly this centrifugal force idea.
Well, they did go the same direction. They all went north, but
no, that's the problem. Is they didn't go strictly north. The U.S. if you go back when I put this up during that presentation, the Western Hemisphere went northeast.
I know what you're saying. They split apart from each other, and you can see it in the Mid-Atlantic Ridge.
Right, but the
Northern
Eastern Hemisphere went northeast.
Was connected to the east coast of the United States,
right?
And Southern Africa was connected to South America.
Right. So the point though is that the Eastern Hemisphere went north to northeast, and the Western Hemisphere went north to northwest. And if it was purely the result of centrifugal force, then they should both go the same direction.
No, they would go north. They all went north. The centrifugal force would cause them to go north. And that's what they all did. They all went north. As they did, they separated from each other, including India and Australia. But Australia broke apart from Asia. Asia just kept on going. And I could get into more of the other evidence, and that's unexplained tsunamis and burials of all kinds of animals in the Arctic and Siberia, and entire ecosystems were
Gentlemen,
buried.
I think this has been a great back and forth. I think I'm going to start winding it down and try and wrap it up right at the 6.5 hour mark. And so that's in about nine minutes. Hard to believe we've been going 6.5 hours. This has been great. T-Rock and Jungle Jargon
I couldn't
really
imagine being in your position and being able to give up 6 hours of my life every week to host this.
I'm just barely.
Hey, these are always a blast. I'm glad T-Rock and JJ
this is awesome.
We definitely want you to join more, Carlos. So I guess in the last few minutes here, I did want to make sure, Carlos, that you had a chance to. Have you tested to see why you might be muffled? Because you're coming in great earlier.
I think so far it's my charger. I'm charging my phone, and when I took my charger out, I was coming in clear, and that's when my phone died because I forgot I took my charger out.
That's right. If you're charging it, that's probably what it is.
Like, watch now. How do I sound now? Do I sound any better?
Oh yeah, perfect.
Way better. I just took my charger out. Yep. Science.
Okay. Science. There you go. You figured it out. I'm impressed. You made a testable prediction, and it came true. Now I just hear an echo from me. So let me see if that's. Is your echo cancellation off?
That might just be a problem with my mic. I'm gonna have to go get a new mic so that to make sure this doesn't happen.
Are you hearing an echo too, T-Rock?
I hear the echo. It sounds like somebody's got two different screens open with the program on it.
I hear the echo.
Let's see. Is it better now? Well,
Yeah.
Carlos muted. Okay. Well, I guess
Yeah.
Carl. Oh no, I think we're good.
Let's do some tests. Let's see if it's me. I'm gonna mute myself now.
No, I think whatever we did fixed it, so I don't hear a mute anymore, which is good. So
Oh,
hopefully
I
that
also
solved it.
unplugged and replugged my headphones.
So I guess in a nutshell, and I'll give you the chance to respond, is going back to the Eve argument. And then I'd also like to wrap it up with something you said on fixation. So Eve, we have our sequence. You would argue, if you were to look at the sequence when we remove all the rare deviants, I'm not sure if you heard my illustration, but if I handed out 10 manuscripts to 10 different people and said, copy this out, each of you. Well, each person that copies it is going to have their own unique mistakes, right? Each copy is not going to be identical. And so we can look through each copy and we can figure out which ones are mistakes, which ones are the rare deviants. We can remove those from the equation and we can get a pretty close approximation to what the original manuscript is. And so they've done that with mitochondrial DNA. And so we have a very good idea into what Eve's mitochondrial DNA sequence looked like. Okay. And so the point is, where do you get the idea that this woman, of whom we've all descended from, belonged to a larger population and even has previous ancestors?
Well, simply just based off of the way that the mitochondrial Eve is defined. Frankly, again, going back to the notion of it being that female ancestor of which we can furthest tie every living person to. And again, with also the notion that can change as people die and other people are born. So it's just simply the case of acknowledge all you're doing really, I would say, is just acknowledging that aspect of the definition, where is that, yeah, there's going to be a point where we no longer can connect everybody that's living past this person. That doesn't mean that there weren't people past this person. So to give you an example, and I'll say, supposing this is the case, I'll just say, let's say perhaps I'm wrong, but so supposing that this is the case, at some point in the future, there should be a point when the furthest we can go back is somebody living today. Does that mean that the person that they can trace it back to today didn't have ancestors? No, it just means that we can't trace back past that person.
Right. But so, for example, here on this mitochondrial phylogeny, the issue that you're going to have is this represents worldwide mitochondrial DNA. So it's not like, well, we're just looking at the HVR haplogroup here and these branches, which represent DNA differences or mutations. They go back to a common ancestor here. So all these people here have a common ancestor that goes back here. But no, we're looking at worldwide mitochondrial DNA, and all haplogroups, meaning all people groups worldwide, European people, Asian people, Australian people, African people, they all go back to a single woman. And to infer that that woman had previous ancestors is without justification, because again, we have very little diversity in the mitochondrial DNA. There's only about 25 differences on average separating any two people. Okay. And the mutation rate's fast. It's about 0.5 per generation in the mitochondrial DNA. Do the math. How long does it take to accumulate that much DNA diversity? It's trivial. We could easily get that in a couple hundred generations. How do you take that level of diversity back hundreds of thousands of years, 200,000 years, Carlos?
I personally can't say, because again, I don't delve into that area, but I would just again stress that just because we can't go past that one individual does not mean that there weren't more individuals past that.
But then it also doesn't, let me say this, but then it also doesn't mean that there are.
Well, no, but it's more likely, that's true, I would grant that, but it's more likely that there are, because from what we see, people come about from people.
No,
Donny,
because
can you clar-
no,
Donny,
guys,
can you
I'm
clarify?
gonna refute this because I've refuted this in my book. Here's the problem: the only way, and this is how evolutionary scientists, and I've debated many, how they explain this is through coalescence. That mathematically you're just bound to land on a single ancestor of whom we've all descended, right? But the problem is, Carlos, and you can look up coalescence theory. Coalescence relies on a number of assumptions, but one major one is what's called random mating. Okay. But the problem historically is there has not been random mating. What I mean by that is historically, people have existed in tribes, they've been isolated and separated from each other. And so if you have
Yeah, I would agree.
group,
That goes.
right.
Sorry, that kind of ties into my point earlier about what I was saying.
Yeah. And so if you
People
have
are intelligence. Yeah.
Yeah. So if you have people, right. I remember you talking about that earlier. So if you have people in Africa and people in Australia, or even within Africa, Africa's massive. Let's say you have a tribe, in this spot geographically in Africa, and then another spot, hundreds of, far away from that tribe. And within those tribes, you're getting interbreeding, intermarrying. Well, then we shouldn't have a single mitochondrial DNA ancestor. We should actually have multiple mitochondrial DNA lines, because that would be multiple coalesced mitochondrial DNA sequences. And so the
Genghis Khan.
Genghis Khan, yes, a lot of people
So my
today
point.
go
My
back to
point.
Genghis Khan, but we have evidence for people before Genghis Khan, because Genghis Khan would fall within this
Well,
Y
no,
chromosome tree.
I'm sorry. The that was kind of me just doing a quick quip. But the point I'm trying to illustrate by saying Genghis Khan is that also tying into intelligence, we forget a lot of the things that we are capable of and how the things that we as humans do can influence the things that happen. So, especially with our evolutionary line. So I was going to make this clip actually earlier when you were talking about how there was very little variation, and I was going to joke in and just say Genghis Khan. And the point I was going to make there is that, you would expect there to be less variation than what you would normally consider mathematically. This is why I was arguing earlier against, you could say theoretically, if this is the math, but circumstantially that is not the case, because we have things like people like Genghis Khan, people like Hitler, where we have genocides where a lot of people are killed. We kill each other, so we're affecting the variation just in the way that we do things in our own day-to-day lives. It's not just simply the case that, like when I say environmental pressures, but it's more so just selection pressures in general, which ranges from things that we do to each other like that on large scales, wars where we're wiping out large masses of population, to even simple things like how we choose our mate, which, as you said, I'm saying, we're like in tribes, we choose people that are similar to us, which is going to limit the variation if we're choosing people that are similar to us.
But my problem is, how does that, and you're starting to be muffled again. I wonder if you plugged
I did. I did.
And you probably have, no worries. You probably have no choice because it's probably dying soon, but we'll wrap this up soon. So my issue is, and we can further this discussion at a later date, is I don't think it answers the objection I had, because again, we have evidence for a single mitochondrial DNA ancestor that we've all descended from. But if evolution was true, that should not be true. We should find multiple mitochondrial DNA lines. We should share some of those with the chimpanzee.
Well, the point that I was making to, again, why we may not necessarily find that is because of people like Genghis Khan. It could be the case that there was, but they got killed off. Something may have happened to them.
Carlos, let me ask Donny something real quick. Donny, can you clarify for us real quick two real important points? One, that the evolutionists also have a bottleneck in their proposed history, but if I'm not mistaken, if I'm mistaken on that, you can correct that. But I think they do, and if so, how long ago? And then point number two that Carlos is trying to make is irrelevant, because Donny, you can elucidate this. But the graph that you showed actually implies a genetic clock that predates Genghis Khan and any of the historic stuff that Carlos is talking about. So, in other words, all that historic stuff that he's throwing out there.
I wasn't specific. I'm not
completely
hyper
irrelevant.
focusing on Genghis Khan. I'm saying I was just referencing him because he's a well-known example, and we understand how his actions have implicated
But
things.
all the
So
historic
the point was that this could have happened plenty of times. You can look at how chimpanzees interact with each other. They go and they kill each other, take over each other's things. That affects how their diversity is going, because they're literally destroying parts
Carlos,
of
look what you
the
have to believe.
population.
Carlos, it comes down to the law of parsimony. Look what you have to believe. Okay, so first I want to point this out. Yes, you can pick your haplogroup, right? You've got, again, your HVR haplogroup, most common in Europe, if I'm not mistaken. All of these branches representing DNA differences in people groups. This is basically random mutations over time in people groups. All of these branches do go back to a common ancestor. And so this person is the common ancestor to all of these. But again, we have worldwide representation. And so where you have common ancestors of people groups and haplogroups, they go back to other common ancestors. But the point is, every single haplogroup worldwide goes back to a single woman. In terms of Y chromosomal DNA, every single haplogroup, every single group goes back to a single man. And so with the evolutionist model, the problem you have is you have to believe, you want us to believe that, okay, in your out of Africa model, you have tribes spread out, okay, where you've got non-random mating. You don't have random mating. People are intermarrying and intermingling and inbreeding within their specific tribes. So you want us to believe that one specific tribe made it and every other tribe died off. And so their lineages are lost, right? Is that what you're saying? And then the one lineage that, that lucky woman, basically, she was able to pass on her DNA. And is that essentially what you're saying, is all the other tribes worldwide would have been killed off, but only one made it?
Not essentially. It's not essentially that it would be one made it. It's that whatever made it is left from all the ones that already died off. Like it's. It's not that hard. It's not that hard to fathom. I don't think it's that hard to fathom that tribes have engaged in warfare, killed each other, and then subjugated other members of other tribes, namely the women, and taken those bits of the tribe and essentially genetically just put them into the gene pool. They just interbred them, just bred them out. I don't think that's very far. That's very far fetched. I mean, we literally see it all the time.
That would diversify the tribe, because it's not the women that die, it's the men that die. In the mitochondrial DNA, you'd have a diversity of women.
Not necessarily, because if you're saying that after a certain point we're going to keep losing diversity, then if they just keep breeding in those populations, then it's just going to do as you said. They're just going to start losing diversity.
But remember,
at which point it wouldn't matter, because that diversity that's lost isn't relevant to whether or not we're reproducing.
I've studied genetics. It's not the women's mitochondrial that gets killed off. It's the Y chromosome that gets killed off.
Of course, because we kill the men.
Are you saying,
Right.
Jungle, because the men who go to war and lead the way, they get killed off?
Yeah.
The women get left behind. It's harder to get a single mitochondria.
Well, not just they get left behind. So sometimes they go in there and they get taken.
And then they intermingle with the group that they get taken into.
Yeah.
And
they
then you
get taken into that, and it may start off with a lot of diversity, but then as you were saying, it would probably go down.
I think,
but at that point, it's just not it doesn't matter.
I think Donnie's whole point's very evident here, though. Carlos doesn't seem to understand the genetic implications of that scenario. Should be what we don't see is you should genetically be able to discern multiple mitochondrial lines existing at the same time.
I understand that, but what you're not seeing is what you're trying to wave off is the possibility that we have created a circumstance in our interactions where that is not possible for us to find just because of how we've destroyed evidence. We've nuked places, for God's
Yeah, but
sake.
Carlos,
We've nuked places. We've
Carlos,
caused
you can't go and say,
irrevocable damage to places that you know what I'm saying? Like,
You haven't explained how, though.
Yeah, that's
Carlos,
exactly
you
the
can't
point
go
you're
and
missing,
say.
Carlos.
I want to say this, Carlos. You can't then go and say when somebody presents. I'm just going to turn your mics.
yeah, I'm mute myself when I'm talking.
No, you're doing good. Just suddenly now it's really loud. I don't know why, but you can't really go around saying to the mitochondrial DNA data that suggests we've all descended from one woman. You can't just assert, oh, but that woman belonged to a population and she had previous ancestors. You've shown that, well, maybe this or maybe that, or perhaps this is the reason. I mean, this is not empirical. This is actually storytelling, and basic coalescent theory tells us that naturally we should find multiple mitochondrial DNA lines. But let's just say, for sake of argument, what you're saying is true. Okay. And this occurred somewhere between 70,000 and 200,000 years ago. Well, notice this again that I've shown on this tree. And then you can look at the data itself. Okay. Where we've got the Eve consensus sequence. It demonstrates that there's incredibly low, there it is, incredibly low variation. So if we've been evolving, adding mutations every generation to our genomes, mitochondrial DNA in terms of women, Y chromosome with men, then we should have far more than just, what does this paper say? On average, we only have 21 differences separating any two people. That's trivial. That's this data is what the biblical model would predict. One woman, one man, low variation. That's it. That's biblical expectations. But the evolutionists, they never predicted it. All they have in response are stories and rescue devices and a whole lot of post hoc, ad hoc rationalization.
Well, no, I would have to push back. My apologies. I would have to push back with sort of like an offshoot of how you guys tend to respond to us in terms of I often hear like Kalam arguments. I know nobody's bringing those up right now, but like so I would say you're assuming that there's no other people before her, and you can say that I have no position to assume there were. I would disagree on the basis that, again, we know people come from people. In the same way you guys would tend to say something can't come from nothing. I would tend to say people don't just come from nowhere. And you could say people come from God, but that's a separate thing you'd have to evidence. As far as we know, it's more likely to think of the two options that she didn't have ancestors and she did have ancestors. It is more likely to say that she had ancestors because we know people have ancestors.
I would disagree with that because of basic coalescent theory, what we know about DNA variation, what we know about the mutation rates, and the fact that none of this was predicted from the evolutionary model. And if you want to believe, okay, we go back to previous ancestors and eventually we come to what? Our common ancestor with the chimpanzee, but we've already gone into the fact that, okay, let's compare them. Let's bring in the Y chromosome data from chimpanzees. Let's bring in chimpanzee mitochondrial DNA, and they're nothing alike. So everything points in terms of parsimony to the separate ancestry model. And I really encourage you, Carlos, and anybody else, look into that mitochondrial Eve consensus sequence paper. And you know what? You know who published that paper?
For sure, I'm gonna drop you my email, by the way, so you can send me again. I would really like a list. You can include this in a list of genetic topics you think I should look into, so I can get more engaged in these arguments from a genetic standpoint.
Well, instead
paper, of my typical just analysis.
No, this is good. Carlos, this has been good. This has been fun. You've really engaged with these highly technical arguments, and I do appreciate that. And so I really hope that you decide to join future open mics as we engage all the time. We bring people with different views into
I really appreciate you guys for having me.
Absolutely. So I hope you become a regular. I think we're going to save any further discussion on genetic entropy for, because we are doing another open mic next next Thursday on the 12th. So Carlos, hopefully you're free for that. You as well, T-Rock, and everybody else. Gentlemen, I actually think this is the perfect place to wrap it up. I think if we get on another topic, we'll end up going for 10 hours. So everybody, it's been great. To everybody who's tuned in, thank you so much for tuning in. And stay tuned. We'll be back here on Saturday. To our critics and non-critics, this has been another successful night of Debate Dojo on SFT. God bless all.
Good night, guys.